Did you know that data science is one of the highest paying careers in tech today? Whether it's Google, Amazon, Microsoft, Netflix, startups, or even banks and hospitals, every organization is looking for professionals who can work with data. As a result, data scientists, data analysts, and AI engineers are among the most in demand and well paid professionals in the industry. But there is one skill that every data science professional must master first: Python. That's why we have created this complete data science full course for beginners. This isn't just another Python tutorial, this is a structured data science course that starts from the fundamentals and prepares you for advanced data science concepts. Since it's a complete curriculum, we have divided it into two parts. In part 1, you'll learn Python from scratch, including data structures, object-oriented programming, file handling, and NumPy with plenty of hands-on coding exercises. In part 2, we'll cover pandas, data analysis, statistics for data science, hypothesis testing, probability, and probability distributions, the core concepts that form the foundation of data science and machine learning. And here's the best part. After completing both parts and passing the assessment test, you'll receive a course completion certificate. You'll find the link to apply for certificate in the video description and the pinned comment. So if you are serious about starting a career in data science, this course is the perfect place to begin. Let's get started with Data Science Full Course Part 1.
Python, and in this program, in this training program, I'll be telling you exactly how you can communicate with the machine by writing instructions in Python language, right? So it's like that. Now Python is, what is Python here? It's a small introduction here, right? And Python is basically the interpreted language. It's interactive, it's object-oriented programming language. So I'll just tell you exactly what does it means, right? So I'll just put more focus on the foundation part, right? Because it is your first time. So I'll just push more focus on the foundation part, right? And let's proceed further. So it says Python is an interpreted language. Now, what does it mean? I would like to show you something, right? Oops. I would like to show you here, right? Okay. Let's take an example of HTML, right? So when you execute HTML, right? I hope you have some idea about HTML, right? So when you execute HTML, the HTML runs directly, right? So the HTML runs directly. So this type of execution is called, interpreted, right? So here I'm talking about the interpretation. What is interpretation? The HTML code runs directly. So here, when we talk about Java part, it doesn't matter whether you know Java or not, but I want to tell you that when you run a Java code, it is basically converted into a intermediate code, which is a dot class kind of thing, and then you get the output or you get the response from the system. So in these two cases, what you need to observe is that here the code is directly getting executed without any intermediate conversion. Here in Java, the code gets converted into some intermediate code, and then you get the output, right? So there is it's a two-stage process, and it's simply code into output. So when a code directly executes, right? So without any intermediate file, so that is interpretation. So Python is interpreted, but I want to tell you, right? Python is a versatile language because it supports both compiled and interpreted execution, right? So you can compile a Python program or you can interpret it also directly. So it is versatile. Second, it is interactive. Now, what do you mean by interactive? Interactive basically means, you have a shell, right? I'll be showing you, okay, it's not available in my system, right? I'll be using Anaconda for that. I'll be showing you exactly what is Anaconda, and in Anaconda, I'll be telling you about what is interactive, like that. Then I'll be talking about the object-oriented part here. What is object-oriented? Basically, object-oriented is something that lets a developer build real-life applications, right? So you must have heard of C programming language, right? So C is something which is also a language, and Python is also a language. So what is the difference between C and Python? When you are a C developer, you cannot represent real life entities, right, in programming. So let's take an example of ATM, right? So ATM is a very beautiful example. We have ATM in real world, right? So how are you going to represent the functioning of ATM in programming. So to represent something which is real in programming, you need a feature which is called object oriented or being object oriented. So when somebody says Python is object oriented, that basically means he's saying that you can build real world applications or real life applications, or in other words, you can represent a real life entities such as whatever it is, right? Whether it is a manager, whether it is a bank, whether it is a teacher, whether it is a smartphone or ATM, right? Or a government, whatever. So you can express any entity in real life sense in a language which is object oriented, right? So if something is not object oriented, you cannot express that thing. So this basically is the difference between being object oriented and being procedural, right? We call it procedural. All right. So I hope you understood this part. I'll just proceed further. Now, there is a question, right? Why we need to learn Python, right? Why it is important? Why we cannot learn any other language? Why not Java, or why not C++, or why not the other things, right? Why we are sticking at Python? Now, there are certain reasons here that I have listed, right? So I'm just going to tell you the reasons exactly why you need to learn Python. So the first reason that I'm going to tell you is Python is multi-purpose. Now, what do you mean by multi-purpose? I'll tell you. Let's take an example of PHP, right? So PHP is one of the language which is very popular in the market, and but the problem with PHP is that you can use PHP for building websites only, right? So you cannot use PHP for building, let's say, Windows applications, right? So that PHP is not multi-purpose. So here we have Python, right? Python is a beautiful language. You can use Python for building Windows applications. You can use Python for building web applications. You can use Python for building embedded applications, right? So they run on Raspberry Pi or some IoT kind of devices. So it's beautiful, right? So one language, multiple solutions. It's like that. Now, the second reason, right? The second reason why Python is beautiful, or why Python is important, and that is being object oriented, right? So I really encourage, I really promote, and I really push this topic, object orientation, because this is the topic that has brought revolution in the software development, life cycle, you can say, or software development domain. Because when this feature was introduced, the developers could build the applications, and the applications which behave in a real world way. Then the third feature is interpreted, as I've already discussed. Interpreted is basically, you can simply directly get the output from the code without any intermediate conversion, right? So it's like that. Then in the fourth point, what we have here, we have a focus on readability and productivity. I'm telling you, right? So when you are lost in 10,000 lines of code, so it becomes really hard to read the code, or to differentiate between the sections. Just to give you an idea, every day, I'm talking about the Linux kernel, right? Linux kernel, right? Kernel is the main software that basically drives the Linux operating system. So every day, approximately 3,000 lines of code is contributed in the same Linux kernel. So just imagine, every day you're getting 3,000 lines of code from 1,000 developers at least, right? So when you have this kind of code push in your ecosystem, in your software ecosystem, you really want your codes to look more readable. And when it is more readable, it leads to more productivity, because it becomes easy to read the code. So it is very important. Okay, if you have done any C++ or Java programming, you can see the mess that the curly brackets or the flower brackets create, because there are a lot of brackets which are tangling around, so it becomes really difficult. Then in the fifth point, what we have here, we have batteries included. So what does batteries included basically means here? It basically means the libraries, right? Here I'm talking about the libraries. So I'll just take the reference from C++ or the Java here, or R even. In R, you have modules, right? So used for, doing various operations such as math modules, or, math libraries, or graph libraries like that. Like rplot you have for plotting the graphs. So in Java you have packages. If you remember, in packages are basically the libraries which gives you the functionality to perform activities or operations. In C++ mainly you have header files for various operations such as math or such as strings for string operations. So in Python we call it modules, right? So we have modules here. So let's say if you are doing any activity such as, let's say, if you're plotting a graph, right? So for that, we have modules in Python such as matplotlib or cborn. I'm just giving some technical jargons here. Don't get scared. We have a lot of modules here. We have modules for mathematical computations. We have modules for string manipulation. We have modules for, let's say, data analytics. We have modules for machine learning. We have modules for graph plotting. We have modules for website development. We have modules for artificial intelligence, right? So for various domains, we have modules here. And as I've given you a number, 98,524 plus. This is the count of modules that we have in Python. So the maximum number of modules, the more functionality you have available with. Now you can think of that, why Python is unrestricted programming language kind of thing. Then we have something called interactive shell. What is it? I'm going to show you the interactive shell in Anaconda part. Just allow me to move to the Anaconda thing. Now the final part is that Python is cross-platform. So when somebody says a language is cross-platform, that basically means the operating system, right? Operating system independent, right? So basically, Python can run on multiple operating systems, whether it is a Windows OS or whether it is a Mac OS or whether it is a Linux OS. So Python can run on multiple operating systems. Now, guys, see, the point is that if you think as per the business perspective, what does cross-platform basically helps, or where is the benefit of being cross-platform? So let's say if I am developing a product for my clients, right? Let's say a commercial product that I want to, just push into the market, and I want to, earn some revenue out of it. I want that product to execute on as many customers as much it can. So let's say, just to give an example, let's say .NET, right? .NET is one of the technology that we have in the market. So that is mostly Windows competitive or Windows compatible, right? So if I stick to .NET mostly, so that product will be available for Windows users, right? Because .NET is not fully compatible with Linux or Mac. So in that case, my product selling will be limited. So if I go with a technology which is unrestricted of OS, so I can sell the same product to the multiple users of different operating systems. So that's how it will lead to multiple sales, you can say like that. So that's how it's a commercial benefit. Okay, guys, everyone. So this slide answers, a lot of questions here, like how R is different from Python, or how Python is different from R. So, here I've given a lot of domains on the left side, and on the right side we have the solutions in Python, right? So whether you're interested in web development, we have solutions in Python. If you're interested in GUI development, we have solutions in Python. If you're interested in scientific or software or system administration, we have solutions, right? So yes, this course covers mostly all the important topics related to fundamentals of Python. I like to say it like that, and I'll try my best to go in depth as much as I can. All right, I'll just proceed further. Hope you have understood the modules here, right? I'm not going to read all the modules because it's useless to read. I'm just going to make you understand exactly the solutions we have in Python. It's like that. I'm sure you've not heard of various solutions like this in R, like that. I'm not degrading R. R is beautiful, but I love Python like that. Thank you. Well, just to convince you more, right? Just to convince you more, who uses Python, right? So here there are some of the big giants in the market, in the world, who are using Python for their computing, for their extensive computing, for getting their business run, right? So we have Mozilla, Google, Yahoo, IBM, NASA, and a lot of companies, right? So if these companies are convinced with Python, why not we? Like that. Okay, let's proceed further. Oh, wow. So here we have something, right? So we have a practical lab, and so that is a sound hiss that comes from Python generally. Yeah. Sunil, we can do predictive modeling in Python as well, right? For that, we have a beautiful library in Python called scikit-learn. Sometimes we call it sklearn as well. All right, everyone, participants, right? So here I'm proceeding further with the environment setup. I'm going to tell you exactly how to push the Python into your systems, right? So I'll try to be in detail as much as I can. Yes. So here we have environment setup. It was really hard for me to learn the spelling of environment in my initial days, right? But I can do it now. Okay, so here we're talking about environment setup, right? Or in simple words, software installation, right? So here we're talking software installation part here, right? You can install core Python, and you can install a distribution here, right? So just giving you a small overview here. So the Python is available in two forms here, right? So there's something called core Python, and there's something called distribution, right? So what is the difference in these two versions here? I'll tell you, right? So when we say core Python, it will install standard Python. When I say standard Python, it basically means some basic libraries, right? So such as for doing the math, for doing the string operations, for simply input output, you will get the basic libraries. You will not get specialized libraries, right? So such as you will not get sklearn for, let's say, machine learning, right? And you will not get, let's say, Seaborn for graph plotting kind of thing, isn't it? So you will not get these libraries in your core standard installation. But if you go with a distribution, right? When I say distribution is Python plus all major popular libraries. This I hope this should clear the difference between the core Python and the distribution. So when somebody says distribution, that basically means is giving you a box full of all the sweets in it like that, right? So here Anaconda is a distribution. So when I say Anaconda is a distribution, this basically means it includes Python plus all the major popular libraries, right? So I'm just going to show you exactly how you can get, uh, you know, Anaconda thing. And there's a question from Keshava. He says that is it not possible to add the modules as and when it is required? Like, yes, Keshava, obviously and absolutely it is possible, right? And all the time it is possible. Generally, it depends, right? So it depends in what approach, right? Using what kind of approach you want to proceed. So everything is possible as such. Yeah, we can, right? So there is a command for that, Keshava, right? Python -mpip install, right? Let's say sklearn. This is the kind of command that we have in Python for installing the specific libraries, right? Like that. Just giving you the idea, right? So don't get confused, everyone. Don't get confused. So I'll just show you the practical things here, right? So I'll just go to python.org here. Right? So this is the beautiful site we have here. So this is for, all right, I'll just try to be core Python, right? So here we're talking about the core Python. If you're interested in installing core Python, you can simply go to python.org, and from the download section, you can download the 3.7.2 version, right? So this is the source, right, from where you get the Python thing. But in this program, in this course, I think it is not encouraged to, do this step. But just for the added information, I just told you this thing, right? All right, so sorry, we are not installing. All right, so we are going with the distribution, right? We are going with the distribution. Hello, distribution, right? Jyoti says, do we require any system specifications to download and use it? Jyoti, I'll suggest that you must have at least 2 GB of RAM. That is the minimum that is required. Apart from that, generally in 2018, we are supposed to have at least some dual cores or i3 processors, right? So do not practice this thing in Pentium 4 or 3. It's really dangerous. Sometimes, you get kind of nausea. I hope that that answers your question, Jyoti. Anaconda.com. So here, this is the website anaconda.com. So I'm going to go here and I'm going to just show you the magic behind this website. So I hope everybody is clear with the distribution part, right? So guys, my question to all of you: do you understand what is a distribution? Type in the chat window. Thank you, Suman. Thank you, Asim. Thank you, Sanjay. Thank you, NJ. There was a question why it has a snake in it. I'll ask. Right. Thank you, thank you, thank you, thank you, everyone. It's not cloud-based, Rahul. It's offline right now. It's offline. Yeah, thank you. I can see a lot of answers here. Everybody is active. Mahabir, I'll try. You'll get the recorded session, Mahabir, right? All right. Fine. That was humorous, Sujit. Beautiful. So Raghu says, is it IDE? Yes, I'll say like that. It contains a lot of IDEs, right? So Raghu, Anaconda contains IDEs such as Jupyter, such as Spider, right? So we have some collections of IDE within the Anaconda. I'm going to show you. Thank you, Saurabh. That is beautiful. Thank you. IDE stands for Integrated Development Environment. Abhishek Yadav, that is your question. What is IDE? IDE stands for Integrated Development Environment. It's basically an IDE contains a code editor plus compiler, and some more functionalities, right? So such as Turbo C in your academic days, or NetBeans or Eclipse, right? Or Jupyter in Python, or there are a lot of IDEs which are available. Yeah, Rajesh. Yeah, recently it is not recent. It has been a long time. They have been publishing a lot of webinars on their Python distribution. So yeah, Rajesh, that is a customized, Python distribution from Intel, which is optimized for Intel hardware, like that. Sarath, there is a question from Sarath, why we are considering Jupyter for this course, why not PyCharm or other IDs? Sarath, I would like to answer this question this way, because this is a training session, and in training sessions, I'm going to use a lot of small programs in terms of code snippets. So those are easy to view and understand in Jupyter. Yes, definitely PyCharm is really beautiful, and it is it is one of the best IDE we have available for Python. But the difference is that PyCharm is mostly used for full-fledged project development, right? So if you're developing a full-fledged project, in that case, you're not supposed to work on Jupyter. You're supposed to work on PyCharm-like softwares. But for my viewers who are beginners, I strongly recommend and suggest to work on Jupyter. All right. Yes, Pawan, I'll ask the grad team to share the PPTs as well. Yes, comparatively, Python is faster. NJ, you say that why there are too many IDEs. So basically, it's like saying why there are too many Android smartphones. Why not one? It's a competition which is going on in the market. The best IDE for Python is obviously PyCharm from JetBrains, right? So they have very good IDE available. I'm going to show you, Bharti, what is Jupyter. In industry, we mostly use PyCharm in most cases. It depends. At the student level, people use Sublime, people use VS Code, sometimes Notepad++. Yeah, thank you. Okay, I'm done with this, right? I'm just proceeding, right? I'll just go to the download section here. Where are you? Download here. It is download here at the top right corner, right? So I'll just go to this section here and the corner distribution. And hey guys, look at this beautiful. It's not beautiful. It's black and white. It's colorless. Okay, let it be. Okay, you can see some, some fancy titles here, some technical jargons here, such as Jupyter, Spider, NumPy, SciPy, Numba, Pandas, Dask, OK, HoloView, and a lot of things. So see, this Anaconda is contains all these tools and technologies, right? So this is something why we call it a distribution, right? Like that. Okay, so here we have two versions available for Anaconda. We have the Python 3.7 version and we have Python 2.7 version. I will be going with the Python 3.7 version. Right? So 2.7, there is a slight difference in 2.7 and 3.7 in terms of code writing. Right? So there is a slight syntactical change somewhere. Right? So 3.7 is something that I would like to go with, and I will suggest to go with the 64-bit graphical installer, right? And yeah, there is a Mac. Okay, it's a Mac one, right? So you can see here, right? It's available for Mac, Windows, and Linux. So you can go with the OS according to your system architecture. Pawan, there are not as such major differences, but slightly code tweaks, right? But it leads to instability, right? Guys, remember, when you're working on two different versions, like 3.7, 2.7, 2.7 and 3.7, there will be code instability, right? So there will be a stability issue in the codes. Yeah, mostly 2.0 is ruling the market because it is old. It was available earlier. 3.7 is compared to newer, and it is being adopted at a very rapid pace. All right. So guys, you'll be downloading the setup from here, right? And once you do that, I'm going to do a magic, and suddenly you'll get files like this, right? Yeah, you'll be downloading the 3.7 version, right? It's not backward as such. It's not mostly backward compatible. You may face issues, Nikhil. So guys, I have two Anaconda here, one for 32-bit and 64-bit, and one for 32-bit kind of thing. So mostly you all are going to have 64-bit version in your systems. So download the 64-bit version, right? Pawan, in some cases we require the code change, right, between the 3.7 and 2.7. Not in all the cases, but generally it leads to error, right? When you get yourself involved in this kind of versioning thing. So guys, this is the setup for Anaconda, and it's really easy to go with the graphical installer because you just need to press next. You need to press I agree, right? It's like we don't have choice here. Obviously, we'll be click on I agree. Simply click on next, and simply click on install, right? So this is how we do it, right? So when you click on install, you're going to see a magical progress bar, going further from left to right. So as it completes its journey, the Anaconda will be installed in your system. So I just canceled the installation because I have it already installed. So you can see here, once the Anaconda is installed, it is Anaconda Navigator we have here, right? So this is something that you're going to look for after, after installing the Anaconda thing. So I'll just click on that, and here in the middle of the desktop, you will see a beautiful splash screen. So I'm just taking a pause of 10 seconds here, right? All right. Are 10 seconds over? I think. So I already have Anaconda installed in my system. How do I know which version you have? I'll just tell you that thing. That's a beautiful thing. Okay, everyone. This is the Anaconda Navigator, right? And here you are seeing some tools or some products for which are already built in within Anaconda. Even you have R Studio here, right? So I'm sure, very much sure that you remember the R part. So you used to code in R Studio, so that is available here. Apart from that, I would like you to take to the environment part here. And when I take you to the environment part, can you see this first column here, this name column? These are the libraries that you get as a gift with this Anaconda. So we can see that we have a lot of libraries which are available here, right? Shwetank, just take the update. It's free, right? Just take the update. Okay. So we have a lot of libraries here, right? So I just recommend you to have a tour of this library in case if you want. I'll just proceed further. So here I'm going to home part, right? So this is home. And for the Python programming, right? Everyone, for the Python programming, I'm going to use this one, right? Jupyter. Jupyter is one of the beautiful web-based IDE we have available. And for the training and academic purposes, Jupyter is the best IDE that you can use, right? And there is a question from Pawan, how to add libraries in the Jupyter lab. I'll just show you, right? So here I'm going to click on launch button here, and it is going to launch Jupyter. So in the next 5 or 7 minutes, I'm going to show you exactly how to work on Jupyter, right? And believe me, right? When I learned this Python thing, I was not working on Anaconda earlier. So I had to, manually install Jupyter in my core Python. It was a little tedious, but I got along with it and it was installed finally. Now, when I see Anaconda, it makes my life, a donut, a sweet, because you don't have that much stress to work on. Okay, so let's launch it. So here I'm launching. Vishnu, I think during the remote desktop hosted cloud-based training assignments, there's a team of excellent people who will be guiding you through. All right, so we have a lot of things here, right? Okay, I think I must delete all these things earlier. Okay, let it be. Fine, guys. So this is Jupyter, right? Yeah, but I'll answer you, right? So this is Jupyter, right? So this is the interface looks like. It's a web-based interface, right? You can simply start with new, and you can simply click on Python 3. That's how you can start, or else you can click on folder here, right? And you can create a folder, right? So it creates untitled folder like this. Okay, what I'm going to do is I'm just going to keep it simple, guys, right? I'm not going to mess with many options here. So I'll just take you directly with the coding part here. I'll go to new and I'll click on Python 3 here, right? So that's how we start, right? That's how we start with this notebook, right? So Python 3. Once I click on the notebook, right? So I'm going to see another window like that, right? And it has just started, right? So while you are working on Python, right? So here it is, notebook. You will see this kind of window, right? So these are the cells, right? So you can simply, write codes here. So I'm just going to show you exactly some code snippets here, how we work here, how we get across, right? And this is the name of your notebook, right? So you can just simply hover your mouse here, right? So if you want to rename your notebook, you can simply click here and you can say my first notebook, right? So like that, right? Yeah, Jishnu, we can change the working directory. That's absolutely true. So this is my first notebook, and I'm just going to rename it. You can see here it says my first notebook. And here, this is the cell where I'm supposed to write the codes here. So let's start with printing the hello world message, right? So let's print the hello world message. And for your information, this is the comment, right? So by using the hash symbol, we create comments in Python, right? So just to write some descriptive statements. right? So this will be ignored by the compiler and will not be treated as error, right? So it's like how we start hash. Hope you understood. So for printing a message, right, I'm going to, simply write call the print function, and in the double quotes, I'm going to, say a message here. Hi, this is hello from Python. All right. So this is a built-in function, guys. So mostly while learning Python, you're going to deal with built-in functions, and these built-in functions are provided during the Python installation, right? It's already installed, and this is a message that I want to print here, right? So hi, this is hello from Python, and if I want to see the output, I can simply click on run here. You can see, so when I hit the run, so it displays the output in this way, right? Just understand the behavior, and this is the reason why I love Jupyter, because instantly you get the output and very close to your codes like that. So you don't have to move your eyes, or move your eyes in a circular way to find out exactly where I'm seeing the output or where I'm getting the output like that. So it becomes easy for us to manage the codes and the output like that. All right. Now, so yeah, there is something called kernel, right? Kernel is basically a software program which is responsible for running this notebook. Make sure it is running, right? So if it is not running, so I'll just shut down. Okay, just some troubleshooting, right? I should not be doing this. See, no kernel, right? So when it says no kernel, that means there is no engine which is attached to this website, to this notebook, who will be executing the Python codes. That means it's a bad time. So I'll just restart the kernel, right? Kernel restarting, kernel ready. Okay, let's check. Okay, it's running, beautiful. Okay, now everyone, so here is a quick tip, right? New to programming, so in that case, stick to syntax, right? So this is something that I encourage my participants to observe, right? Every time you learn something, please stick to syntax, right? So when I say stick to syntax, what does it mean? Python is case sensitive, so it's case sensitive, so it's print, right? It's not print. Wrong, bad, boo, right? Good. Right, so here you can see the P is capital. It's wrong because it's case sensitive, right? And print, right? This is also wrong, right? No. So spelling mistakes, right? Do not do spelling mistakes, guys. So these are certain general errors, right? General guidelines. When you're starting with any programming language, you need to stick to syntax. You need to stick to it, right? So just have a sharp eye. Have a sharp eye over the code, right? What you are seeing and what you're writing. So just keep this thing in mind. So in case if you do something bad, so let's say if I skip the bracket here, and if I click on run, this is how the error is displayed in the Jupyter. But generally it takes some time to understand all these errors. It takes certain experience to understand, okay, this is something that there is something which is understood now. Right now, for the beginners, it will be a little difficult to understand exactly unexpected EOF. So when somebody says EF, it becomes really confusing. What is EF, right? It means end of file, like that, right? So just skip it. So to avoid all these confusions, just stick to syntax. And the shortcut here, right? The shortcut here is Shift plus Enter, right? So this is something that I'm going to use frequently. So if you don't see my mouse, going to this beautiful button and clicking it, and you are seeing the output automatically, that's because I have pressed Shift Enter, right? So Shift Enter, like that, right? I hope everything is going uh, in a smoother way, right? So just checking. So everybody is up and active. Just respond me, guys. Is everything clear? Okay, thank you. Thank you. Thank you very much, Ajay. Thank you, Rajendra. Thank you, Sujit. All right, that's great. There are a lot of participants with good enthusiasm. I can see, right? So I can feel it, right? All right. Great. Thank you very much, right? Thank you. Uh, yeah, Bhunesh, I'll definitely share the list of cheat sheets. All right. You know, there is a question from Mudit. He says that how to do on Chrome instead of Explorer. It's asking for PIN or password. That's true, exactly. You know, in that case, okay, I was just checking it out actually. You know, there is a key actually, right? There's a key which you need to, pass along with the URL to work on this notebook, right? I'll just answer you exactly from where you can find that key. All right, Amit, you are saying you are right, right? Shift enter takes you to the new cell, and whereas control enter simply displays the output in the same cell. That's true. All right. So okay, so I just got lost in the questions here. Himadri, the pie charm is beautiful. Spider better than spider. Okay. All right. All right. Now I'm going to answer some more questions here. Sachin, it is absolutely not recommended what you are thinking of, right? Do not ship your code. Do not ship your production codes into Jupyter. It's not at all recommended. Although and obviously you're not going to, ship the same notebook to the client, right? Never ever do that because it's not the right platform to execute the projects here, right? It's just meant for, snippets kind of thing or the testing kind of thing, right? Like that. All right, so I'll just proceed further with some more things here. So I've added some more cells here, right? So, you know, when you're into notebook, right, just go through the options, right? So I invite all of you to the tour of a notebook, and I just want you to do something called R&D. So that basically stands for research and development, right? So it will help you in getting deeper and deeper, right? Okay. Anjani, your question is really long, right? So I'm really sorry I cannot answer in this session because debugging the large codes takes a longer time. Ahanda, there's a question from him. He says sometimes we use single quote, sometimes double, even sometimes triple as well, right, Ahanda? So just answering this question, I'm sorry, I'm just getting interrupted sometimes. In Python, this is string. This is also string. Just observe the quotes, guys. This is string 2. Also the quotes, guys, right? So in Python, all the quotes are same, right? So you have single, you have double, you have triple. The only difference lies here, right? So you are allowed to give line breaks in triple quotes, right? You are allowed to give line breaks in triple quotes, but you're not allowed to give line breaks. Bad. No, you cannot give line breaks in double quotes or single quotes. Otherwise, double and single both are same. But the difference here is that in triple quotes, you are allowed to give line breaks. That's it. So that's where the story ends. Okay. What if I number value for name? It is going to be a number, right? So like if I enter a number, it's going to be a number, but in the string form like that. Yeah, Sanjay, obviously we need to take care of the types. And as you gradually, experience or do the codes, you get to know these things and you used to it, right? It automatically happens. You automatically do all the stuff that is required for getting the right output. So it becomes the habit. All right. So everyone, what if Nupur, there's a question from Nupur. She says that what if Python cannot convert string into integer? In that case, it is going to raise an exception, and exception is basically the runtime error, right? So runtimes are really bad, right? They crash our programs, they terminate the programs, we lose the data. So to overcome this situation, there's a concept of exception handling. Okay. So there are a lot of questions. Yes, Kritika, all the inputs that you accept in Python are strings. Mostly, this happens generally with all the programming languages, even if you are using Java. So in that also we have strings. In case if you are using the buffer reader class, it's always string. No, Jishnu, in that case, the Ranjan will not be converted into integer, or the its ASCII value, it will be an exception. So what are the data types in Python? We have int long, we have int float, we have Boolean, we have all the basic fundamental data structures. Apart from that, we have special data structures such as list, tuple, dictionaries, and sets, like that. In today's session, we are going to learn so many things here. So I'll just start with my presentation. Right, I'll take care of beginners as well. Right. Okay. All right. So here we go. Right. Okay. Now, especially this is dictionary, guys. First of all, I want you to have a look at a dictionary. Right. I want you to have a look at a dictionary. So here, when you say dictionary, basically in dictionary, what is special is that list and tuple both are holding scalar values, means individual values, right? List and tuple both are holding individual values like this: apple, banana, cherry, right? So these are individual values. But here, if you observe the commas here, right, before every comma, there are two things which are maintained here, right? Before every comma, because you are a beginner, that's why I'm just highlighting this part very much. Before every comma, can you observe two values here, two things here? Right? But here, before every comma, you can see only scalar or singular values, right? So basically, dictionary is a data set or data structure which basically holds the objects or the items in the form of key and value, right? Key and value, key and value, key and value, right? So this is dictionary, right? So this is a kind of data structure that we use in Python for managing two things, right? One can be the key and second can be the value. I'll give you the example like this: one, Ram; two, Sham, assuming a employee and name; three, Rohit. So you can see here key and value. So in such situations, when you are supposed to handle, you know, multiple values, multiple things. So one can be the key and one can be the value. In that case, the dictionary data structure is suitable. Okay. So a dictionary is a collection which is unordered, changeable, and indexed. In Python, dictionaries are written with curly brackets and they have keys and values, right? I'll come to each and every point, but just observe, right? Just stick to this thing. Observe the curly bracket first of all, right? So I'm just recounting everything. In list, we were having square brackets. In tuples, we are having parentheses, and in dictionary we are having curly brackets. So just telling you the beginners, right? Just telling you the starters, guys, how you identify what thing is that, how you identify that thing. So first of all, you need to learn the identification, right? Learn the identification first of all, right? And in my practicals, I'll tell you each and everything. Just allow me, right? Let me cover this basic fundamentals. We're going to do it in two phases, right? The theory part and the practical part. So let me get into the practical part. Okay. So here we go with the practical lab session, right? So I'm just going to start with the session, the practical lab. And so I'm going to start with an Anaconda Navigator. I hope everyone is aware of how to work on this beautiful distribution. So I'm going to start with the Jupyter part here. Right. So here it goes like. So I'll try my best to explain you. What you need to do is you need to be parallel with me, right? Be parallel with me, and we'll have a lot of learnings and practicals, and we'll enjoy this session a lot. So here we have Jupyter here, right? I'm going to start with a new notebook here. And here I'm going to just simply put in a name, Python DS. All right. So here we goes like, okay. Okay. I hope this Zoom is good for everyone. Last. All right. So here we have some things to cover, right? So you can see here, I'm telling you about a list here, right? So a list is basically a collection of values. So when you have, a huge set of values, you use list, right? So in a situation when you have huge set of values, right? So values can belong to different data types in a list. So in a list, if you are adding some values in a list, so it can contain the values of different data types, right? So in a single list, you can have integers, you can have strings, you can have floats, you can have booleans, you can have that thing. So a list can contain another list. I'll show you it in the practical exactly, because I'll show you it like this. Okay, 1 comma 2. Okay, just look at this expression, right? It may sound difficult for you, but I'll repeat it once again. So you can see here, this expression is basically what? A list, a list containing multiple lists. Can you see, right? Just trying to be, just explainable, right? Explanatory to you, right? In case if it is not understood, I'll repeat it once again in my practical, right? Just helping the maximum I can. Now the final part is that list is mutable, right? List is mutable. What does it mean? It means that you can edit the values in a list, right? So if there is a value called apple, you can simply change it to grapes, like that, right? So let's create a list here, right? So I'm going to create a list here: apple, mango, banana, cherry. So guys, this is a list here, right? A list. Why it is a list? Because you can see a square brackets here, right? Like that. Now, I'm just going to print this list here, like this. So you can see it is printing. Now, you may be thinking that, we are working with static values. Yes, we start with the static values, but once you feel comfortable with the static values, we move to the dynamic allocation, right? We move to how to dynamically add the values. I will definitely move to that. Just allow me, to cover all these fundamentals, right? Because I believe that all participants are not at the same stage. So guys, everyone, right? Everyone, is the concept of list clear here? Yes, everyone, right? I have intentionally used these single quotes and double quotes here, right? I have intentionally used these single quotes and double quotes because both are same and both are allowed, right? So there's no difference between these double quotes and single quotes. So everything is string here, right? Yeah, Raj, input function will be taken later. That's true. So Thamlika, there's a question. What do you mean by order collection? Basically means it basically means that in the order, in whatever order you add the values, the same order will be maintained in the list. This doesn't happen with the dictionary. Now, fine, everyone, work on this. So I believe that everyone is familiar with the loops, and I will be requiring loops, to extract the values from the list or the tuples. I'll be, requiring the loops to, iterate through all the collections. So that's why I need loops first of all, right? And especially there are some people which are really care about when somebody says I'm a beginner. So it's really a alert for me to be, attached to the participants so that they can learn things also. All right, so here we're talking about the loops here. So here we have for loop and while loop mainly, right? We don't have do while loop here. So I'll be talking about the for loop here, right? Okay, so just bear with me, right? Just bear with me. Okay, so before that, I'm going to tell you about something called range function. This is a range function, right? It generates numbers from 0 to length minus 1, right? So the output of above function is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So just get this, guys, right? So this is a range function, right? And what it does, it generates numbers, right? And by default it starts from 0, and whatever number you have given till n minus 1. So what it is going to do, it is going to generate this series, right? So this is its behavior. You need to understand the behavior. Now, as you have understood the behavior, what I'm going to do is I'm going to change the expression to this x in. Now, what this expression basically means, this expression basically means that all the numbers will be assigned to x one by one, right? So all the numbers will be assigned to x one by one. So if the first value of x will be 0, right? It's like this. Now, for x in numbers, this expression basically means all the numbers are going to be assigned in x. Now, what I'm going to do is I'm going to replace that expression with this expression. This expression is same as this expression. The only thing is that you will not see these numbers getting extracted externally or on your screen. So this extraction is going to happen internally. You got it, guys, right? So this is how it goes like. Now this for loop demands this colon as part of its syntax in Python, right? So you're supposed to put a colon here. And in Python, the very important part, especially for beginners, we don't have curly brackets here, right? We don't have curly brackets in Python. What we have is something called indentation, right? Indentation. So what does indentation basically means? You can see it here, colon, enter. So you can see here that one tab is automatically taken here, right? See, one tab. It is not going to the beginning of the line, right? Like this. So this tab basically shows that I am within for loop, right? I am within for loop. So when I say print x, so what it is going to do, it is going to iterate through all the numbers. All the numbers from range function are going to assign to x, and it is going to print x. After every new assignment, the old value will be overwritten. So guys, can I ask you the output of this for loop? Okay, 0 to 9, right? 0 to 9. So you need to understand this thing, right? So this is called generator function. Generally, it is called generator function in Python. This is one of the concepts, but just telling you how it goes like. Okay. So I'll do it once again. See, when I press enter, you can see that it is following the tab. What basically means? It basically means that I'm within for loop. So if you want to come out of for loop, you need to press backspace. Everyone, backspace, right? Understand this thing, backspace. No, it can be negative, right? So it can be negative. Okay. It is consecutive, but we can change the sequence, right? So it's like 5, 10. So what does it mean? It starts from 5, ends at n minus 1, right? So range function, it is going to generate numbers. It is going to start from 5, and always remember, guys, n minus 1. Now, if you want to give colon is a syntax, Saxena, there is a question from that. What is colon for? Colon is the syntax of Python, right? I'll just show you. Okay, see, here we are talking about indentation, guys. Okay, I'm just going to give you a 2 minutes lecture on indentation. Okay. So when I say class car, or okay, for int I equals to 1, I less than equals to 10, I plus plus. Let's say some print I, right? Now this thing and this thing both are same. For x in range 10, print x. Observe the indentation, right? We cannot put curly brackets here, right? Right? We cannot put curly brackets, right? And if you want to understand indentation more further, I'll give you an example like this: A, B, C, D, E, F. Okay. Everyone, observe this, observe the indentation. In this example, you need to observe who is within who, right? So who is enclosing itself within whom, right? You need to understand this thing. So here, this is A. Now, because B has an indentation from left, that basically means that B is within A. And this C is within the indentation of B, right? And this D is also in the same indentation. So this means this C and D are within B. E is at the indentation of A, and F is not without an indentation. So F is outside A. So guys, can I ask you, who are the children of A? Okay, yes. Okay, that's good. Yeah, that's good. That's good. So I can see the responses. Everything is going good. Direct children of A is B and E. Good, good. And who are the direct children of B? Direct children of B? C, D. Absolutely. And can I ask you, who are the root values here? Who are the root values? Root values. A and F. True. A and F. Yes, that's absolutely true. I can see the response in the chat window, and I can assure you that 99.9% people are answering right. That's true. Thank you. Okay. So this is going good. This is going good. I hope everybody is understood with this for loop, right? And we can customize it further. But for better customization, I encourage you to go with the while loop. So in the next demo, I'm going to show you the while loop here, right? So let's say we have something called meter equals to 1, while meter less than equals to 10, colon. Once again, guys, you need to observe the syntax, right? So stick to syntax. Stick to syntax. That's what you are supposed to do, right? While meter is less than equals to 10, print meter is meter plus equals to 1. Okay. Now observe everyone. I'm for getting out of the loop, I'm going to press backspace. For getting out of the loop, I'm going to press backspace. See, right now I'm out of the loop. Print while loop finished. Okay, shift enter. Observe the thing, guys. Observe the behavior. Observe the behavior. Observe the indentation, right? How it is working. Observe the behavior and observe the indentation. The meaning of meter plus equals to 1 is meter equals to meter plus 1, right? So what we are doing, we are basically incrementing the value of meter. If we don't do that, meter will not reach 10 in its life cycle. So it will be infinite loop because meter will always remain 1, right? So there's a question from AL, what is plus equals to, right? So it's like append, kind of. Asim, you said meter plus plus, but unfortunately, meter plus plus is not plus plus, that is unary operator, which is not supported in Python. So we don't have plus plus here. Instead of that, we do plus equals to. Okay, everyone, participants, can I confirm, is this syntax of a while loop is clear to all of you? I'll give you some one more example here, right? I'll give you one more example here. I'll take an example of, let's say, accept 3 numbers and add them all, right? So here in this demonstration, I'm going to show you how you can accept 3 numbers and I can add them all, right? So as per your statement, meter equals to plus is not valid. It should be meter plus equals to. So here I'm just going to give you one more example here. Sum equals to 0 or total I'll take. Okay. For count in range 3. So here you can observe that this is going to generate 0, 1, 2, and count is going to be 0, 1, and 2. I'm not using count. Num equals to input. enter a number. So you can see here, I'm accepting the number from a user. And if you remember that whatever we input from a user is by default in string form or in character form. So we need to convert that in string form into integer form. That's why I am using integer function here, right? Because strings cannot be added, right? Okay. So whatever I'm going to input is going to inside num. So I'll just show you, right? Just like this, 10, 20, 30. See, it asked me for input 3 times, right? Okay. And then what I'm going to do is I'm going to add the number in total, right? I'm just keeping it simple, everyone, right? So whatever number I'm going to accept is going to store inside total, right? And then see, observe guys, I'm going to press backspace for getting outside of the loop, because right now there is one indent from the left. Right now there is one indent from the left, so that means I'm within the loop, right? So I'm gonna press backspace. Print total is total. So let's show you how it is working. 10. Okay, I'm going to take 2. I'm going to take 2 once again. I'm going to take 2 once again. So it says 2 plus 2 plus 2 is 6, like that. Okay. So guys, this was a small demonstration on how we can use loop for solving our daily problems. We generally use loops for values for activities which keeps on repeating or which are recurring, right? So for those kind of scenarios, we can use loops here. So guys, just wanted to confirm, is this concept clear till here? If you answer question is like indented for loop, so yeah, keep on indenting, right? For x in range 10, right? For y in range 10, right? So keep on indenting, right? Just keep on indenting. So you can see a nested for loop, how it is going like, right? So just telling you. Okay. Now I'm just proceeding further, right? And while I'm doing the practicals, your question will be automatically answered. Just allow me, right? Manish, in that case, it is good to go with the list as per your question. All right. So coming back to the list, guys, right? Coming back to the list, there are a lot of questions which are coming on the way. Okay. When you're reading the data sets, right? So generally you get all the values from those huge data sets in the form of list, tuples, or dictionaries. So you need to cope up with these data structures. And with the coming practicals, we'll have a lot of loop demonstrations once again. All right. So guys, coming back to this thing, right? Creating a list. So as I have given you here, we have a list here, fruits. I hope everybody is active till here, right? Okay. So we have a list here. It contains some elements here: apple, mango, banana, and cherry, right? And I've printed the list here. So this is fruits. So it is printing. But you can see here that if I print this output, it is not user friendly, right? Because it is containing some codes here, it is containing the square brackets here. So I cannot show this output to the user, because when you are giving the output to the user, the same output, he will be confused exactly why I'm getting all these codes and square brackets. So let's print the values of a list, right? So printing the values of a list, right? So I'm going to show you exactly how you can print the values of a list in a friendlier way, right? So how you can do that. For that, I'm going to use for loop once again, right? So here, for loop to the rescue, guys. So I'm going to item in fruits, right? So see guys, just observe this syntax here. What this for loop is going to do is it is going to extract all the values from fruits, and that too one by one, right? One by one, it's going to extract the values from the loop one by one, and it is going to assign the values to the item object. And don't get confused if I say X here, F here, or item here, right? So the variable name can be anything. Don't get confused. It's just a holder, right? It's just a holder. And then I'm going to print the item here, right? Just to confirm that it is printing individually. So I've added input function, right? this is just a pause to show you that it is happening one by one, right? See, apple, mango, banana, and cherry. Can you see that? Right? So it is happening one by one. And without that, okay, my kernel just got crashed. Let me restart it. I'll just restart, right? I stopped getting output actually. All right, let's see. Okay. Okay, just a moment, guys. I'll just recreate. Okay, so here it goes like. Okay, so it is done, right? So can you see the for loop here, how it is being used here for extracting the values of a list? Everyone, just confirm me, guys. Is it clear what is happening here? See, guys, you need to visualize that all the values will be assigned to item object one by one, right? It will not happen in front of your eyes. It happens in memory. You just need to have that visualization in your brains that, okay, that's how it behaves like. So guys, here, why we are sitting here? We are sitting here not only to learn, but to understand the behavior, right? You need to understand behavior as well. Okay, so I'll just proceed further. Okay, I have a question here, right? I'll just Anant, you asked me that do we have to use input? Anant, you don't have to use input, right? Because when I'm using a for loop, it suddenly it prints the values all of a sudden, like it's a bang, right? So just wanted to show you the behavior sequentially, right? Okay, see, it is assigning. See, it is printing. It's printing. It's printing. So that's why for that pause I used input. That's just a demonstration to show you, right? So it's not at all. You're not required to use it. Yes, Ravindra, can word item be replaced by any other word? Yes, it can be. List can be edited, right? So basically, or list is mutable. What does it mean? So I'm just going to show you here, right? So let's say fruits at one index we have mango, and I'm going to change the value of one index from mango to, let's say, peach. Right? I hope that is a fruit. Yeah, Himadri, item is just a placeholder. Yeah, we can use any variable, right? So it can be X, Y, Z, A, B, C, right? So a lot of, whatever. Okay. So guys, am I successful, right? Did I change the index one value? Yeah, okay, yes. Yes, I can change, right? So this is something which is beautiful, right? So this is beautiful. So that's how, we work, right? That's how we edit, right? And I'm going to show you a more detailed explanation here, right? I'll just proceed further. As I told you in the beginning, that I'll be doing a list comprehensively. So let's go further, right? All right. Yeah. So here, let's do some more action and list. All right. Okay. So here, guys, creating a blank list, right? Okay. Yeah, Kishore, I'm going to answer your question, right? I'm going to answer your question. Creating a blank list here, right? So I have a list here called colors. See how beautiful is that? That's how we create a blank list, right? Colors equals to square bracket. So this is a blank list here. So if I print colors here, I'm not going to see anything apart from that square bracket. So this is something that I have till now. So what I'm going to do is I'm going to, call a function called append, right? And what I'm going to do is I'm going to add red here. So append is a function, right? Used to add values. Right? It's a function used to add values in a list, right? So if I do, now you can see that it is showing me the values, right? So it is able to show me the values in a list. So you can see that I've added the colors. Now let's add some more colors here. Append, let's say green. So it is going to add green in the list, and append blue. So it's going to append blue here. And I'm going to print it here so you can see here. So just now what we have learned about a function called append. Append is a function which is used to remove the value. Oh, sorry, append the values, like that. Yeah, Raj, there's a question from Raj. He says that what is the difference between append and extend, right? So I'm just going to answer this question. And the question says that what is the difference between append function and extend function? So let's see it here. More colors. So here we have one more list here, more colors, and I'm going to add, let's say, cyan, and the beautiful one, teal, and the pink, and finally maroon, right? So we have more colors here. What I'm going to do is I'm going to call a function called extend, right? More colors. Oops, colors, right? I'm missing S here. What extend does, see, extend function is used to add list in a list, whereas append is used to add a value, a scalar value, right? Can you see here, right? So I've added the extend, right? We have learned append, we have learned extend. Now what we can do is colors dot insert one index. I'm going to push here something beautiful, so that should be black colors. So you can see here at one index, I'm able to push a color, and that is black. So yeah, we have one more function called insert. You know what insert does? Insert adds a value at a given index, right? So it's like that. So insert adds a value at a given index. So we have three ways of adding the values. We can use append, we can use extend, and we can use insert, right? So generally, I try to stick to one or two methods, for the same particular activity. But we have, n number of things. But generally it confuses the participants who are new or who are the beginners. So, in case if you can understand one out of three, that really will work, right? It will work. Fine. And you need to give time, right? You're supposed to give time to these concepts to, get into your brain, or, get into the functioning mode, right? Yes, Arvind, can we insert multiple values at the same time using insert? You can add a list. You can supply a list in the insert function for adding multiple values. So guys, just wanted to confirm, is everything is going okay? Is there any nausea feeling? I'll proceed further. Wait a bit. I'll proceed further. I'm going to add a new notebook here. So more activities on list here, right? So what I'm going to do is I'm going to create some more demonstrations here. Just be with me, right? So this time I'm going to colors, right? And I'm going to create a list here: red, green, blue, orange, teal, and cyan. Right. Okay. Now in this demonstration, let's say if you want to remove something, right? Colors dot remove. So I'm going to remove red, and if I print the color, so you can see here that the red has been removed, right? Can you see that? Right. So we can do that. So colors dot remove. Right? So it's for removing the values. And apart from that, we can do colors dot pop. Right. Once again, pop removes the values last and first out kind of thing. Remember? Cyan. Right. Colors. So it basically removes, right? You can see here the sign is not anymore in the list. Okay. Does that remove all the matches? No, it searches for the first occurrence, right? Okay. Getting the length of list here. So print the length of list is, I'm going to use the similar function, that is colors here. You can see here the length of remove is the length of colors is 4. Mazhar, you cannot do like that, right? So you need to use a loop for that, for your question. Yes, we can remove color, right, by index. So for that, remove object via index. I'm going to use del colors, del 1, sorry, colors 10 colors. You can see here, I'm using a keyword called del, right? So this basically asks for the index, right? And so I've removed the green one. It follows the same array, same array terminology that all the values start from, the first value starts from 0 index, right? So it's like that. So when I print the colors after deleting the 0 index value, you can see that I'm no longer getting the green, right? I'm getting the color blue, right? Like that. Okay. Guys, there are a lot of questions which are coming, right? So let me not lose the balance of the flow. Let me not lose the balance of the session, right? So I don't want to go random suddenly, right? So let's follow the sequence here. Definitely, I'll be answering your questions. Nagaraj, the rollback is not supported, right? It's not supported. Guys, I just wanted to confirm everyone. So like, are we okay till here, everyone? Are you getting exactly how to do various operations? Okay, that's good. Thank you. Thank you, everyone. Okay, that's great. Okay, I encourage that in case if you can do the practicals parallelly, it will be a great help, right? It will be a great thing, but sometimes it may slow down, right? It's fine. Thank you, Noble. Thank you, everyone. Okay. Okay, I'm going to tell you about the in operator, right? In operator. If orange in colors, print wow, found orange, else not in. So there's something called n operator, right? So n is basically used in for as well, and n is used for checking the existence of a given value in a given list. So what this expression basically means? This expression basically means that we are checking whether the value orange is present in the colors list or not. Here's the list. Here's the values of colors. So when I hit enter, so it says orange found. So because obviously orange is there, right? So it's like that. So we can use the in operator, right, for that. So can we read the values in the list using a for loop? Yes, Srikanta, we have already done that. Just for your revision, I'm going to do this, right? So see how we have read all the values from the list. Apart from that, it supports if item equals to orange, right? Great. So it supports all those keywords that you have learned. Like we have continue, we have break. So we can do that, right? We can do this. Okay, so there's a question from Sanjay. He says that can we count the number of duplicate values? Yes, we can do that, right? So for that, I'm going to give you another demonstration. So count number of values, right? So for that, I'm just going to give you another demonstration. So in this case, I'm going to take, let's say, fruits once again, right? Let's stick to the same examples: apple, mango, cherry, and apple once again, right? Okay, fruits dot count apple. So we have something called count function here, everyone, right? So this was asked by one of the participants, like, can we count the values, right? He said duplicate, but let's see. So we have count function here, and count basically is going to ask you what value you want me to count in a given list. So I said apple. So here we have apple repeated twice. So the answer is 2, like that. So we can do that. So Sanjay, I hope this is going to answer your question, right? Okay, thank you, Sanjay. Thank you very much. Now, I'm going to give you one more demonstration. Finally, let's say here dynamic memory, right? So dynamic addition, right? So many participants ask me like, can we add values dynamically in a list or not, and how we are going to do that. Vinith, there's a question from you that why some functions have syntax variable dot function. Vinith, the thing is that in Python, everything is an object of some class, right? So we don't have, some structures or, non-object members here, right? Everything is an object of some class. So that's why what you're thinking as a variable is not a variable, it's a function. So that's why we can call, sorry, it's an object, it's an object. So once again, we need what you're thinking of as a variable is not a variable, it's an object of some class. So basically, we are calling a function from an object, right? It's like that. For AI, for that you need to apply the code logic here. You need to apply some algorithm for finding the specific without specifying the values, right? So it will be difficult for me to apply the same logic because it's going to consume a lot of time, and I'm still pending with some more topics to cover, right? I hope you'll be able to do that with some basic programming. Okay. So guys, in this demonstration, I'm going to show you exactly how you can use a list to dynamically add the values. And what I'm going to do is, uh, okay, shopping list. So I'm going to create a shopping list here, right? So here we have a list here which is blank, and this is a cart, right? And it is blank. I'm going to run a loop here for finite number of times, right? So this is a finite number of times. You can design a loop which runs infinitely, right? So that is also possible using a while loop also. So I'm going to, product. I'm going to accept enter your choice. I'm going to, accept the product detail from here, right? And I'm going to append that product in my cart. So guys, observe here, everyone, what I've done. I'm going to run this loop 5 times. That means I'm willing to accept 5 inputs from the user. Initially, I've created a blank list, right? And I'm going to accept input from the user. Whatever the user is going to enter is going to be stored inside product, and whatever the value is in product is going to be appended or added into the cart, right? So this is the master line, right? This is the master line. You need to observe this. Yeah, both are same topic as per your question. Both are same. And I'm going to press backspace for coming out of the loop. So print user has added length cart. So this makes sense, isn't it? So don't you think that this statement makes sense? And I'm using a length function here for getting the length of, or for getting the number of values in a card. So user has added number of values that I'm retrieving using the length function in the cart, right? Okay. Print following are the values, are the products. So what are the products user has added? So for item in cart, print item. So it is going to print all the items here. No, it will not give out of bound error AI. It will not give. Right? It's dynamic in nature. So guys, I'm going to proceed further, and I'm going to show you output. Then I'll ask you if you have any doubts, right? So see, this loop is running for the first time. Enter your choice is coming here. /n is for line break. Whatever I'm going to enter is going to be stored inside product, and that product is going to be added in the cart. So it's like this. So let's say we have Dell laptop, right? Enter choice. So this time, let's say, hi, I have OnePlus. Oops, I added T. Okay, so enter choice the third time. So this time I'm going to have, let's say, Philips music player. This time I'm going to have, let's say, okay, M-Brain power bank. And finally, right? So finally, what we can have? We can have what we can have Casio edifice, right? So this is going to be, adding in the cart. And what it says, user has added 5 items. That's absolutely true. And following other products, the laptop, OnePlus, Philips, M-Brain, Casio edifice. So this shows, a kind of shopping cart simulation. And thanks to the list, right? Thanks to the list, because list is dynamic in nature and list supports various data types, and I can add values, right? Is it possible to show options as enter choice one, enter choice two? Yes, it is possible. You can simply write here, you can simply write here x plus one, right? So and so it is going to print enter choice one, enter choice two, like that, right? So that's how it goes like. Okay. So guys, in that case, if len product, there's a question like from Sanjay Kakkar. He says that can we put some kind of constraint that no blank to be inputted, right? Like that. So in that case, we can put a condition like this. So if the length of product is 0, that means the user has entered blank. Simply continue, right? Don't append the value in the card. So I hope that answers your question, Sanjay. Yeah, thank you very much, everyone. We can do that, right? We can do whatever you want, guys. But in the beginning sessions, generally I try to create a strong foundation, and customization something that I'm willing to do, right? Once the strong foundation has been laid. Suptic says, is list exactly same as array? No, right? When we talk about general arrays are something which are rigid about their data types, right? Array do not allow multiple data types in their collection, whereas list allows multiple data types in the same list, right? So you can add integers, strings, both at the same time. Arrays are length bounded, means like once you define the length of your array, you cannot reinitialize it or extend it or squeeze it, but we can do this thing in list. So these are some of the differences that we have between arrays and list. There are more, but I'm just you know keeping the pace, just saving my some minutes and hours for my upcoming topics. So Soptek, I hope this answers your question. Yeah, we can do list comprehension today, right? Nivas, we can do that. Okay. Thank you, everyone, right? Okay, Ramesh says list and list example. All right. We can do that, right? So like list and list, right? So how we can do that? So I'm going to, household items equals to TV, refrigerator, chair, geyser, and then we have, let's say, a table, and let's say we have lamp. So in that case, for X, for list in household underscore items, for item in list, print item. See, Ramesh, just for you, right? Okay, Ramesh has had a question. He's asked me that how you can, work on a list within a list. So just try to do something here. So when you're working on list in a list, basically, you're supposed to do a nested loop so that you can extract. In the first loop, you extract the list, and in the second loop, you extract the items from the list, right? See, I got list. Okay. Okay, thank you, Ramesh. You can see here, right? So what you're getting in the list, first of all, right? In case if you're not understood, right? If in case if you're not understood what you are getting in for the first time. So I got what? See, TV, refrigerator, chair. So you got the whole list, right? You got the whole list. And then from this list, from this whole list, you're extracting the items, right? So it is TV, referee, and chair. So that's how these two loops are being used. Avyankush is asking me, can we have auto prompt to avoid typing mistakes? So it's like this, house. Okay, and come on. Okay, that's here. So in order to avoid typing mistakes, what we can do is we can simply write some initial letters like this, and we can press tab in our keyboard, and boom, like that. So that's how we can autocorrect, right? So the master key is tab key, right? After typing some initial letters. So guys, I hope everyone is up and alive, right? So can I see some responses, right? So guys, how is the Josh right now? Let's see. In the list, you can update a list as an item, but you can update individual string, right? The memory value. So when we talk about immutable and mutable, we don't talk about the values. It's about the updations in the memory, right? So in strings or even in list, a new memory is allocated. So that's how it becomes immutable or mutable. Okay, here is a question. This is highlighted because list is actually a built-in keyword or a function. So that's why it is highlighted. I should not be using some built-in keywords, but those are allowed sometimes, or mostly actually. So Surisha, your concern is right. So we can, change it to some other variable like X or Y. Thank you. Everyone is helping me, right? So guys, in case if you can answer the questions in the chat window, please do so. That will help me in covering more topics here. Let's proceed further. Okay. I'm going to show you some more demonstrations here on tuples now because I'm low on time. Please allow me to proceed further, right? And I hope everybody, guys, I'm just going to take help from my last session. Do you remember that when I told you about the Python strings, I told you some expressions like this, right? All these expressions are possible in list as well, right? All these expressions are possible. Yeah, true, slicing. Thank you, everyone. Thank you very much. All these expressions are possible and in list as well and behaves in the same way. So I request everyone here to please experiment and try all the expressions in the list as well, and they will behave the same way and you'll see the same output, right? So just have this thing in your mind as a you can say assignment, or you can say the activity to be done later, right? Okay, thank you everyone for your active cooperation. Now here I'm going to proceed further with tuples, guys. This is tuples, right? Tuples are collections only, but read only, right? So tuples are collections only, but read only. So suppose I have example called days, Sunday, Monday, and then we have Tuesday, Wednesday, Thursday, Friday, and the very beautiful day, Saturday. All right, so it's here, days. See, this is a tuple. What is the identification, guys? The parenthesis here, this is the identification. If you want to see technically, I can show you technically as well. See what it says. In the last session, I told you about the type function. Remember, type function is basically used to, check the type of particular object. So it is tuple. Now, what is the problem with tuple? The problem with tuple is that you cannot edit the values, right? It's read only. So what it's like, so let's say days, I'm trying to change Sunday to fun day, right? So, okay, that was nice. So I'm trying to change Sunday to fun day. So let's see. Oops. You can see that here that tuple object doesn't support item assignment, right? So so why we are getting this error? Because read only, right? We cannot edit the values, right? It's read only. Days dot. See, we don't have okay, this is a list, right? This is a list. So we don't have, functions here in tuple. Can you see? We don't have append, we don't have extend, we don't have remove. Can you see that? Why? Because tuples is read only, right? Okay. So I'll simply yeah, I'll answer your question, AI. You say that we have list. Why do we need to use tuples, right? I'll answer you that. Okay. Thanks. Okay. So the question is, why tuples when beautiful list is there? So here is the answer, guys. Right. Here is the answer. Right. For study value declaration, that's true. It is faster. Amit, you are absolutely right. Tuples are generally faster, but read only can be a constraint. No, Himadri, that's not right. Right. To fix the values, I'll give you an example here. Right. So suppose we have a shopping portal, right? Right. So we have a shopping portal. Let's say it can be Amazon.in. Let's say, right. Okay. So here you are required to develop application, right, for internal team to add, modify, and update products, for affiliates to sell products. It can be, there can be example of, let's say, okay, which website does that thing, right? So let's say some xyz.com. Okay. So guys, if you observe this scenario here, right? So let's say, just giving us some simple example so that you can understand, right? Obviously, at the production, this is not exactly does fits, but it will clear the concept here, right? Okay, we cannot sort tuple, nothing. We cannot, right? We can sort list, but we cannot sort tuple. Those are read only. We can sort tuple when we convert tuple into list, and then we can sort, right? So this is possible. So guys, just coming to this example. Okay, what should be the type of products? So you have a shopping portal, Amazon.in, right? And you are required to develop applications for your internal team, right? Your Amazon team, where the Amazon team is able to add, modify, and update products, and to your affiliates, where the products will be sold. But obviously, the affiliates are not supposed to do any manipulation or modifications in the products. So in what form you are going to deliver the data, right? So the question is that in what form you are going to deliver the data to different teams here. So the question is, what should be the type of what should be the type of products in that case? Yeah, Piyush, that's what I'm trying to say here, right? So in case if you want that security constraint, right? If security feature. So if you are giving the products to your internal team, right, so that they can update and modify the products, in that case, I suppose that you must use list in that case. So when you use list, so you can update the products. But affiliates, right? Affiliates are people who are external, right? Who are aliens. So aliens are not supposed to do any intervention with the property of Amazon. So in that case, the affiliates must be given tuples in that case. So this is one of the example, right? Just to clear you exactly what can be the scenario where a list is good and what can be the scenario where the tuples are good, right? Soptic, that's absolutely true. Thank you. So guys, is the situation or the context clear about the usage of these two? Sanjay, there is no difference as such, but tuples are internally faster because of no manipulation. So it's going good. I'll proceed further. And all the conventions are same, right? For D in days, print D. So you can see here the conventions are the same, right? Tuples are heterogeneous, that's true, because tuples are allocated fixed memory and no changes are allowed. So the traversal means the visiting of elements is faster in that case. Items equals to ABC, A, B, items, items 0, A equals to Z, items. See, Salai, what we have done here as per your questions, right? I can edit the items of list in a tuple, right? I can edit the items list. That's true because it is the nature of list that those are editable. But if you but you cannot you cannot modify the whole list here, right? The concern is not about updating the individual list. The concern is about updating the whole item here. So let's say if I try to do like this. Items 0, right? Okay. This is going to update the same thing. See, it updated the list, right? It updated the list, but I'm not able to update the zero index value, right? Can you observe this? I cannot update the zero index value. It is updating the list only. So still it remains uneditable. All right. Yes, Mazhar, it accepts the data of any data type. Number of followers is directly the number of. Thank you, Saleh. Thank you very much. So, guys, there is nothing more that can be done in tuples, right? There is nothing more. And I'll do some few more things here. Okay. Okay. My days equals to list days, right? And here you can see that I've converted right. You can see that I've converted a tuple into a list using the list function, and now I can make the changes in the individual elements, right? Not in the whole list I'm talking about in case of tuples. And finally, the sorting method is also there. Okay, T equals to. Okay, what happened to this? D. And I'm trying to sort the list, right? So this was something which was missing in the list demonstration. Why is it saying? Okay, okay, got it. My days dot sort, and then my days. Is it okay? SWFMSTT. Yeah, sorted. Great. So you can see that the list has been sorted as per the first character of the list, right? So this was something which was pending from the list demonstration. So thankfully I got to cover it. And there's a question from Nivas. What is the meaning of nested loops? So Nivas, the nested loops basically means a loop within a loop, right? So if you create a loop within a loop, it's called nested loop. Okay. So shall we proceed further, guys? Is everything clear till here? Yeah, sorted is also true. Richa, your is also good. Right. Okay, thank you, Subrat. Thank you. We are getting closer to the end of session, right? And I hope everybody is, learning things here. Okay, fruits equals to apple, mango, banana, and cherry. Right? There are a lot of questions about sorting, so I'm just taking the sorting part. Sort fruits. I think it goes cool, right? Everyone, you can see the things are sorted now, right? Might be I must have used some upper and lower case characters previously, so because of that confusion came. But with this example, the sorting must be clear. Yeah, true, Ashwin, true. So guys, I'm just proceeding further. I'm assuming that everyone has understood, right? And I hope my assumption is okay with the mass. It is a little difficult for for me to answer all the questions in the given period of time, but I'll try my best to be maximum as possible as I can. Okay. Now in the next demonstration, I'm going to demonstrate the dictionaries part here. Okay, dictionary guys, dictionary is one of my favorite topics here. Dictionary is basically is used to manage keys and values. So this is how we use dictionaries to manage the keys and values. Thank you, Rajesh, for that GK, right? Thank you. Okay, let's proceed further. Okay, everyone. So here we have a dictionary, right? Print lang, and here it goes like, so it's beautiful, a dictionary, right? We have a lot of dictionaries here, and in further demonstrations you'll be learning how to manage the keys and values separately and how to go through the keys and values, right? So I'll just try to add one more okay, let's go through the loop here, right? So let's see, when we iterate through a loop, right? When we iterate through a dictionary specifically, what we get in the item, right? So you need to understand the behavior, guys. Right? Okay. Print item. So let's see what we get, guys. 1, 2, and 3. Let's get started. So, guys, any idea what we get by default here? So, are we getting the keys or the values? That's true. Keys. True. So, guys, you need to understand the behavior, right? Understand the behavior exactly. How code behaves, right? So we are not here only to learn code, we are here to understand the behavior of Python, right? So understand the behavior. That's the thing that we are supposed to learn here. Okay, that's good, yeah, that's good. Okay, now one more expression. Okay. One more expression. So this time I'm going to do lang cn. Let's see what it does. Let's understand this expression. Oh, it returns the value. So what I'm going to do is for key in lang, right? Print key. So you can see here it is printing the key. What if I use that key like this according to the above expression? According to the above cell expression, right? This expression, what if I use that key like this? Right? So I think this makes sense, isn't it? So this makes sense here. So this time, don't get confused, guys. Any name can be here. It's just variable, right? So don't get confused if I use lang or if I use a key like that. So it's one and the same thing. Okay, so it is printing the values here, right? So it's like that. So if I do like this, right? So key. So guys, can you answer me exactly what is the expected output this time? E in English, key and value, that's true. FR French, E in English, and so on, that's true. Ravindra, I need to verify your, right? Just be with me, right? I'll try my best. Thank you, everyone, right? That's good, yeah, that's good. Okay, this is beautiful, right? This is beautiful, it is going good. Now, in the next demonstration, what I'm going to do is I'm going to show you a standard way of retrieving the key and values both, right? So let's look at the standard way of calling the keys and values, right? So how we do that? So in that case, what we are going to do is for key comma v, that is key comma value, right? It's like that. In lang.items, right? There's a function called items, right? What item does, it returns the key and value both, right? It returns a key and value both. So a list cannot be a key, right? So if they ask me, can key be a list? Can key be a list or a collection? A key has to be immutable. A key cannot be immutable, right? So it's like constraint. Coming back to the items function. So this function, the items function, returns key comma value. So as per the expression, the key and value is supposed to be stored inside k and v. So if I print k comma v, so you can see here, it is printing the same thing, right? So it's like that. So here we have successfully, completed this part. We have extracted the value, and we have printed the value. And okay, just wanted to confirm, guys. Uh, uh, are you? What you can do is, like, if you want to add some more values, you can simply put this line lang. Let's say TL equals Telugu, right? And simply lang. So you can see that the Telugu has been added in the dictionary. So you can use this expression to add the value, right? Add the values in dictionary later, right? So in case if you're interested, adding some more values. And one more thing, guys. Okay, I'll give you some example here. Let's say if we have a table, right? So if we have a table, uh, how to use list, right? So if you have a table, let's say 1 Ram manager, 2 Sham programmer. So let's imagine that we have a table here in some RDBMS, right? And this is a table called employee, right? And how are you going to represent this thing in Python? So in Python representation would be like employee 1 Ram manager, and then the second row will be added like to Sham, and he's a programmer. So guys, you can see here that how list is comfortably and perfectly suits the structure of a table in RDBMS, right? So things make better sense when you use them with something that is there in production environment, or that is there in the real life sense kind of thing, right? So when you are into let's say object-oriented programming with me, right? So when you will be learning object-oriented programming, so things will make more sense, right? So how things like tuple, list, or dictionary gonna fit better with examples, right? So just giving a small example here with this RDBMS structure, assuming that you are aware of RDBMS and tables. So you can easily understand that how this Python list DS helps in fitting that data, right?
Now, if you're watching this, you probably love Python and coding. But have you ever thought about taking your skills to the next level? Introducing the postgraduate program in Data Science and AI by IIIT Bangalore, brought to you by upGrad. This isn't just another course, it's a game changer for your career. Here's what makes it special. You'll earn a prestigious certification from IIIT Bangalore, a leader in tech education. Don't wait, enroll now and start your journey to becoming a data science and AI expert. Click the link in the description to find out more about it.
In today's session, guys, the agenda is, the OOP essentials, right? So we'll be talking about the object-oriented programming today, which is one of the important factor, right? One of the important factor in coding constructions or application development. We'll be talking about the functions and and their types, right? What kind of functions we have available in Python. Then we have the classes and objects. We have already been all right. We have not been working with class and objects. So in today's session, we will learn how to work with the classes and objects, and then there are exercises and summary. I think that's it. All right, so I'll take care of that later. Fine. So okay, so as you can see here, guys, in my next slide. So what I have here, right? So in my slide, you can see that I've simply, instead of keeping any theoretical part here, so I'm just simply, keeping the labs here in priority, right? Because what I have been observing is that this cohort requires more of the practicals compared to the text theory, right? So that's why I have not included the theoretical content here, right? So I just encourage the participants, once you have mastered the concepts with me, right, please go through the over the internet or some preparatory sessions recording, so you'll find the technical definitions. OOP, right? So what does OOP means, right? So let me take example here. All right. Okay, so here I'm going to use okay, that was a drawing from my yesterday's session. Okay, So here it goes, guys. Okay, so here it is OOP, right? OOP. So remember, it's not OOPS, right? It's not oops, right? So most of the people, many of the people, maybe, you know, defining this term as oops or OOPS. So it's not. It's only OOP, right? So first of all, what I'm going to do here in the first 15 or 20 minutes, I'm going to, create a plot here, right? I'm going to create a plot here. When I say plot, plot basically means the context understanding, right? So we need to understand the context. Okay, fine. So can I confirm, right? So can I confirm, right? If you observe, right? So if you observe in real world, right? So if you observe the current trends, right? So I'm talking about the applications and softwares, right? So both are the same thing actually, but let's take an example here. I'm talking about the applications and softwares. Listen to me carefully, guys, right? I'm just creating the context here. So if we talk about the applications and softwares, right? So can we say that the computers are, so in general term, right? So when I say computers or applications, right, are replacing human work, right? Can I say this, right? So do you agree with this term, guys? Right? The computers or applications are replacing the human works. Do you agree with this? All right. Great. Thank you for your confirmation, right? So the training strategy, the learning strategy is that we'll use our own brains to understand the context, right? So we'll justify the statements according to what is being discussed here. So nowadays, let's say computers and applications are replacing the human work here. So the work which was earlier done by humans, right? Nowadays these are done by applications, right? Okay. Now the work which was earlier done by humans, now it is done by applications, right? So let's take an example of a cashier, right? Let's take an example of a cashier. So what cashier does, right? A cashier, right, can help a user with the withdrawal. A cashier can help a user with the deposit, let's say, right? So you will agree with this term that in banks generally, if we talk about the human context, so the cashier does two operations, right, which helps the users, right, to withdraw their money and to deposit their money. Now, if we take an example of a machine, let's say an ATM machine, right? So you must be aware that we have an advanced ATM machine where we can withdraw and deposit both the things, right? We can do withdrawal and deposit here, right? Isn't it? So there are some ATMs where withdrawal and deposit both are possible at the same time, right? That means in the same machine. Now, here, there was a human which was doing the task, and there is an application which is doing the same task. Now, if I proceed further, okay, if I proceed further with this explanation, right? So, like what I learned from this example, what I want to make you learn from this example is that applications, applications can mimic human behavior, right? Applications can mimic human behavior. So guys, do you agree with this term, right? Can applications mimic human behavior? Whether it is insurance sector, whether it is telecom sector, whether it is banking sector. So what applications are doing, they're mimicking human behavior. So if we follow the, a real world example of, let's say, a high level example of, let's say, hardware and software, so you'll find the robots, right? What robot is exactly? Robot is the human representation. It's you can say, what do you call that? There is a term for this, impersonation probably, right? So it's just like mimication, right? Mimicking, right? So that's what the word I want to use here. Yeah. So now the question is that, right, now the question is that how applications can do or can solve a real life problems, right? So that is the question here. So how applications can solve real life problems, right? Okay. Now, so according to the previous example, withdrawal is I'll not, okay, I'm using a wrong word here actually. Real world challenges, that is the right word. Apologies for that. So how applications can solve real life challenges, right? So withdrawal, according to the previous example, withdrawal is one of the challenge and deposit is one of the challenge. Earlier it was done by human, now it is done by ATM. So that is an application. Now, if you want to, right? So if you, right, if you want to mimic, right, if you want to mimic a real, okay, sorry, I'm using the wrong statement once again. So if you want your applications, right? So if you want your application to, behave or, represent human behaviors, right? So if you want your application to behave like a human, let's say, or like respond like a human, right? So according to the challenges, present the relevant output properly, right? So you need to learn certain principles, right? You need to learn certain principles here. So that is the point here, right? So if you want your application to, behave exactly or solve exactly the real world problems, right? So I'm just using another term, solve a real world, once again, challenges, right? So if you want your application to solve real world challenges, right? So you need to apply certain principles, right? Apply certain principles, right? Principles into your programming, right? Principle, apply certain principles in your programming, right? So those principles are given a single term, and that is called object oriented programming. Right? So that is called object-oriented programming here. Or in simple words, we call it OOP. So what is the point here? The point here is that, so when if somehow, right, if I make you understand exactly how to, I mean, first of all, what are OOP principles, right? What are these terms, and how to implement these principles in your programming so that you can solve the real world, right? So I'll give an example here of a real world problem here, right? So for example, suppose I'm really sorry, I'm really bad at the designing. Still, I'm learning how to, see, this is going to be really bad. I don't know how I'm going to, do this. So this is something. Okay. So sorry, guys. All right. So you might be wondering what that creature is. Woof, it's not meow meow meow. Hemant. Okay. So this is a dog actually, right? Yeah. So so this is a dog, guys, right? So I'm really bad at designing, right? Okay. So this dog is actually barking, right? So this dog is actually barking, right? Okay. So what this dog is barking, it says woof woof, right? So this is a okay, real life representation of something, right? So it's a real life representation of dog, right? So this is a real life representation of a dog. Okay. Now, can you code this above a picture? That is the point, right? So if somehow if you learn OOP, right? So as a summary, right? If you learn OOP, right? So if you learn OOP, so what you can do is that you can turn the above picture into code, right? So when I say you can turn the above picture into code, now what does it mean? What I'm trying to say here? Can you respond me exactly? Like if I say that if you learn OOP, you can turn the above picture into code. Now what I'm trying to say here? So if we learn OOP properly, right? So we can simply convert the above picture into into code. And what do I mean by that? It means that you guys, you developers, you the IT people can code anything real, right? So you guys can code anything real, right? So what does it mean? It means that if there is a challenge which is there in the real world, right? So let's say if there is a new company which is starting their manufacturing unit, and they're creating certain products, and for the automation of those products they need some applications. So in that company, right, in that manufacturing company, whatever the real challenges are, you can simply construct the real challenges into programming, you know uh, representation, and that is going to help you building better codes, right? So you can see here that in today's session, once again, right, so in today's session I'm talking about the construction of codes. Here I'm not talking about solving a problem, right? So in today's session I'm not aiming for solving a problem. No, I'm not aiming for solving any problem, right? And any output based problem, right? I'm not looking for any 2 plus 2 equals to 4. I'm not looking for any 4 kind of thing, right? The I'm looking for the principles that can help me in constructing better codes, right? So this is the agenda of today's session. So after this theoretical part, right, can I ask my participants, like, are you exactly clear why we need OOP principles in programming? Did you understand exactly what we are talking about here, everyone? Can I have the confirmations, right? Your confirmations will help me in delivering you better. Yeah, yeah, good, great, great, excellent. Okay, yeah, that's true for the construction of proper codes, right? So yes, Saroja Devi, I'll just tell you, right? I'll just repeat you once again. So in today's session, we are learning basically OOP. OOP are basically the principles that help you, real-time solutions or that help you represent the real-world challenges in programming, right? So what are the principles of OOP, right? So when we talk about OOP, right? So there are certain characteristics of OOP. So here, the characteristics are class, object, right? There's something called encapsulation, and there's something called abstraction, right? There's something called polymorphism, and there is something called inheritance, right? So these are the fundamentals actually. So what does OOP consist of, right? What principles does this OOP consist of, right? So this OOP consists of mainly 6 principles here: 1, 2, 3, 4, 5, 6, and the principles are classes, objects, encapsulation, abstraction, polymorphism, and inheritance, right? Now, now whenever let me tell you. So basically what these characteristics are, right? These characteristics are inspired, right? These characteristics are inspired from daily life or routine life or challenges, right? So whatever you understand. So what are these things, right? So I want to say to all of you is that, right? I want to say to all of you that these characteristics are inspired from our daily life. So you guys, right, you guys are the IT people, right? I'm also a human, right? So basically these characteristics exist in our daily life, right? So these are some technical terms, but these technical terms are constructed by the programming architects by looking at the human behaviors and how humans solve their challenges and how humans represent their challenges, right? So these terms are not ordinary terms, they are there in your life also, right? So as a programmer, right? As a programmer, right? As a programmer, you are supposed to understand these characteristics in your life and in coding, right? Right. So there are two contexts here, right? There are two contexts, right? The above mentioned characteristics are there with you. Now the very first phase is that where are these things with you? That is the first thing, because until unless if you don't understand what are these things with me, so you will not be able to code these behaviors in programming. So in today's session, right? So in the OOP session, I'm going to discuss about classes and objects. The very first two things here, and the second, I'm going to talk about the inheritance part here, right? So these things I've not included just because of the shortage of timing, but I hope that with the foundation of these three, you can cover these three later. Still, if you have any doubts or queries, you are most welcome to ask me, right? So within the given duration, I'll try my best to solve your queries as well. Now, the very first question, right? So this is the question for people, who are already having some sort of knowledge about the OOP programming. So we're going to discuss this thing, right? So my question to the people right here is, how do you define the classes and objects in your daily life, in your life? So where are these things around you? So my question to all of you, right? So those who have some sort of experience. Okay. So in order to understand, right, in order to understand this term here, right, so I agree with all of you, right? Most of the participants are, telling me the right thing here, but I'm going to make it more clear, right? So let's see what we have here, right? Okay. So, what I'm going to do is that I am, okay, fine. So before, okay, I'm just confusing myself. Yeah, before I start discussing the concept, right? So I want to tell all of you, especially, right, the way a programmer sees the world is a very different from how a common man sees the world. That's the first point that I want to say to all of you, right? So the perspective, right, the perspective or the view, right, the perspective or the view of a programmer is way different from how a common man think or sees the world. That's that. This is the sentence that I want to start with, and let's say exactly whether you are able to differentiate between your left hemisphere and the right hemisphere. Let's find out how it goes like. Okay. So I'm going to ask you two things there, right? So your choices, right? I'm going to say two statements to all of you, right? And your answer choices are yes and no. It doesn't matter what your answer is, but your choices are yes and no, right? So we're going to, play a small fun game here. So let's get started and listen to the statements carefully. Ultimately, we'll land at what the class are and what the objects are, right? And it is going to be a little difficult for some people to grab the context, but let's see how it goes like. I'm very much sure that I'm going to have 90% plus consensus here. So rest 10 plus can discuss it with me, or, they can just simply, process the information, right, over the time. Okay. So here it goes like, so I'm going to say two such statements here. So my first question to all of you is, can you smell a flower? So what's your answer, guys? Can you just quickly respond me, guys? I want to see some quick responses here. Everyone, come on, come on. See, a generic question, right? I'm not asking you to simply bring a flower right now, right? Or please don't say that I don't have flower right now. Okay, so a generic question. Okay, so I've got good responses here, right, from the. All right. So my question to all the people here is that if you say, okay, that's ugly, right? So if you say flower is logical, my question to all the people who said yes, who can smell it, my question is, if the term or the entity flower is logical, how can you smell it? My question to you is this. Why you said yes? You're saying that the term or entity flower is logical, and at the same time you're saying that the flower is logical and you can smell it. How? A generic version, Eric. I'm using a generic term here, right? So I'm not going into science of flowers. A simple generic flower. Okay. Yeah. Yeah. Okay. Okay, my question to all of you, right? So still there are some people who are still confused, right? So people who say that the flower is physical, right? So can I ask you, can you draw a picture of flower? And at the same time, can I ask you, if you compare the picture of rose and the picture of flower, please don't draw daisy on the name of flower. And please don't draw daisy on the name of flower. So can you draw a picture of flower? That is the question. That is the point, right? You cannot draw. You cannot. Some people, you see, I told you in the beginning, right? So it is going to put pressure on your left hemisphere and the right hemisphere. Yeah, it's generic. Okay. So, okay, I'll just finish this quick part here, right? The term or the entity flower is logical, right? So I'll call it in English, right? So for better understanding, I'll call it in English. We can call it a category, right? We can call it a category, right? So you can when I say category, so in English you can observe that. Okay, think of anything, right? Think of any category. All the categories are logical. Think of any category. All the categories are logical. For example, let's say when I say continent, what do you think? Continent is physical? No, right? Continent is not physical. It's a category. Right? It's a logical thing, right? So when I say Asia, oh sorry, uh, Russia, right? I hope I may be bad at this example. Right? Russia is a continent, let's say, if I'm not wrong. If I'm wrong, please correct. Right? So this is a physical example of what continent. Okay, I'm very sorry. I need to learn the geography, but I need to stop this programming for some days. So Asia is a continent, right? Okay, thank you. We are having fun here, isn't it? So Asia is an example of a continent which is physical, but when we say the term continent, it is logical, right? So in the same way, the flower is logical and the rose is physical. So when you say you can smell flowers, that's actually wrong, right? You cannot smell a logical entity, right? So I hope you all will agree with this. And rose is physical, so yes, you can rose is physical, so definitely you can smell it, right? So that is the point here. Now if I proceed further, right? So let's take some more examples here, right? So let's take some more examples, right? What is the difference between in terms of logical and physical, right? Okay, in terms of logical and physical, can you see any differences in these two terms? Right? Can you differentiate? Yeah. So can you just elaborate it? Can you just elaborate it? Yeah, that's true. That's true. That's true. Great. Great. So, okay, in real world, let's take one more example here. So if we call it, let's say, employee, you don't need to answer me, right? You simply look at this. And we have Rajesh here. Just identify the difference in being physical and being logical, right? Just identify the difference in what is logical and what is physical. So that is the question, right? So, okay, general question to all of you: who can work for the company? Rajesh can work for the company, or employee can work for the company? I'm having a mixed responses here, but mostly I'm getting the please do not please do not think of Rajesh can be anything, right? Rajesh is a representation of employee here, right? Rajesh is a physical representation of employee. So I'll call it, okay, let me call it, right? So, there are chances that participants may be, drawing some better visualizations, right? So Rajesh is a physical representation of employee here, right? So specifically, right? Okay, who can work, right? So Rajesh can work. I'll tell you the reason, right? See, now the question is that why the logical things are given, right? The question is that why the logical and things or categories are given, right? Why the categories are given? Let me, explain you here, right? So why the categories are given, to describe the behavior, right? To describe the behavior of physical representation. To describe the behavior of physical representation. So when some people say class is a template or class is a blueprint, what does it mean? Right? So you are giving me technical definitions. That's true actually. But if you go with the context of this definition, when you say class is a template or class is a blueprint, what does it mean? It basically means that you're basically describing the behavior of your physical entity. That is your object exactly that I'm talking about here. Right? So, okay. Okay, Pradeep, okay, fine. So, fine. Yeah, I'll just repeat it for you, right? Okay, I'll just repeat it for you. Okay. See, for the common people, let's take another example. Here, boy, right? For a common man, right? This is a physical thing, right? Let's take an example here. For a common man, this is a physical thing, boy, right? But for me, right, if this is going to make some sense here. Let's say boy and Rahul, right? So what is the relation between these two things, right? So you'll see that Rahul is basically, he's a boy exactly. He's a boy, but he is a physical representation of y, right? Okay, he's not a boy, he's a physical representation of y, right? Rahul is a boy, right? You can say, but right, it's a boy exactly. So Rahul is physical, right? And the boy is logical, right? It's a logical thing. So it's a category, right? It's a category, and this is the physical representation. Okay, let me just close this description here. Let me close this description. Let's conclude this thing. The category part, the logical part, technically we call it classes, right? Technically we call it class. And the physical part is called object, right? So I'm just telling you exactly the identification, right? How you how you identify the classes and objects around you, right? The point is that how you identify the class and objects around it. I told you that OOP has got class and object as its characteristics. So I told you in the beginning that you need to understand these terms in real sense and in programming sense. So let's say an example here, right? So here in this example, who is the class and who is an object? The very easy, formula to understand who is an object. So all objects are physical, right? All objects are physical, and the categories are called classes, right? So the logical part is called class here. So it's just identification. So I'll just call it like this: flower is a class and rose is an object, right? So try to differentiate in these things, right? Okay. Car has been a traditional example, right? Most of the people say that, okay, condinia, right? According to your statement, most of the people say that car is physical, but I say car is not physical, right? Can you drive a car? You cannot drive a car. Easy, right? How? Why? The reason, because cars are just the categories. So if you, let's say, if you say Honda XYZ101, right? Can you drive Honda XYZ101, or you can drive car? That is the question, right? So you need to differentiate these things in your minds. I told you in the beginning, right? So the perspective is different, right? I come to Rajesh, vehicle part also. So you need to differentiate between the things here, right? No, money. I'll just come to that part later, right? There are many other concepts, right? So let's phrase it to the simple ones here. So guys, can I ask my participants, is this making any sense to all of you? Yeah, Tony, I'll just do that. Some. Okay. Okay. Fine. So I'll take one more example here, and then we'll jump to code, right? I'll take one more example here, and then we'll jump to the code. Okay. Now, can you see this, guys, right? Dog. And then we have an example here. Let's say Russell. Okay. I believe I'll take the generic example, Tommy. So this is going to make sense to most of the people here, right? Okay, so we have these two things here, right? The dog and Tommy. So I will not, I will not mark these things, right? I will not mark these things as class and objects, right? I'll proceed with the public opinion, right? So how will you categorize these two terms in terms of class and objects, right? What do you think, guys? Which one is a class and which one is an object? Right? See, I'm not proceeding further, right? It's just you who is telling me according to what you have understood. If you are not still not clear, just find out which one is physical and which one is logical. Yeah, yeah, that's great. That's great. That's great. Yeah, good. So my question to all of you, right? Let's proceed further. And I'm going to say a sentence here. You're supposed to answer me within 1,000 milliseconds, right? So I'm going to say a sentence here, and you're supposed to answer me in 1,000 milliseconds, right? Okay. So in all of my examples, I'm going through the generic version, right? So here I'm not talking about the Russell Terrier or the Mastiff breeds, right? So please exclude all the complex things here. Let's keep it simple for the understanding. So here is my statement, guys. Answer me in 1,000 milliseconds. So my question to all of you is: can a dog bark? Yes or no? Come on, yes or no? Come on, can a dog bark? Come on, quickly, quickly. Great. Great. I can see some good responses here, but people, the participants who are saying uh, that dog can bark. My question to all of you is that you say that dog is logical, dog is class, and at the same time you say that dog can bark. My question to you, once again to you, is that how can a dog bark when you're saying that dog is a class, isn't it? Okay. Okay. One more thing, guys. Right. I want to keep some things, some generic things here. I'm just keeping some generic examples, right? So I'm not talking about the breeds here, right? I'm not talking about the quality here, the height and weight here, because yeah, money. That's true. From the programmer's perspective, dog can't bark. That is what I'm trying to say here, right? Okay, fine. Let me tell you exactly a few things here. What I was telling. Okay, in terms of IT, no. That's what I'm trying to say, Eric. That's good. Okay. So you can see here, guys, right? So there is a yeah, there is a method, right? There is a behavior, right? Bark, right? There is a method or behavior, bark, right? And this bark behavior belongs to the dog, right? But a dog, this is the behavior, right? This is the description here of the category here, and Tommy is a physical entity, right? Tommy is an object, right? Tommy is an object. Oops, that's really ugly. Okay. Okay. Okay, where is my zoo? Yeah, the Manas, that's true. The characteristics of the dog class would be barking here, right? Okay. So the point is that why we need objects, right? If you still not clear, right? The point is that why we need objects, right? Because objects can perform action, right? Because they are physical. This should make sense, right? Because objects are physical, that's why they can perform action. So when I say action means Tommy can bark, right? So that's why we created the Tommy. If we don't have Tommy, a dog cannot bark, right? So object is the realistic, real life representation of your category or class, right? Yes, Siddharth Nair, that's what I'm trying to say here. Objects represents the real world entity, right? So let's take an example of, let's say, manager. Okay, that's really ugly. Okay, fine. So let's take an example here of an IT company. Let's say manager and let's say Raghu, right? So when I say manager and Raghu, what is the difference here? Raghu is representing a physical entity, a real entity, right? And the characteristics of Raghu, what Raghu does, how Raghu behaves, are defined by its category called manager. Right? So that's what I'm trying to say here, right? So I think this should make some sense as of now. Okay. Are things getting better, guys? Hey, money, come on. Okay, great, great. So now you can feel that the OOP is helping you in constructing the real life challenges in programming sense, right? So let me go through the programming here, right, and the content. Prompt. Okay, let me go through the programming. Eric, I'll call it as a namespace, right? I'll call it as a namespace. So in context of Java, you can say, you can take example of packages if you want to categorize animal and dog, right? So you can say that animal is a container, right? It's like a module in Python which contains a lot of classes, right? Okay, so still not, if still not understood, Eric, I'll give it an example here, right? If you want, right? So for me, like, okay, so you can consider animal as a package, as a container, right? And cat, dog, lion, these are the classes. Let's take one more example here, right? Let's create one more package or container or a module here, which is called human and male and female. What are these? These are the sorry, classes, right? These are the classes within the human, right? Container, no, Divya, container basically means the modules, right? In Python, we call it modules, right? What are modules? They are just basically the container for multiple classes. What are modules? They basically the container for multiple classes. That's it, right? It's just a container, right? It's just a it's just a organization thing, right? Code organization, right? It's just a code organizing activity that we're doing here. Yeah, HG, I will definitely give you example. Let me just go through the construction of code first of all. I'll definitely keep that thing in mind. Okay. Yeah, there are many predefined modules, Abhinav. such as time and like sklearn, TensorFlow, machine learning. All these, domains are going to take advantage of only the predefined modules. Right? Okay. Twitter notebook. Modules are basically the files. I'll call it. Modules are physically files. Tony, files. Right? In one file, you construct multiple classes. Like let's say abc.py, right? No, Tony. Yeah, G ready. Modules contains classes. M Mantha, we call it namespace here in according to you can call it Python vocabulary. So the Jupyter is starting. It's going to take a while, I believe, and still working. Okay, come on. It's taking longer. Okay. Alok, a very good logic. That's a good humor. Great. I appreciate that. No, Anjul, it's I5 actually. The Anaconda, this thing is little slow. Yeah, Vijay, I will. Basically, I don't use the Anaconda distribution directly. I'm using the Anaconda prompt, right, which is a little quicker than Anaconda distribution. Okay. Okay, great idea. So I'll just click on new and then Python 3 here, right? Okay. So I'm going to take few concepts here, right? So okay, it's object oriented programming, okay, and here we're going to take advantage of uh, uh, classes and objects here for the construction of code, right? So basically, in this demonstration, we're going to construct the dog's behavior, right? The dog's behavior, sweet dog behavior of let's say barking here, right? So it's just a small example, right? Right? Okay. So let's do this. So we have a class called dog pass. Okay. Now, first of all, right? Now the first one. Okay, so there's a class called dog here, everyone, right? So you can see that I'm using a keyword here which is called pass here. So we need to understand, and this was asked by one of the participants to me also, that what is the purpose of pass keyword. So, what is this first of all? What we are seeing here, right? So this is basically the blank class, right? So if you want to create something blank, right? So, you cannot, create a blank class like this first of all, right? So you're not allowed to do this, right? But other languages, other programming languages allow you to do this thing, right? So let's say if you say class, okay, in terms of Java, right? So in terms of Java, let's say if you create a blank class, you can do like this, right? But in Python, you cannot keep a class blank, right? Like this. Yeah. So, you can see here that, okay, so if I execute this program without, like this, so if I execute the cell right now, you can see that I'm getting a compilation error. Reason because, Python programming doesn't allows you to create a blank thing like this. So if you want to, prevent this compilation error at the same time, if you want to, keep the things blank, right? So you just use the keyword pass, right? You can see here, right? So pass does nothing. It's just a filler, right? It's just a filler. It's just a filler, right? So we use this keyword pass for preventing the compilation errors. So let's say if you are constructing a blank function or if you're constructing a blank class, so in that case, you can use passes or blank loops as well. Thank you, Siddharth, for that. Okay. Yeah, and you need to observe this construction here, everyone, right? You can see here that after the class, I'm using a colon here. So that is a part of syntax, everyone, right? So please observe this thing, right? Okay. Now here, what I'm going to do is that, I'm going to construct a method here. Right? So let's learn construction of method, right? Construction of method here, right? So how we construct the method in Python. So it's like def, uh, let's say bark. Okay, so this is how we construct the method. You can see here. Yeah, Harsh Srivastava. No, Harsh Srivastava, parenthesis is not required after the class name. Okay, so you can see here, I've constructed a method here, bark, right? And please observe the indentation, especially for the new learners, right? So who are people who are especially starting with the programming. So next step is to construct the object. Now, a small alert for all of you, we construct the object outside the class, right? A small alert for all of you, we construct the object outside the class. So you can see here, I'm pressing backspace in my keyboard. I'm pressing backspace. See, I've pressed the backspace. Now the cursor is outside the class scope because I'm not following the same indentation gap. Can you see that? Right? I'm outside the class right now. Okay. Now here we are supposed to construct the object here, right? So what is the syntax of constructing the object here? And the syntax goes like this. All right. Tommy equals to dog. All right. So here, the object name can be anything, everyone, right? The object name can be anything equals to dog. This is the construction of your what? Object, right? Okay. Construction of object. Now, in the next step, invoke the method, right? No new. Gotham, no new keyword. Dot bark. See, I've executed the program, and it's a very simple generic program. You can say here, it's not stuff with a lot of code, right? Arun, yeah, I initialize the class members or constructor here, right? We don't use the new keyword like we do in Java or C Sharp, but here we don't use the new keyword. It's not given here, right? Okay, Bhav. Yeah, great. Yeah, I can, this is a, okay, a bar, okay. So this is a constructing method, right? Yeah, this is a constructing method, right? Construction object calling function, right? Calling function. Now, there is a very good question from the participants here, right? So the question is like, what is this self keyword, right? The question is that what is this self keyword? Now, this self keyword is actually your object, right? This self keyword is your object, right? The self keyword is your object, guys, right? So who is object in your program? The object in your program is Tommy, right? So this self is the same Tommy, right? So basically we are using the object reference here, we're keeping the object reference here, it is required here, right? But in other programming languages this object is automatically taken care, such as in Java. In, let's take an example of a Java. I'm just using the comparison here, right? So this is a keyword, this is a keyword in Java, which is basically the object reference, right? So here instead of this we have self. What is self? Especially for the new learners, it is just the object, Tommy. Uh, self is just a term here. Self is not the keyword here. You can write A, B, C, D, E, F, whatever you want, but ultimately you need to understand that this ABC is going to contain the reference to your object. That's the only thing that I want to say here. We don't pass the object here, it is automatically supplied to self, right? We don't supply the Tommy to the self, it is automatically taken care by the Python environment. Yeah, it's like a call by reference, you can say like that. Self.xx is correct. That's true, Sandeep, that is correct. Okay. Yeah, Shubham, I'll definitely do it for you. Now, I'll tell you one thing here, right? Yeah, I can put Tommy here, right? So it is not going to make any difference here. Still, see, I've executed the program. It's the same thing, right? It's the same thing. Either you write Tommy or self, both are the same thing. Okay, Anish has a question. He says that what is the difference between class and def? A class is a keyword which is used to construct a class. So in real world, dog is a class. So how we construct the dog class in programming using the class keyword, and bark is a method, it's a behavior of dog. So how we construct the behavior or a function of your program class dog in Python, and that is using the def keyword. Def means define. Okay, so there are a lot of questions which are being asked here. I'll just can you simply post the questions to the Q&A section so that the scrolling is not a limitation for me, right? Dheeraj, lambda expressions are allowed, right? You can use lambda here. Uh, yeah, see, guys, I can see that the questions are getting scrolled, right? So please post the question in the Q&A section. I'll answer them. Sripriya, we don't have access specifiers, right? So, but still, we have some techniques of, you can say that specifying the things as private by default, all the things are public. But Python is really bad at this access specifier thing, right? It doesn't follow the same kind of conventions specifically. Yeah, Anish, I will share you the lambda expression. Just allow me to complete my session content first of all. Okay. So, it is 1 hour, right? So I'm going to take the Q&A section here for a while, and then I'm going to proceed further. I'm going to extend the so till the time, in case if you're still struggling with the code construction or if you're doing the practicals parallelly, please follow the same thing. So here I'm going with the Q&A section, guys. In case if the chat is not answered, please post the questions in the Q&A section. All right. Nidhi, okay, you missed the first test session. The clarity is good, not good. Nidhi, can you please elaborate exactly what kind of clarity you were looking for? So I'll definitely look into that matter and I'll let you know about the content. Rajshekharan Parma Sivam. In C and Java, we used to have hash include and similar in upGrad, Python code simulator, but we don't have it in Jupyter or we don't require in Python. All right, Rajshekharan, as per your question, I'm not using any built-in module specific library here as of now, but I will be using probably from my next session. So we'll be using all those import statements in our Python code, Rajshekharan. Eric, principles are process, so you can say they are same kind of same, right? So you're supposed to follow the principles. At the same time, you're supposed to follow the process. So sounds similar. Manish, method is not a part of OOP. Reason because method is a part of procedural style programming, such as C language, right? So C programming follows procedural style. So when I say procedural style, it's a functional approach, right? So it's not a part of OOP. Milind, I agree with you. Categories are logical, and the items within those categories are physical. That understanding is absolutely correct. So I'll give an example here. So actor is basically a logical entity, actor, and Chris Hemsworth is the physical representation. So actor and Chris Hemsworth. So in this example, actor is logical, and the physical representation Chris is the physical thing. So that is an object. Sumit Satapathy. Okay. Yeah, Sumit Satapathy has a question. He says that the identification of class and object, right? So I want to say something to all of you here. So, there are many participants here who are getting confused. Let's say, what is animal or dog or Tommy? So, what is the relation between animal, dog, and Tommy? So, how should I correlate them? How should I, identify them? So, that is the kind of confusion which is going on here. So, I want to tell all of you guys, it's not only there is a concept of classes and objects, right? It's not only for the real entity representation. Not only class and objects and categories which are available in OOP, right? Apart from that, we have inner classes, we have static classes, we have abstract classes, we have interfaces, right? So there are n number of other sections also which justify your confusion, right? There are and modules as well, right? So there are n number of different topics available which justify your confusion exactly that. Okay, so because you have not covered or you have not completed the content completely, that's why there is a confusion. So I would categorize this like this. So let's say an example of animal, dog, and Tommy. So here in this example, we can categorize animal as a module, dog as a class, and Tommy as an object, right? So you need to extend your knowledge to completely clear your confusion. I'm trying to do that. So, and you're supposed to take it further with more practice and learnings, and it's going to take a little extra time, some more time to understand all the concepts. But that is not a bad thing if you're confused, because it is bound to happen when you're learning something new. Sumit Satapathy. Azhar Hussain. Azhar Hussain has a very good question, right? Azhar Hussain has a very good question. I would like to take this question here, right? Azhar says that can we define a class as a group of objects, right? So let me show you here, right? Okay, Azhar, look at this. Okay, okay, okay. Just a second. Let's say POXO, P1, P2, P3, P4. Azhar, look at this example carefully. I'm repeating the question of Azhar once again. Okay, there's a doubt here that a class is a group of objects, right? So I have a class here, POXO, and there are four objects here, P1, P2, P3, and P4. Now, my question to all of you: are you able to understand the behavior of these objects, or what this class does? Can you elaborate the functioning of anything with a class or object here? Are you able to identify anything out of this information? No, that's true. Okay, let me give some more detail here. Play, pause, stop, seek, record. Now, my question to all of you: if we want to understand, the class, if we want to understand the behavior, right? What things are helping us? Are the attributes or the functions or the properties helping us, or the objects are helping us in understanding the behavior of class? So which section is basically helping you in understanding the behavior of your class? Is it the characteristics of your class, or is it the objects? Yeah, that's true. So this basically confirms that a class is not defined by the objects. A class is basically defined by the characteristics. So there is a technical definition here. What is a class? A class is basically, a class is basically a data type, an abstract data type, we call it, which is basically a set of methods and attributes, right? So a class is basically an abstract data type, which is a set of methods and attributes. A class is defined by its method and attributes, not by the objects, right? If objects are not existing, doesn't mean that a class cannot be defined. But if attributes and characteristics are not existing, at that time, a class cannot be defined and objects cannot have the behavior. Yeah, my PC, that's true. Hi, my PC, if you observe, you're talking about the member variables. What are these? These are the characteristics of classes only, isn't it? Yeah, that's true. So coming back to the Q&A section here, hope Azhar, you understood the example here. Right? Can you confirm me, Azhar? Yeah, thank you, Azhar, for that. So I've got a lot of questions here. What's the time, right? 9:30. So I'm going to take a few more questions here, and then I'm going to proceed further with the programming. I'm going to come back for the questions, right? Mir Mohammed Murtaza. So what is self keyword, right? So here, the object of your class, right? So here you can see here, the object of your class is self, right? So that is self. I'm going to show you the demonstration to help you with that. Yeah, Ambuj, that is not passed to the parameter. That's just always, it's just always there. Okay, SG has a very good question. SG has a very good question here, right? So does a function have to be defined within a class? And the answer is no. You can have functions outside the class as well, right? So that is my answer to you, not to confuse you further. Yeah, fine. So I believe that the remaining question can be solved with some more practicals here. So let me do the practicals, and then we'll see exactly what things are going on here. Okay, so let's do this, guys. Global functions. That's true. Okay. All right. So let's do some more programming here, everyone. So let's say we have a class called, let's say, employee. Okay. So I'm just constructing the code here, right? Okay. We have a self pass. I'm adding some more things here, guys. I want to tell you something, guys, right? I want to tell something to all of you. You have not learned sufficient as of now. You have not learned sufficient, right? Please listen to me carefully. So please let me go through some more codes so that you can understand exactly what is happening here. And I will, definitely, solve your doubts as well. So first of all, I want to introduce you something called constructors here. Constructor. Right? So I want to introduce something called constructor here. So what is a constructor, first of all? A constructor is basically a special method, right? A special function. It's a special function, right? Now, when you create the object of your class, right? When you create the object of your class, here I'm creating an object of my class, EMP, or let's say Rajesh. Okay, let's call this Rajesh, right? So, okay, EMP is better because I have a plan for this. Okay. I have an object here, EMP, and this is the name of your class. It looks like name of your class, but this section is responsible for calling of constructor, right? So this is a constructor. What is a constructor? A constructor is a special method. Now I'm going to tell you exactly how we use constructors. I'm going to tell you that. But first of all, please look at the syntax of construction of constructor. Please, right? Look at the syntax of construction of constructor. It's like def double underscore init double underscore. Self is as usual part of your function declaration. Print constructor invoked. Can you look at this output, guys? So does this output confirms that this constructor is getting invoked? Right? Can you confirm, guys? This line confirms that this constructor is getting invoked. True. Great. Now, in my further programming, please look at this exactly how I'm utilizing the constructor, right? In my further programming, look at this how I'm utilizing the constructor. See, here I'm passing, let's say, Rajesh, and here I'm passing 25,000 or 24,000. Here, comma, name, comma, salary. Is it making some sense to you guys? A constructor, okay, Pratik, I'll explain you once again. A constructor is basically a special function. It's a special function. Now, what constructor does basically? That is a question here. What constructor does? Constructor basically allocates memory to your object, right? Or it is a symbol of allocation to memory to your object. A constructor is invoked by writing this section here, right? This code section is responsible for the invocation of constructor. Now, in my further programming, we'll see that how we take advantage of constructors, right? So here I'm passing Rajesh here. Rajesh is getting assigned to name, and the 24,000 is getting assigned to salary. Now, what I'm doing here, see, now you need to observe that how I'm taking use of this self, right? How I'm taking advantage of this self. Okay, let's look at this. Self dot name equals to name, self dot salary equals to salary. Can you observe this? Now, what I have done here, I have associated these variables with the global variables here. If you remember, I'm not confusing you. Okay, let me show you. Right, def print details. Self print. Hi, your salary is dot format. Self dot name. Self dot salary. See, look at this relation. Look at this connection, guys. Right? Can you look at this connection? How I'm able to use the variables globally using the self object. Look at this observation, right? Can you observe, guys? I cannot do this. If I do this, this means local variable. So it doesn't exist. Right? It doesn't exist. These variables are limited to their functions only. Vijay, self is not different from this in Java. It is equivalent, I'll say. So here, self. Nimalya Das, your question is what self is defining. Self is basically EMP, right? Let me show you. Print EMP dot name. So here I'm passing Rajesh here. Rajesh is going to name. This name is getting assigned to self.name. It's a variable. It's a global variable. The difference is that it's a global variable, can be used anywhere, and it's a local variable. Now, if I print self.name here, it will be Rajesh. And even if I print emp.name here, it will be Rajesh. Why? Because self is emp only, and whatever we associate here is getting associated with emp only, because both are same name. And if we look at the output, we can see here, it prints Rajesh here. Okay. Yeah, Amarnath, it will work. It will work. Yeah, okay. I'm going to repeat it once again. Okay. I went sequentially first of all, right? Okay. So first of all, in this demonstration, we need to observe SG self is not local to constructor. Self is a global object, right? Self is a global object. I will not mind if you replace this self with emp, right? I will not mind. It's just a object reference. It can be stored in any name, right? I will not mind. So if you want to feel comfortable that what is this self, I will say that this emp this emp is traveling in every method, so that we have the same data available in every sections, right? So I will say that this emp is traveling or getting transferred to every method, so that we have the same data in every section of our program or application. We have the same data. So if I am supplying Rajesh from here to name, this Rajesh is getting assigned to self.name. This will be similar here, Rajesh only, and this will be similar here, Rajesh only. So to keep the data intact, to keep the data preserved over various sections of your application, we're using the object here. And in Python, we are not supposed to supply the value to your EMP yourself. It is automatically supplied. It is automatically allocated. Okay. Pratik, I will say that init, double underscore init is the syntax for constructor, right? Okay. Pratik, can you, my PC, can you give me the code sections, right? What you're talking about, caller and callee? What's that context here? Yeah, Ruchi, thank you for asking that question. I will definitely explain you exactly how, the flow is going in this program. Now, first of all, before I proceed further, that is the constructor invocation, parameterized constructor invocation, my PC, according to you. Gautam, I agree with you, right? Yeah, I will tell you, right? My question to all of you is that why this line is not getting printed? Ruchi, I'll come to your question, right? The control flow. Why this line is not getting printed? Yeah, so Priya, dot format is needed. I will explain. Yeah, we need to call this thing, right? Okay. Yeah, print details is not called. So what I'm doing here, emp dot print details, right? Okay. I'm just removing this part here. So why we're getting this error here? Name self is not defined. Okay. I'm using emp here, so I'm supposed to use emp here as well. So I'll change it to self here. Name, okay, and self. Right? Yeah, guys, I'm coming to a question, right? Let me just complete the code here. Fine. Yeah. I'm going to answer each and everything. Let's see exactly whether my explanation answers most of the questions or not. Okay, let's find out. Now, first of all, I'm going to explain this question once again. I'm going to describe each and everything once again, and let's see whether this solves the doubts or not. Now, first of all, the very question which is asked to me is that how is the control flow is happening, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, the point is that how the control flow is happening. Okay? So how the program is getting executed. Now, first of all, I want to tell you that the class section will not execute. Hey guys, I think we got disconnected for a while, for a few minutes, I believe. Hey guys, am I audible to you, everyone? Is it audible? Okay, great, great, fine, fine. Fine. So let's look at the sequence here first of all. So this section will not be executed. The execution will start from line number 10, right? Because it is without indent, right? From here, right? So from line number 10. So from line number 10, we are basically, creating an object here, EMP. And here, this is the invocation of constructor. This is your constructor, right? This is your constructor, employee EMP, this one. So we'll start from line number 10 here, right? We'll start from line number 10. Thank you, Nitin, for that. And this is the invocation of your constructor. What is a constructor? A constructor is a constructor, right? A constructor is a special method responsible for the initialization of your object. In our case, it is EMP, right? A constructor is a special method responsible for the initialization of your object. In our case, it is EMP. Just sharing the same thing here. Now, in Python, if we talk about the syntax of constructing a constructor, it is like this. Init, right? I'm using the gap here. I'm using the gap here, but this gap is not required, right? We don't, use the gap, right? So that you don't confuse it with a single underscore. So that's why I'm saying there are double underscores there, right? So this is the syntax of creating a constructor. Now in this demonstration, I'm using constructor with some parameters here. Why? I'm using constructor with some parameters here. Why? Because I want to initialize some data here. I want to initialize some information here I want to associate some information with the object here, right? So what that information is Rajesh. What this Rajesh is going, where this Rajesh is going, it is going inside name, and 24,000, where this is going into salary. Now this self is automatically taken care by the Python environment, and as this Rajesh is going to name, automatically this EMP will be going inside self. So this EMP is going inside self. So you can see here that we have two methods here. Why we need object reference, so that we can keep the data similar, a common, or we can preserve the data, common data across multiple methods. So this name is Rajesh. So we have self.name here, which will be Rajesh. So self is helping here, if you can observe, right? So if you observe, I'm using the self function, self object here also. Now, the point to be observed here is that what is the advantage of self here? The advantage of self here is that it is preserving the information across different functions, across different sections. So this is the advantage of keeping the self object here. If I don't use self, like let's say an example here. If I don't use self here, right? Okay, so can we remove it? So if I don't use self here, so this variable and this variable are different, right? Okay. Why self? Kanika, the reason is that why we need self, so that we can carry these variables across different functions. You can see that I'm using self dot number one here. You can see that I'm using self dot number one here, self dot number one here, right? Why? How I'm able to carry the data? Because the number one, which is the data here, is referenced using the self keyword. All right, so I think I got lost for a while once again. All right, can you hear me, guys? Am I audible? Okay, great. So once again, guys, I want to confirm, does this program makes any sense to all of you? Is it okay with all of you? Is it better? Okay, fine. That's great. Thank you for confirming. It was a little hard to understand, especially the self keyword. So you can see here, guys, here I'm talking about the inheritance here, right? So here, what does inheritance means basically, right? It's like acquiring the properties, right, from the base class into derived class. So exactly what is happening here, let's find out. So here we have a class called father. There is a method which is there in the father, which is food habit. What food habit does, it prints I like salty. Now there is a class called son, and this is the syntax of inheritance. Now the very first thing, please observe the syntax of inheritance here. Now what is syntax of inheritance? Simply parenthesis and the name of class. Now what this expression means? This expression basically means that the son is acquiring the methods or the members of the father class. Now what do you mean by that? I simply mean by that the food habit which belongs to the father is acquired by son. So can I ask my participants, what will be the default food habit of the son? I like salty. That's true. Now, in order to confirm this thing, right? In order to confirm the acquiring of the members, in order to confirm on the acquisition of this method, right? So what we are doing here, we are calling, we're creating an object here. Let's say Ajay, right? And Ajay dot food habit. So if the acquisition has happened, if the inheritance worked, you can see that the Ajay is printing the food habit, and which is I like salty. Now, in this demonstration, right, I'm not aiming to print a message here. In this demonstration, there is only one thing that I'm looking for is how to acquire the properties of any class, of any other class. What is the syntax of inheritance, right? So this is the syntax, this is the point which I'm aiming here. Now, let's say, right, so Manas. Manas, that's Ajay's print, right? Okay, the print is the method is for a father, but that is acquired by son. So automatically, the food habit will be of Ajay as of now, which is of son. Now, in case, let's say, according to the real world, let's say if the son decides to change the food habit, if the son decides to change the food habit from, let's say, salty to sweet, so we can override the method, override, right? Def food habit self print I like sweet. Now, this is something called overriding. Now, what do you mean by overriding? Overriding basically means that we are basically redefining the content. We are redefining the behavior which we have received from the base into the derived. So here, the food habit has been changed in son. Now the son says, I like sweet. So if I execute the same code once again, we'll see that the son says, or the Ajay says, I like sweet. So this is called function overriding, guys. Function overriding is something which I was not looking for, but this can be done here as an example. So we did that. Yeah, Tapti, we can do that. I think you can do this the same thing with the given example. Yeah, Pratik, it will override locally. And uh, there was a question, right? There was a question about the access modifiers. I missed that. I want to say to all of you, the Python doesn't have good, command over access modifiers, right? So let's say, self dot underscore, let's say private var, right? So this is something which says that it is a private variable, but in Python it is not, right? And in Python, double underscore is actually the private variable, right? I don't want to confuse other participants, just for the people who ask me, right? Okay. Alok Kumar, access modifier is basically, is a set of keywords which lets you decide what variables you want to share with multiple classes. If we have multiple classes, so where you want to share the variables in what classes and where you don't want to. Yes, Harsh, a class can inherit more than one class. Overloading. So one of the participants asked me about the overloading here. So Overloading is basically done in this way, right? So def, okay, Lakshmi, I will show you the addition, right? So let me answer the overloading part here, right? Okay, because it was also I'm going to answer you too, right? Okay, overloading. How we do overloading in Python, right? I don't want to confuse, right? Especially the newcomers. It's just a concept that I'm explaining, right? Def add int num1 int. Oh my God, what I'm doing? Num1 num2, right? Self self equals to 0. Print num1 plus num2. Okay. So you can see here Ajay.add 10, Ajay.add 10, comma 5. So I forgot the name of the person who asked me about the overloading, but this is how we do overloading in Python. Yes, the update is allowed, but you should not be doing that. So I'm going to take the Q&A section from here, and let's find out. I missed all the questions, I believe, because I restarted the session, though, so that's why I've missed the questions here. So if you want to ask me any questions, guys, you are most welcome to post the questions in the Q&A section. Okay, Sheikh Abdullah. Okay, Sheikh, it is kind of difficult in IPython or in Jupyter because it doesn't follow that kind of hierarchy. For this kind of environment, I suggest you to use the PyCharm, right? So that will allow you to easily do that. Yeah, Anjul, we can call the function of father class by creating the instance of father. Today's session, we're going to deal with files, right? So, okay, I'm just going to give you an overview of exactly what are files, and then we'll be talking about file modes. File modes is something which is very important. Then we're going to do something file readings, like something like file reading, and we're going to do something like file writing. And there are a lot of exercises that we are going to do. And in my session, I'm going to do data analytics using the file handling part of Python. So this is something special that I have prepared for today. So we'll be involving some data science here, and out of data science, we will be picking the data analytics part, right? So how we can implement that thing also. Excuse me. Apart from that, in last session, we covered the OOP part, right? The object-oriented programming. Most of you have done that part. I'm going to repeat that part in file handling as well. So what I'm going to do is I'm going to mix, right? I'm going to mix that file handling part plus OOP part so that you can have a good idea about exactly how things together work. And apart from that, I'm going to introduce some inheritance like concept. Most of you have heard of it, right? So how we do inheritance in Python. So that's how I have planned the session so that you can have a mix of everything, right? And finally, we're going to have some data analytics part. Okay. So let's get started. Let's proceed further. I hope everybody is clear about the agenda. And here goes the first slide. So here we're talking about file, right? So file, I'm not going to go through the content here, right? I'll just leave that part to you. So let's go this way, file, right? So let's take an example of a song, right? So we generally, most of us are, like to listen to songs. So we get songs technically in the form of MP3 files. And most of us like to watch movies. We watch movies, and technically we get the movies in the form of .mp4 or .avi files and the .mpeg files, right? So these are files. The best thing about files is that once you push a file into your system, right? Once you push a file into your system, that remains in the system even after a restart. So if you restart your system, right, so that doesn't affect the file uh, storage, right? So it doesn't affect that. So a file, the nature of file is permanent in nature, right? So it's permanent, and basically right now, like why we need file, right? So just answering you this question, why we need files. So if you observe carefully, the the mechanism or the solution that we are using right now for storing the inputs or the outputs, right? So whenever I'm writing a Python program, I'm accepting some data from user, I'm storing that data in a variable, I'm calculating something, I'm doing some math, and I'm generating some output out of that thing. I'm storing the output in a variable once again. So when I close the program, when I terminate the program, all the variables are lost, right? So the input that you gathered or acquired from the user, or the output that you generated after a lot of hectic programming part, so you lose it, right? Once you close the or terminates the application. So that's the problem with the current storage solution, that is variable, and the nature of existence of or the nature of persistence, I will say that. So that is temporary. So in that case, suppose if I ask you to create any application for any of my client, so in that case, if a client is using an application, as soon as the client finishes its work and closes your product or your software, is going to lose the data. And obviously, no client is wanting or looking to lose the data. So you need to have that solution with you where you can save the data permanently. And for that, the best solution for the current time, we have file, right? So if I train you on how to work with files, so you will be able to store the inputs and outputs permanently in the system for future reference. So in case if you have generated some data, some important output, a user or your client can see it once again, right? So that's how it goes like. So that's why we need files, guys. So ultimately the conclusion, the summary part here is that we need files so that we can store the data permanently. I think that makes sense, isn't it? So there is a challenge here, like variables versus files. So when we say variables versus files, here in this case, can I ask my participants who wins? So the chat window is all open to you and it's free to type. All right. Okay, thank you, Himandri. Thank you, Vishnu. So yes, definitely true. Definitely, I can see a lot of responses here. So that confirms that everybody is active and listening. That's good. Thank you very much. Let's proceed further. And now I'm going to take you to the file operation order, right? Okay, let's create a sequence here, right? Let's create a sequence. So here, let's say if I'm supposed to do something, right? I'm supposed to do a file operation, how it's going to be done. So it's a three-step or three-stage process. In the programming part, in the coding part, you're going to open a file. You're going to do either read or write in a file, and you're going to close the file. Remember, closing the file is important. And I'll tell you why closing the file is important. In case if a programmer or a developer does not closes the connection with the file, in that case, the file becomes locked with the current user or the current program. So if any other program is trying to access the same resource, the same file, that file won't be available for any other program, right? So you're supposed to close the connection immediately once you're done with that file so that other programs can access the data or can make the changes in that file, right? So that's how it goes like. So once again, it's a three-stage process. One, you open a file. Two, you do the operations, either read or write. And three, you're closing the file. Now, once again, I would like to clear to the new beginners, right? New beginners. What does read or write means? Read or write means like assume a file like a jar. Assume a file like a jar. When you say read, it means you're pulling the content out of the jar, right? When you say read, that means pulling the content out of the jar. That means pulling the content out of the file. You are reading the data, pulling the content, right? Getting it out. When you say write, that means pushing the data into the jar or pushing the data into the file. That means write. So it goes like that: read and write. So you can assume read and write in context to hard disk also. So when you say reading the data from hard disk, that's basically you're retrieving the data from hard disk. right? And when we say write data into hard disk, that means you are writing some content into the hard disk in the form of files, like that. So I hope this file operation order is clear to my participants. And now I would like to proceed further with my next part. And as I do in my all sessions, I keep the slide minimal. So hardly we have 3 to 4 slides in total. So let's get started. Here we are talking about the file modes, guys. This is really important to understand file modes. I'll tell you why. A file is something which can be used for various purposes. You can use a file for reading. You can use a file for writing. You can use a file for appending. You can use a file for reading and writing both. So basically, Python says, hey fella, tell me what you are gonna do with file. Mode to the rescue. Right. So it goes like this, right? So when you are working with files in Python or even in any other programming language, whether it is Java even, right? So every environment, every execution engine is going to ask you, right, what you are going to do with the file. So for that, you need to have some sort of communication medium, right? You need to tell the Python compiler or the interpreter, right, I'm going to do something with the file, and what that something is mode, right? So let's get let's get back to the slide once again, and let's say what can we communicate to the Python interpreter, or what can we tell the interpreter about what we're going to do. So here there are 4 modes I've taken here. There are more than 4 modes. I've taken the the blessed one. Okay, I didn't want it to confuse you about exactly like messing all around with multiple modes, right? So these are the major and important modes we have available. The first mode that we hear is the R mode, and it is also called the read mode or the default mode, right? So when you say R, so you're talking to Python interpreter, you say I'm going to do R with files. That means you're telling the compiler or the interpreter that I'm going to read the file. So if you say, hey Python, I'm going to do W with the file. So that basically means you're telling the interpreter that I'm going to write some content in the file. Now there's a third mode, which is A. I'll come to this after R plus. So when you say R plus, it means that you're talking to the Python interpreter as a developer, and you're saying, hey Python, I'm going to do read and write both in the file. So it's like that. Okay. And now we have something called append mode. We'll be having a practical on this. Append mode. What is append mode? For appending mode, you need to understand this thing. W is write mode. Execute 1, write hello in file. Execute 2, write hi in file. So conclusion, hi overwrites hello. So you can see here, guys, a small case or a scenario, what I'm talking about here. So if you are using a write mode and you are writing some data in a file, right? You are writing some content in a file. So in phase 1, you are going to write, let's say, a text called hello, and if you execute the same program once again, and this time you input hi in the file, so in that case, it is the hi is going to overwrite hello in that case. So you're going to lose your old data, right? So lose your old data after every new write. So you're going to lose the data after every new write. So this is the problem with W, right? So W is cursed, right? Like that. So just adding some humor here. So W is cursed. So it cannot accommodate new content, right? It cannot accommodate new content. So what we are going to do is I'm going to use A mode, that is append mode, to the rescue. Allows to add content or add new content, or okay, I'll keep it simple. Adds new content at the end of old content. Okay, execute 1, hello. Execute 2, hi. Output, hello, hi. Okay, so it goes like this, right? So we have append mode. Append mode is something which is helpful when you are writing multiple times in the same file. So in the first attempt, if you write hello, and in the second attempt, if you write hi, so it is going to retain the old data and it is going to append the new data at the end of the old content. But if you do the same thing with the W mode, which is cursed by Loki, so it is going to overwrite, the old data, the new data is going to overwrite the old data, isn't it? So I hope the difference between the W and A mode is clear. So guys, can you confirm me whether it is understood or not? So let's see how many participants are active. Okay, thank you. Thank you. Thank you. Okay, that's great. That's great. Thank you. So I'll just proceed further and let's see. Okay, these are the file modes, right? And then what we have here. All right, so it's lab time, right? So let's get into the lab and let's see what we are going to see in the same demonstrations here. Okay, so let's get started. Now what I'm going to do is I'm going to start the anaconda thing, right? So here I started the anaconda thing, right? So it is starting. And what I'm going to do is I'm going to show you the browser. Hey, poor Edge browser, where are you? All right, so I'm going to start my Jupyter, right? Launch the Jupyter, doing the practical as well. So by default, this opens in Edge browser. Can I ask my participants, like, do you see the same Edge browser or the Chrome browser? Like, which is your default one? Let's see. Chrome, Edge, Chrome. Okay, there are a lot of people who work on Chrome and Firefox. Some people are seriously annoyed by Edge, right? Okay, so I'm going to show you exactly how you can, change the browser. So what I'm going to do is I'm going to, simply copy the URL from here, right? I'm just simply going to copy this thing, and I'm going to simply paste it here, right? Okay, how it is working? It was not supposed to work. Okay, fine. So you can see that I just simply copied and pasted the URL in different browser. So it is asking me for a password or a token here, right? So in case if you are willing to change the browser, you can do it like this. So the question is that how are you going to get the token? For that, we're going to do a small hack here. So just observe the hack carefully, right? So what I'm going to do is I'm going to go to the edge, right click and go to the inspect element, right? So that this is a small trick, a hack. We do have standard solutions for this. So here, when you right click on edge and go to inspect element, so there you see something called Jupyter API token, right? So this is the token that the web page is asking. Yeah, so I'm just going to double click on it. I'm going to copy the token here. So you can see the token, right? So I just copied the token, right? And I'm just going to paste it here, and I'm going to log in. And see, beautiful. So I've logged in, right? So just a small hack, how you can, change the browser if you want. Apart from that, in case if you want a standard solution, so I'm not confusing you, right? So how you can do that? You can go to the environments from here. You can click here. You can click on Open Terminal. And here you can type Jupyter Notebook List. So there's a command called Jupyter Notebook List. It is going to show you the running notebooks available with the Jupyter. So this is the URL with the token here. So what you can do is you can simply, copy the URL and paste it in the browser, and that's how you're going to get the Jupyter Notebook in different browsers. So this makes your life easy because some people like me are, habitual to different browsers, right? So it goes like that. I hope that is understood. And the best part is that this is recorded, so you don't need to worry about the command, right? You will get the commands. Okay, so here we start, right? So I'm going to click on new for that. Okay. I'm going to create a new directory here, folder. All participants are requested to post the questions, right? Um, I think the chat window is visible to all of you, I believe, right? And the Q&A section, that must be visible to all of you. Okay. I'm going to create a new document here. Okay, Arjun, got it. There is no limit. Okay, there's a question from Soptic. Are there any limitations in file size? As of now, no. Right, depends on the RAM availability. Okay, thank you, Reshma, for the response. I'm going to give it a name. Let's say file action in Python. So that's how it's going to work. Okay, let's learn file handling. So what I'm going to do is I'm going to simply, right here, I'm going to first of all, let's create a file, right? A blank file. So this is demo one, guys. Demo one. Sriram, I request you to download the Anaconda distribution, right? And that's how you can proceed, right? For as of now, you are requested to just observe the lecture, because it will be difficult for you to do the installation and understand things parallelly, right? So just have patience, and you can do that. Oh, Raghavendra, thank you for that. Raghavendra sent the online Jupyter URL that is also there, so you can use that directly. But unfortunately, it will be difficult for today's session. Okay, let's create a blank file, right? Okay. So I'm going to create a blank file here in my D drive. So, okay, file object equals to open d slash, sorry, ds slash. I'm going to use, let's say, okay, avengers.txt here, right? And I'm going to, okay. So guys, this is uh, how we create a blank file. So there is a function here which is open. Open is a function, right? And it accepts two arguments here. One is the path, second is the mode, right? So open is a function which is used for dealing with files, for doing actions with the files. It accepts two arguments. One is the path, which file you are willing to modify or manipulate, and the mode here, right? So the mode here I'm using is W, and I'm using E drive ds directory and avengers.txt. So here it is, right? So you can see my screen that in E drive, in another DS folder, I don't have avengers.txt. So what happens basically, it creates a file. So yeah, it creates a file. So if the file doesn't exist, right? So in the write mode, right? This is the behavior of write mode, that if the file is not existing, it's a non-existing file, it is going to create the file. And yes, in the path, you're supposed to, put this double slashes, right? So it is required. So this is going to throw error, right? So these single slashes are not allowed, because slashes are something which are meant for escape sequences. So what is a escape sequence? Generally, you must have tried slash and somewhere in your career. Slash ends for line break, and slash, R is for vertical hit or vertical enter kind of thing, right? So slash B is for some noise kind of thing, some bell kind of ring. So you're not supposed to add single slashes. Just put double slashes. Still, in case if you want single slashes to happen, for that, what you're supposed to do is a small quick tip, a tweak here, a small hack. You just simply prefix the string with uh, the character called R, right? So the character called R. So what it does, it basically allows you to accept, or allows you to type a single slashes here. So this is how it can be done. R stands for raw, 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 and it becomes like raw string, right? So it is called raw string. So it is like that. So in case Soptic, there's a question from you. He says that if there is a conflicting file name, so in that case, you're going to lose your old data, right? Okay. So what I'm going to do is I'm going to simply execute the file. No, we cannot change the slash, right? Okay. So just observe here on the right side here. Okay, 1, 2, and 3. Can you see the file? Isn't it? So you can see here the file has been created automatically, right? And the reference of this file has been given to the object called file object. This object name can be anything. I have just given a sensible name to the object name, right? So what this file object is doing, basically, it is holding the reference of physical file. So in order to manipulate this physical file, we basically catch this thing. So you can write whatever you want here, right? The variable name, the object name can be anything. So it is okay, right? It is okay, whatever name you want to give. Ashish, as per your error, you're supposed to give the mode, right? W. And Ashish, obviously, you just check whether you have E drive in your system, and in case if you have, just check whether you have DS directory in your system. If it is not there, use a custom drive or custom location. Thank you, Venkat. Thank you for big support. Right, that is really needed. Yes. So that's how we create the file, and right now I'm not doing any operation, so I'm going to simply close the file connection, right? So I'm just going to close the file connection. Just observe here, guys, right? Close the file so that other apps can use it. If it is a shared file, right? If it is a shared file. So, Mr. Fred, in case if you are working on Mac, in that case, what you can do is you can simply open the terminal and type pwd. Right? So open the terminal, and if you type pwd, that is for present working directory, you will see exactly how you go through it. Or okay, you can do one thing, right? Let's go with the simple thing. In Mac, what you can do is you can create a folder in desktop. Simply right click on the folder and go to info section, right? Right click on the folder and go to info, and in the info window, you will see the path of that directory. Just simply use that thing. Thank you, Arjun, for that. Okay, trying my best. Okay, let the world be a better place. Okay. Yeah, Reshma, sometimes Windows 10 or Windows operating system doesn't allow you to, do file operations in case if you're using C drive, let's say. So I suggest that don't use C drives, use D, E, or other drives to avoid permission issues. Keyboard shortcut for adding a cell is press the escape key first of all, Hemant, and then press B. Thank you. Escape plus B. Thank you, Hari. Himadri, you're trying to print the file object, right? Do not try to print the file object. Thank you. Thank you, Aman. That's beautiful. Okay, guys. So that's how it goes like, guys. Here we have Avengers. I'll just show you a small fun here. Let's create 5 files, right? So I'm just going to show you a small fun here. Let's see. For X in range 5, FO equals to open, e/gs/ .txt .format X, comma W, FO dot close, and let's see what it does. Right, a small fun. Check on the right side. So you can see easily I've created 5 files here with this thing, right? So I'm just giving you 30 seconds to observe the code, and I'll just answer the questions in the meantime. Vani, in case if the file is not closed, it means that it is still occupying the memory. That is absolutely true. And the worst part is that, Vani, your Jupyter stops working most of the times when you don't close the files, because you engage your kernel, you engage the Jupyter engine with that file. So you will see that many of the times you're not seeing the output, right? So you're supposed to close the file with respect, right? I hope you understand. Okay. Thank you, Sanjay. That occupies the RAM space and that also locks the file, right? So do not lock the files, just release them, right? So just do 1947. Freedom, I mean. Yes, it is going to work, Debanjan. As per your question, it is going to work. Debanjan, please share the question with attendees as well, right? So I hope, I can feel that most of the participants are doing the practicals parallelly, and you know what? That is amazing. Let's proceed further with some more demonstrations here. Okay, getting file infos, right? Okay, so here, let's see what we have in the bucket. So here, fo equals to open eds avengers.txt, and the mode is w, right? What I'm going to do, okay, print file name is, I'm going to print fo.name, and then print file status fo.close. What we have here, sorry, we don't have any kind of option to use the file, but we can use a file format. Okay. Aman, that's just okay. Aman, there is a question from you. Aman says that why do we require format in previous command? Aman, this x is the value of x is being replaced by the curly bracket here. I just wanted to, I generally I prefer the standard ways of doing the activity, right? I prefer the standard things. Otherwise, it could be like this: fo open equals to eds slash, and then it is going to be like comma x comma dot txt and then comma w. And okay, now when you do this, right, when you do this, it is not going to work. You know why? Because this comma will separate the number of arguments, right? So here this comma will not work because open is expecting two arguments and you are supplying one. You separated the comma, 2, 3, and 4. Bang, bad. It will crash. The next solution is here that you can use plus, but here plus requires string on both the sides, right? The left and right should be string. So in that case, you need to convert the integer into string like this, and that's how it works. And for me, this looks really ugly, isn't it? So I had to do a lot of operations. I needed a lot of knowledge to make things work. So I thought that format function to the rescue, right? So that's how it works like. Okay. Fine. I hope. Did you understand, Aman, what I explained? Okay. Thanks, Naveen. Yeah. Thank you for the correction. Right. Okay. No worries. Okay. So what we were doing, we were dealing with the file operation, file mode, and what we're going to do is fo.mode here, and finally fo.close, right? Oops. And I'm going to print the status once again. Guys, observe the output and the code, right? Observe the output and the code. In the meantime, I'm going to answer the questions here. Write mode is creating the file here. How do we delete and overwrite the file? What are the modes? Roshan, for deleting a file, we don't have mode for that. For that, we have a module called OS, right? OS.remove. It's like that. Import os.remove. Okay. Lenovo, as per your point, right? Lenovo, can you post the same question in the attendees with attendees so that attendees can also see the code, right? Okay, everybody, right? I think it's easy to understand what is happening here in this section. So here we have fo.name. This is a property, right? Okay. Okay, fo.name, this is a property which returns you the file name, this one. fo.close returns true and false, which tells you whether the file is open or closed. So whether it's false means it is open. Fo.mode basically tells you the file mode, which is W, and fo.closed once again tells you whether the file is closed or open. So if it's true, that means it is closed because I've closed the file here. Okay, Naveen, thank you. You said it right. The participant is missing the double quotes in his path, right? Okay. Anthony, he says that why we need to create file like this when we can create directly from the web page from Anaconda. Okay, so here is the answer to this question. I'll repeat it once again. He says that why we need to create files like this when we can create the files from Anaconda. Okay, so the answer is like Anthony. Imagine you are developing a product from for a client. Let's say this is your product, right? So if the user selects save menu from here, how you are going to save the content, right? Please save this content. So when think as per the client point of view, right? So you're giving a software to a client, and he's trying to save the content. So when he clicks a button, he wants that this content should be saved in a file. So in that case, you're going to do this kind of programming, right? This kind of programming or this kind of programming to save the content in the file. So that in that case, right? So do not think yourself as a user, right? The perception is different. So think yourself as a developer, and you're going to give product which can save the data to one of your clients, right? Thank you, Anthony. There are a lot of questions which are being asked here, right? I'll just try my best to do them. Vani, as per your question, these are the properties are object of the file classes, right? So file from file, these properties are coming. Bharati, yeah, as per your question, you are going to require additional modules, right? There is no standard module available in the Python for reading different file formats. Yes, Ravi, you're going to face the error. Don't worry. Okay, guys. Now I will proceed. Right, I'm going to take the questions after at least 5 or 7 minutes, so that I can complete the content as well. Now here in this demonstration, I'm going to tell you how you can pull the data from file, right? So okay, how you can pull the data from file. So this is what we are going to do right now, and I'm going to write some data in the file. So let's say I've opened the Avengers file, and I'm just going to write some content here. Okay, just observe this carefully, right? Okay, Avengers is a movie, and this is a nice movie. Okay, I'm bad at writing. I'm bad at storytelling. Please excuse me for that. Okay, and this nice movie, and the characters are awesome. Okay, so here we have 3 lines in the file. I just save the file. Okay. Okay. So here, how you can pull the data from file? That means reading file. Okay. So what I'm going to do here is I'm going to create the file object. So this is FO. FO is file object, right? It can be anything. I'm going to call the open function here, eds avengers.txt, and I'm going to put R mode here, right? Remember, R is for read. Okay. Okay. Now I've executed the cell. Now I'm going to call fo.read, right? Read function to the rescue. Okay, fine. So observe what read function does. It basically returns all the content of the file. Returns all the content of file. Yes, Jasurya, if we close the file, reference of the object get erased. That's true. And f4 dot. Okay, I'm not going to close. Okay, I'm just going to close the file now. Fine. Okay, so here what we did is we did the read function here, right? And read is for simply retrieving all the contents of the file. Now I'm just going to show you another version of read, right? Okay, not messing around. I'm going to simply call f4 dot read line returns the first line of the file. So here you can see, right? Here you can see that I'm using one more function called readLine, which is for returning a single line from the file. Okay, this is how it works. Okay, guys, everyone, I'm just giving you some vocabulary, some power functions. You need to understand the behavior, right? Just understand the behavior. Read function returns all the content. ReadLine returns a single line. Now here we have one more function, f4 dot read lines. Okay, what it does, returns the lines in list format. Upgrad, it will not work in case if it is W mode, right? Okay, so observe the content here, everyone. So when I'm calling read lines, it returns all the content of the file where the lines are kept as an item of a list, right? Can you see that? The lines are kept as an item of the list. Okay. Yeah, I'm going to come, right? So Ram, I'm going to come to this point. Fine. So we have covered three functions here. One is read, one is read line, and one is read lines, right? Like that. Now, what you can do is, okay, guys, while I'm executing this code, I'm making sure that I'm closing and opening the file carefully, right? You may not be noticing me, but every time I'm calling a different function, right? I'm opening the file once again and I'm closing the file after explanation of each and every function. So just to avoid the errors here, right? So just make sure that you follow this sequence. Otherwise, you're going to get stuck in the middle. And there are a lot of reasons due to which things don't work. I just want to spend some time in troubleshooting, just keeping you on the safer side for the smooth running of the program. I'm going to come, Sheila, for your question as well, right? Just allow me some more time. Now, okay. What I'm going to do is lines equals to f dot read lines for line in lines print line. Isn't it, guys? This makes sense, guys, isn't it? Just observe, this makes sense. I'm calling read lines. So read line is going to return me a list where every item is a line from the file, and all the this whole list is going to be stored inside this lines variable. It's a list. Now I told you that you can iterate through the list, isn't it? You can iterate through the list. So this is how it looks like. Okay. So what I'm talking about here is how to get all the data or how to traverse through file content. Okay, guys. So in this section, I'm focusing on how to traverse through file content. So this is the solution for traversing through file content. Now observe. Suppose if I give you a task to analyze a data from a file. So if you are given a task of analyzing data from a file, you are supposed to read the whole file all at once, and you're going to analyze each and every line, or maybe each and every word, or maybe each and every character. For that, you need to learn a mechanism through which you can get all the contents, right, in a sequence. So this is how it is done, right? Okay, just giving you the chance to ask me questions in case if anything is not understood, how I was able to retrieve all the lines from a file, and I was able to point out each and every line one by one. You can ask me anything if you want out of this, because things are more complicated further. Okay, Bharti, for that, Bharti has a good question. Bharti, please post the question with attendees also. So Bharti says that, is there a method to know how many lines are there in a file? So what I'm going to do is, I'm going to simply, do the len on lines. So does this make sense? Isn't it? Thank you, Asim. Thank you very much. That's good. So this is going, okay, this is going to return me the length of the array, isn't it? So this is equivalent to the number of lines. Now, finally, I'm going to show you the last way, right? The last procedure to, read all the files, right? Okay. So it's like the super easy way to get all the lines from the file, or the content from the file, right? Okay, so here it goes like, guys, make sure you remember each and everything, right? It is super difficult, for the participants to remember, but I'm going to need all the content, all the knowledge in the last half an hour. Super easy. Okay, let's get started. Let's proceed further. So here, once again, file object equals to open, right? eds avengers.txt, and I'm going to use the read mode here. Okay, and now, oopsie, what happened? Avengers. Okay, got it. My mistake. For line in F4, right? Print line. If you iterate through file object, it returns the line by default. Learn my nature, says FO. Okay, so here it goes like, Amit Gupta, we do have get CWD here in Python. That is for get current working directory, right? So it's like get CWD, like using the OS module of the Python, import os.get CWD. Fine. Okay, I just confused my participants. Okay, guys, if you iterate through the file object, right? I'm iterating through the file object here. You can see here, it returns the line by default. So just FO is requesting you to simply check out the behavior, right? So guys, can you see the behavior, right? How it is done? It is internal. It is automatic. I just learned how FO behaves and I just use it, right? Just learn the behavior, use it. So guys, this is the simplest way of getting the content of the file, right? So that's super easy. So guys, can I ask you, right? So did you understand what is happening here? Okay. Okay, that's great. Can we extract words specifically? That's true, Soptik. I'm going to tell you that. So in case if there is like, okay, if there is a line, if there is a word is available. Okay, let's do some action, right? Let's do some action. If line contains is, print it. Otherwise, no. Fine. So this is something that I'm going to do, right? If line contains is, then print it. Otherwise, no, you don't print it. Right? Okay. So how I'm going to do it, right? So if is in line, print line. Look at the beauty of Python, guys, right? Look at the beauty of Python. So there's an operator keyword called in, which checks the existence of given input in the given argument. So if it is there, it is going to print the line. Hey, beauty, what happened to you? I just forgot to close the object. Bad thing. Okay. Okay, so you can see the beauty of Python, right? So this is the reason why I love Python. It's super cool. It's readable, right? That's how we call it readable, right? Okay, so if is in line, so it prints the line like that. Now, in the next step, right? In the next step, what I'm going to do is replace all the replace. Okay, what was the okay? All the vowels into at the rate, all the a into at the rate. Okay, I'll just keep it simple. Yeah, it's sensitive, right? We do have solutions for that. I'm just keeping it simple. So I'm just going to do some changes here. So in the output, I'm going to replace all the a's into the at the rate and the lower as well. Okay, dot upper. In case, right, just one of the participants asked me to do this. Right. You can see that we have upper here, right? Okay, that's great. Now, in the next step, I'm going to replace all the a's with the at the rate. You can simply have a look here. Okay, come on, where are you? For line in FO, see, I'm iterating through all the lines, and what I'm going to do is line equals line dot replace a with at the rate, going into string manipulation, print line. All right. See, you can see some things there, right? Can you see? Yes, Sanjay, we're going to do that, right? I'm going to show you uh, in the write operation. That is my next demo, right? Yeah, it is case sensitive. In that case, what I can do is I can simply, convert the whole line into lower, and then I can simply uh, do it. F4.close. I'll just show you in the demonstration here, right? Let me try if this works. Line dot, I'll just call lower and then replace. Let's see. Guys, just check. This is called function chaining, right? This is called function chaining. You can do this in Python, right? So I can call a function from a function. So what I did is I just converted the line into lowercase and then I replaced all the small a's into at the rate, isn't it? So once again, the beauty of Python, right? So that's why we love it. It's super cool. It's simple, elegant, and it makes life easy and gives you more time to live. Right? Can I extract a specific line? Right? Okay. So if you want to extract a specific line, for that, I'll just tweak the code. If line dot starts with, I hope, print line. Okay, print line. Okay. Oops. I forgot to close the connection, I believe. Okay, just checking out what error we have here. If line dot starts with this, I think that is a capital D, I believe. Okay, got it. So you can see here, guys, I got the line right. This is nice. Let's get started writing the content in the file, right? So writing data. So I'm going to do this. So just be with me, guys, right? Let's get started. Okay, now this time we're going to write the data, and I'm gonna need a beautiful example for this. Let's build something. FO equals to, okay. Okay, for that I'm going to use open lang ds.txt. I'm going to use the write mode here, right? Okay. And what I'm going to do is fo.write, English is for America, right? fo.write, and let's say Chinese is for China. Slash n f dot write. Okay, I'll just keep it simple, and f dot close, right? So just be sincere while closing. So where do we have our folder, right? Here we have. Okay, guys, executing the demonstration, right? Keeping things parallel. Okay, so here it is. I created. Did I execute? Okay, no. Acha, acha, got it. Got it. So let's check the file, right? Let's check the file. You can see here, guys, English is for America and Chinese for China, right? So this is beautiful. So we have successfully transferred the data, or we have successfully written a file. So for that, I'm using a function called write, and write is for writing the data into the file. And I think this is really pretty easy to understand exactly how it is working, right? Now, what I'm going to do is I'm going to do a testing here, and this time I'm going to number of characters, right? Kritika, the 22 is number of characters, how many characters have been written in the file. Okay, it's like that. So I'm going to write some more content here. This time we are going to do the execution too, right? Bhakti, you say that why f.close is always in a separate cell. The reason, because I like to I like my things. I like things to keep clean. I like things to be distributed so that participants don't have problem misunderstanding. I don't want to show you the messy code, right? I just want to keep the code clean. That's how things go with me. A personal problem with me, right? Just bear with that. Soptic, no, we cannot set the font size. No, we cannot, right? We're not working on Notepad. It's just text data. Yes, Bojraj, we can format the data while writing. That's true. Thank you, Naveen. Okay. Now, so we had American, we have Chinese, and this time we are going to take, okay. Okay, so Telugu is a language from Andhra, right? So I hope I'm right. Okay, so now this time I'm going to write this data, and let's see if it what it does with the old data. Yeah, we can do that, Kritika. Oops, it's a close file. Okay. First of all, I recreated the file. Let's check. Oops. See what I've done. I have overwritten the file, right? Right. Okay. I've overwritten the file. I'm going to write the data, and now let's check. Okay, the data has not been written. What I'm going to do is I'm going to close the file, and when I close the file, the data gets written. It's here. But every time if I'm opening the file, right, this line overwrites the old file every time, right? So every time, when I'm trying to write a new data, right, uh, it is basically, it is, overwriting the old data, old file, right? So what does that mean? That means basically that, you cannot maintain the previous data. So how you gonna, deal with this situation? Right, Anthony, that's the number of characters that I'm writing, right? 28. So how you gonna deal with this information, this stage? So guys, can I ask, right, how you can maintain the old data, right? If you remember my initial explanation. All right, so yeah, so that's good. Yeah, using append, that's true. So I'm just going to show you a demonstration on append, right? So let's see how append works. Right. Okay, that's great. Yeah, I'm really glad that the participants are having excellent memory, and I'm very much sure that I'm going to get uh, anaconda response. Right. Okay. Thank you, Naveen. Thank you. Roshan, I'll come to that overwriting part. The problem is that, Roshan, I'll tell you, right? Until and unless you close the file, the write function doesn't write the data in the file. That is the problem, right? You need to close the file for getting your data written in the file. And if you want to write it once again, you're going to open the file, right? So that's how it overwrites. Append mode, blessing from Python. Okay, so here I'm going to create once again ds avengers.txt, and this time this is append mode. And first of all, you need to observe the existing data. Observe the existing data. Telugu is a lang from Andhra, right? I'm going to I've executed the file object, and I'm going to write something here, right? Hey, this is append mode. Did you see old data retained? If right, if yes, append. Tutorial append is on. F4 dot close, and here it goes, right? So Ravi, I'll ask my team to send you the session. So I've executed the write here, right? So it is done. And now I'm going to check the lang here, right? Okay, lang, let's see, 1, 2, 3, finger crossed. Oops. What happened? What just happened? Okay. Yeah, true. You know, just got messed up with the questions, right? Fine. Okay. So I just used Avengers file instead of lang, right? So what I'm supposed to do here is I need to check the Avengers here in that case. Append mode, right? It's appending from here, right? Hey, this is append mode. Did you see old data retained? If yes, append is on, right? So even this works, right? This works also. So no matter which file we are working on, if we can see the old data, that means the append is working. So Bochraj, the file names are not case sensitive in Windows, but they're sensitive in Linux, right? That depends on which OS you're working on. Okay. So this was a beautiful demonstration on the file part, right? Okay. Now just bear with me, guys, right? I'm going to show you a really huge demonstration on how we're going to do this thing using OOP, right? Naveen, we can't do that, right? With the default append, we can do that with the seek function. It's really handy. So guys, as I told you in the beginning that I'm going to involve OOP also. So I'm just going to write a program here, right? Just have things here, right? Just see the things here, right? It's going to be messy, right? It's going to be messy. Just be prepared. Class file handler def write data self comma content print URN write data and then content def wait data self path print URN wait data and path. Hey guys, Bojraj, I'll definitely, like, if you want to format, you can do like this, right? Bojraj, you have been asking me all the time. So I think this should make sense, right? So while writing the data, if you want to format the string, you can do it like this, right? So that's how it's going to be done, right? Bojraj, is this okay? Okay, thank you, Bojraj. Thank you. Okay. Guys, observe the code, right? This is a challenge for all of you, right? I hope that the participants remember the last session, right? This is just a dependency here. There is a class called file handler. This is for writing the data, and this is for reading the data, right? I'm not completing the code. I'm just creating the prototype. This is a prototype. I'm going to add inject code here, right? Just observe. Okay. Then we have something called class program, and this is how we do the inheritance, right? Hey guys, observe the inheritance. Observe. Sweet. The inheritance syntax, right? I'm assuming that most of you are familiar with the inheritance concept. As I see the responses, many people are already familiar with the languages. So this should work here, right? Just observe the syntax of inheritance. Thank you, Shagun, A1. Okay. Now what I'm going to do is I'm going to def accept input self. Okay. Okay. Data equals to now this time. Okay. Input, enter whatever you want to be saved. Self dot write data. Observe calling function of base class. Yeah, Vani, it's a little complicated, but believe me, it is easy also, right? I'll just show you exactly how it is working. Hey guys, observe this. First of all, I've created an object of a program class, and the object name is P. I'm calling the function called p.acceptInput. So here it is calling the accept input. As per this function, it is going to ask the user for typing something. Whatever the user is going to type is going to store inside data. Here, I'm calling a function called write data. But the twist is that this write data doesn't belong to a program because it is nowhere declared in the same class. This write data function belongs to the file handler class, which is here. And why I'm able to access the function? Because I've done something called inheritance here. If I remove this line, or if I remove the inheritance, I will not be able to call the function from the base class. Right? So it's like this. Now, if I execute this, you can see that it has called accept input, and because of input function, it is asking me for the input. Blah, blah, nice, blah, and blah. So whatever I have entered is going to be stored inside data. I've called the write data function. Here is write data. And this data is going to pass inside content. So it will be having blah, blah, and then nice blah, blah. And then it is going to print you are in write data and then the blah, blah story. Let's check it out. Observe. Observe the sequence here. Okay, I'm just going to keep it simple in that case, right? Let's keep it simple. Now, as you observe that this is the content that I need to store in the file. So what I'm going to do is I'm going to, FO equals to ds slash db.txt, comma w, right, and fo dot write content, fo dot close. Hooray! Data saved. Right, I am able to save the data. So this is how it is going to work. I actually plan for a read also, but keeping things simple here. So in the same way, you can code a read function, right? So if I give any path as input of the file, you can simply display the file content like that. Okay. So okay, so this is something that I want to write. Self is a keyword, once again, equivalent of this. Okay. Okay. Okay, so I remember the beautiful song from the TV show Big Bang Theory, and in that show, there was a time when Penny used to tell a bedtime song to the children. So does anyone remembers that song? Yeah, thank you, thank you, Vishal Kumar. That's a soft kitty and like that, right? Okay, fine. Okay, that's great, yeah. Soft kitty and shiny kitty. I don't remember big ball. Okay, fine. So let's hit enter, right? Hooray, data saved, right? So I'm just going to check this db.txt whether my data is there or not. So here we have db, and here is the output, right? Soft kitty is shiny kitty and big ball. Okay. So thank you, Raghavendra. Thank you. So this is how things work, right? So this was how it was planned. So just added some OOP stuff, just added some inheritance thing, okay, and then with the objects I'm able to call the functions, and I'm able to save the data, right? And this is a command line interface, and that's how the GUI also works. So Bharti, if we go through the OOP part, actually you are bound to go through OOP part. You cannot write codes without OOP, right? Unless until it is a script. If you are developing a product, let's say for a client or for a company, you are supposed to go with the OOP part. Vishnu, he says that what is the inheritance concept? So here's the answer. Inheritance is basically acquiring the property of a given class. So this function is a property of file handler, and the program wants to acquire this property, this function. So if a class is looking or wanting to acquire the members, the functions, or the assets of any other classes, so they just follow this syntax, right? So what the syntax means? This syntax basically means that program wants to acquire the properties of file handler, and what we're acquiring, write data, it is here, and you can see that after acquiring we are using it here, right? So how this acquisition helps, because you can use it in machine learning space. OOP is also required. Mostly no, because in machine learning generally we write scripts, right? So we write scripts for for solving the task. But there is an example of Rosetta. Rosetta is one of the tool developed for machine learning. So Rosetta is a product, right? So our product is developed using OOP. But if you're solving a specific small number of objectives, so that doesn't require OOP in that case. So, guys, I'm just proceeding to my last final demonstration of today's session, and then believe me, I'm going to release you. Then you can have a long breath of relaxation. Okay, let's complete the final demonstration, and then we all are going to win this thing, right? So let's get started. Okay, data analysis kind of thing, right? Or I'll call it kind of thing. Yes, Uptek, it is important. Guys, I have a file with me, right? And this is employees.csv. I just want you to check this out, right? What are the details in this file, right? Just giving you time of, let's say, a max of 1 minute. Thank you, Barsana. Yeah. Thank you very much. Okay. So, team, right? Team, did you study the data, right? Just study the column structure here. Did you study the data? Is it okay with all of you? We have first name, we have gender of employees, we have start date, last login time, we have salary of employees, we have bonus percentage, we have senior management, and we have team here. And I'm going to tell you that you're going to learn something new here, right? Just be with me. Just be with me, guys. Okay? Okay. Fine. Yeah, Bhojra, that's also there. What I'm going to do is I'm going to, read that file, right? emp equals to open e/ds/employees.csv, comma R. Hey guys, CSV stands for comma separated values. It's just a plain text notepad file, nothing else. Sure, Himadri, I'll do that. For line in EMP, print line. I think this should make sense. What do you say, guys? Avinash, sure. So this makes sense, right? So the expected thing, oops, I forgot to execute. Should be like this. So does this output make sense, guys? Do you see the same data here? Just look at the beauty of Python, guys. You just learn reading the file and how handy it can be in the real time, in the production time, right? So now when you're working with something which is relevant to the companies, it really makes sense, and it really things are on the right track. I mean, yeah, we can add the R Pavitra before that, and I can simply remove this. Okay, emp dot close. So we cannot do that, right? Because for that we need a library. Guys, is everything okay till here, guys? Is everything okay? Okay, thank you. Now what I'm going to do is, okay, everybody can print the whole line. Can you print the first name only? Do you dare? Okay. So here's the challenge, guys. Somebody came, hacked my system, and just asked me to do something. Okay. So we have got the whole data, right? And we need to print the first name column only out of that. So how are you going to do that? So in this demonstration, what I'm going to do is I'm going to show you how you can do it. So what I'm going to do is just assume that this is the value of first. This is the first thing you are getting, right? I'm going to call the function called split. Split is a function which used to slice the data, right? Split is a function used to slice the data. Just keep this thing in mind, or any line. Just pick any line, and I'm slicing the data based on comma here, just getting things simpler. And I've got chunks here. So this is an array, right? Like it's a list, right? It's a list. So what I've done, I've splitted the line based on comma here, and I've got the line in the form of array in chunks, and it is going to be index based list. So in the zero index, what can you tell me, like in the zero index of chunk, what I will be getting? Yeah, so I slice the whole line based on the comma delimiter, and that's how I can get the first name, Douglas, Thomas, and Maria. So I'll just do the action here, and you can see that. We do have standard libraries for doing all this stuff that actually you'll be learning with me, all this stuff, but just giving you the concrete and core things to have things in you, right? So it's like that. So first thing. Okay, so this is beautiful, right? This is beautiful. No, Pavitra, I don't think so. We can do that. Saurabh, basically, if you observe the data, every data is separated by comma. Every line, every word is separated by comma, right? So I'm going to show you once again. Print line. So if you observe here, Saurabh, the values are separated by comma here, right? Comma. So what split does, basically, it slices the values wherever it finds the comma, and it becomes an array, right? Okay. Now, what if I want to, guys, my question to you, all of you, what if I want to retrieve the team? So can you answer me? What if I want to retrieve the team? Excellent, excellent, excellent. Excellent. Great, yeah. I'm really surprised that the participants are really active, because what they told me is something that is only possible when you learn Python properly. Right? So print chunks -1. Oopsie. So we have got the team here. So in today's session, I'm just discussing the agenda here, guys. So I'm going to give you the overview of NumPy. I'm going to discuss something called arrays. Arrays are the backbone of NumPy, right? So in this today's session, we're going to play with arrays, right? So there's nothing which is conceptual, or there's no concept kind of thing here. So it's all about arrays here, right? So array, what is array and how we're going to use it? So you're going to see it in my coming demonstrations. Then we are going to work on array manipulations, and then some advanced array manipulations, and a lot of exercises that we are going to do today, right? So this is something which is planned for today's session. Now, everyone, right? So today we are going to start with NumPy, right? So first of all, we are talking about the NumPy here, right? So I'm just going to tell you exactly about the NumPy part first of all, and then we are having lots of demonstrations today, lots of demonstrations today, right? And there's going to be many inputs and outputs in today's programming. Now, uh, can I ask my participants how many of you are doing the practicals parallelly, so that I can just make the speed with you, right? Or you can make the speed with me. So I'll just uh, so here we're talking about NumPy, right? So basically, first of all, what is NumPy basically, right? So NumPy is the most basic and powerful module of Python, which basically allows you to work with data. Now, first of all, you need to establish some connection with data in NumPy, right? So if you're starting with the NumPy for the first time, you need to have data in your mind, right? So basically, I'll give an example, right? NumPy is not used in basic programming, right? Just understand this thing. We don't use NumPy in basic programming. So here we're talking about something which is your future. So let's take an example. Let's say we have a data, right? So let's say if we have a shopping data, or if we have a tabular data, if we have some records, rows and columns, right? So how are you going to represent those millions of rows and columns in programming sense? So for that, you need something called a multi-dimensional array, or a 2D array, right? So that array kind of concept is the backbone or the key of NumPy. So here I'm going to say three words here: NumPy, array, and data. So what is the connection between these three words: NumPy, array, and data? So NumPy provides you array that can store data. So, and that array is basically special because NumPy provides you hundreds of built-in functions, hundreds of built-in properties that can easily manipulate that data according to your requirement. So in today's session, in today's session, you're going to see that how we create arrays with NumPy, and how we can manipulate that array in various senses, right? In various ways. So that's how it is going to work. Now, okay, fine. One more note to all of you. NumPy is not going to make sense in today's session much. You know why? Because NumPy makes sense when the library or the array of NumPy is used in the data analytics further, and used in the machine learning further. So NumPy makes sense mostly when we have data, when we have data analytics, when we have NumPy all together. In that case, NumPy makes more sense to us, right? So in today's session, it is a array play, I'll say like that. It is an array play. So you're going to learn how to play with array, and how you can simply juggle around this array kind of concept. So once again, I would like to give you a simple conclusion here. There are three things that you need to take care of. One is NumPy, array, data. The data is stored and represented in the form of array, and this array is provided by NumPy. Now, here is a question. We can represent the data in the form of Python list as well, in the form of Python dictionaries as well, in the form of Python tuples as well, right? So why we are talking about NumPy arrays? That is the question here, right? Okay, now listen to me carefully. Now, first of all, the traditional data structures that we are talking about from the Python part is the tuples. We have lists, we have sets, we have dictionaries, but these data types, these data structures from Python have a bad side of them, right? Yeah, have a bad side to them, have a have a curse associated with them. And I'm going to tell you exactly what curse is there which is associated with the Python data structures, with the standard Python data structures that we are talking about here. And that curse is the hunger of eating the memory. There are two curses I'm talking about here. The first curse that is associated with the basic Python data structures is the hunger to eat memory. So when you're using list, when you're using tuples, dictionaries, or sets, even the normal integers, they eat memory. They take a huge chunk of memory for the small data or for the smallest block of data. They eat more than that. That is the first thing. So the first point is they are hungry about memory, right? The RAM part. Now, the second part is the performance. They are very slow, right? So I'm going to show you a demonstration for this. So the standard Python data types are slow. They perform very slow when you're doing large computations. Yeah. So when you're doing computation on matrices, right? So when you are multiplying matrices, when you are, iterating through matrices, when you're doing traverse lower matrices kind of thing. So, they are comparatively slow. So all these curses of basic Python data structures are actually reversed in positive way. So when we talk about the array which is provided under the NumPy tree, so this array has got everything which is not there in Python data structures, and I'll say only two words here. One, memory efficiency. One, memory efficiency, right? NumPy, the arrays under the NumPy tree eat a lot less memory compared to what a list or a tuple requires in their cases. So the very first thing is that NumPy arrays eat a very less memory, right? Now the second point is that NumPy arrays are super fast. They perform excellent, right? They perform excellent in terms of performance, right? So if you're talking about the latency part here, it has got a very high latency. Means it's super performing, right? You simply get the response in milliseconds, right? So whereas the same computation, the same programming takes seconds or even more than that in Python data structures. Okay. Now the question is that now the question once again, right? Once again, I asked, when I was learning NumPy years back, so I asked my trainer that why so NumPy is faster compared to basic Python. So the answer is that the faculty, the trainer told me that, at that time, that the NumPy is built on top of C, right? So NumPy is written in C programming language along with some basic Python as well. So most part of NumPy is written in C, and that's why NumPy performs faster than Python. So this is the reason why NumPy data structure. So the only thing that we're going to pull from NumPy is that we're going to pull the data structure only. We're going to pull the arrays only, right? So from NumPy, we're not going to pull the OOP concepts. From NumPy, we're not going to pull the file handling concepts. From NumPy, we're not going to pull, the exception handling concepts. No, we are going to pull the data structure only. And once again, I would like to give you the conclusion here. Why we are pulling the data structure, the array part from NumPy? Because of only two things. And the first thing is, once again, the memory efficiency. And the second is that the performance, right? Memory efficiency and performance. Only these are the two reasons why we use the data structure, the array part from NumPy. Okay. So guys, I would like to ask you, right? Is the fundamental of NumPy is clear to you, right? Did I make you clear exactly what we are talking about here, NumPy? The point is that you need to understand why we need to use NumPy, right? And things like that. Yes, Optic, it provides a ND array, right? So n-dimensional array. Thank you, Bindi, Santa. Thank you, Bhavya. Thank you, Pavitra. It's a library, Ashutosh. It's a library. It's a library. Okay, fine. Thank you. Okay. Eligeni, why it is fast, it's not clear. So he says. So basically, thank you, Divanjan. It is fast because it is written in C, right? So C is generally faster by its nature. So that's why it is fast. Once again, Jeffrey, it uses stack, right? Okay. So the NumPy key, right? The last line here is that what is the key to NumPy requirement or NumPy performance or memory efficiency? And the answer is n-dimensional arrays, right? Okay. So this is just this is just a summary of exactly what I've discussed here with some extended information here. So it says like NumPy is an open source library available in Python that aids in mathematical computation, whether you are doing scientific computation, whether you're doing engineering calculations, or you're doing data science programming. So as I told you in the beginning, right? When you're doing core NumPy, it doesn't make much sense, right? So when you're doing the fundamentals of NumPy, but when you're doing the computations at a higher level with bigger challenges, and in those cases, when you see the memory efficiency, when you see the performance efficiency, in those sections, you find the sense to NumPy, right? So in today's session, I'm going to tell you what arrays are and how you can play with the arrays. And further, in my next session, I'm going to show you exactly how NumPy arrays are used, right? Okay. So NumPy is basically an incredible library to perform mathematical and statistical operations. As I told you earlier, it works perfectly well for multidimensional arrays and matrices multiplication. So it is like it's a lot of mathematics involved here. So in today's session also, we're going to discuss some of the mathematics here. So let's get started. This is the last slide, right? So as I do in most of my sessions, that I keep the content on the lower side. So this is something that I want to tell you: n-dimensional array or ND array, right? So when we're talking about performance, when we're talking about memory efficiency, who is the hero here? Who is the who is the reason here? Who is the strong part here for bringing all these features through NumPy? And that is called ND array, right? It's all the n-dimensional array. So we're going to work on this ND array, right? And it is a powerful n-dimensional array object, and it has advanced array slicing methods. So I hope you remember the slicing Walla part, right? I think we did it in strings, right? We did it in list as well. In list, I told you to repeat actually. Okay, fine. Thank you, Vani. Thank you, Saignish. And I'm going to tell you something about reshaping, exactly what exactly reshaping is, right? So there is a lot of things that I'm going to cover today, and just be with me, right? And the most important part before starting the practical, right? The most important part before starting the practical is that you need to think in the same way as I am thinking. You need to grab the question first of all. You need to grab the question, and then you need to understand the logic, and you need to see the output and compare the logic with the output. So it's going to be a 2-3 stage process that we're going to work with, because in today's session we're going to play with a lot of numbers, right? So a lot of numbers we're going to play with. So you need to be careful, right? What we are talking about here. Don't lose the connection. Don't lose the connection, right? Don't lose the connection first. That's a note. Okay. So I'm going to launch the Jupyter part here. And now I'm going to click on Python 3. Here's the beautiful Jupyter. NumPy in action. So here we have a NumPy, and So Rajesh, according to your question, the remaining 4 sessions you can see probably in your upGrad portal in case if the videos are not available there. So I request you to drop a mail to the upGrad care team, and they're good at replying and resolving their issues. I'm very much sure. All right, thank you, Rajesh. Fine. So here we're starting with the NumPy in action. And first of all, what we're going to do in order to use the NumPy library, basically, we need to import the module, right? Import NumPy. So this import is a keyword in Python, which is to include a library, and the library that I'm including here is import NumPy. The best part is that we are using Anaconda distribution, and in Anaconda distribution, basically you get the popular libraries are already installed, and this is how we include the module, right? And further, I'm going to call some good functions, right, for doing the computations. So repeating, so this will be the syntax for calling the functions, right? So I'm going to call some functions from this library, and for every function calling, I need to use the reference of the module, so and that is NumPy. But what I'm going to do is I'm going to create an alias here as NP. So basically, this alias helps me in reducing the typing, right, the keystrokes. So further, when I'm going to use the function from the NumPy library, instead of writing the whole NumPy, I can simply write NP here. So I think this alias makes sense now, right? So I hope everybody is clear with the alias part. Okay, thank you, Reshma. Okay, that's great. That's great. So that's how we start, guys. Import NumPy as NP. NP is an alias for NumPy. And here, what I'm going to do is I'm going to create a an array here, right? An array, right? So what I'm going to do is my Python list equals to 1, 2, 3, and 4. So here, what I've done, I've created a list, and you can easily see that this list belongs to Python. And for easy understanding of exactly what we are doing, I've just named the variable according to the context here, right? So that is my Python list. And what I'm going to do is I'm going to let's convert list, my Python list into NumPy array, right? So I'm going to convert that list into NumPy array for getting the maximum performance out of it. So Saurabh, okay, just a second, guys. Saurabh, you got an import error, right? Saurabh, can I ask you, like, are you using Anaconda or the plain standard Python? Anaconda. You must not get import. In case if you're using Anaconda, okay, Sai Ganesh, for you, go to the kernel menu and click on restart. That is your thing. Saurabh, NumPy in action import. Saurabh, this should not be there. I think every Anaconda has this NumPy. Yeah, Salai. That's not required, Salai, as of now, but NumPy should be there. Roshan, you're getting NumPy error? Okay. So can we do one thing, right? Let's go to environments, and I'll simply, click here, open terminal, conda install NumPy. Let's see if this works, right? Okay, fine. I'm happy to see that for you it is working. But Saurabh, I'm really unsure about why you're getting that error. So I think you can follow the same command here as I'm doing for for installing the pandas. Thank you. I'll just move back, right? So here, what I'm going to do is I'm going to convert that list, my Python list, and I'm going to store in this variable NumPy array. Print NumPy underscore array. Okay. Print type NumPy underscore array. So here, guys, this is how it works, right? So it's just a basic start that I'm giving to all of you. Make sure that you're not slow and lazy right now, because it is going to be a very tricky programming further. So Shruti says, Shruti, please post the question to attendees as well, right? So Shruti has a question. What she says that what is the use of converting list to array? So the use of converting a list to the array is that now when you convert a list into array, the very first thing is that it is going to occupy less memory. Second, whatever further computations you're going to perform on array will be faster compared to the Python list. Thank you, Sarah. Okay, thank you, Shruti. Fine. So once again, you need to remember two things in the background: memory efficiency. I'm going to show you the proof for this, right? I'm going to show you the proof for this. Don't worry. And performance, right? Yes, Shagun, that's true. Because Shagun, the reason to your question is because it is an object. That's why, not a kind of structure. Okay, so here you can see that I told you that the key or the backbone of NumPy arrays is the ND array. You can see the ND array here, right? So this is what I was talking about. Now we will not call it as array. It is a ND array, right? So it goes like that. Now I'm going to show you some more demonstration. So the next 10 minutes are going to be easy, right? And further, it is going to be tricky. So just make sure you go with that. Okay. I'm going to show you some more basic demonstrations on NumPy. So here we have arrays, various data types. Thank you, Roshan, for that. Thank you very much for informing. That really helps. So arrays of various data types that I'm going to talk about here. So here x equals to np dot array, and here I'm going to take 1, 2, 3, 4. And if I print x here, so it prints 1, 2, 3, 4. And if I print the data type, right? So if I print the data type of that array, it is int 32, right? So data type is a property here which is used to print print the data type of that particular array, and that's how we go it like that. Okay, fine. So further moving to the other thing, other demo, x or y equals to np dot array, and here we have 1.0 comma 2.0 comma 3.0, and if I print y, we'll see the output of that y, and here I'm going to print the data type of y. So I'm doing some simple things here, just making you comfortable in the first 3 or 4 or 5 minutes, and then further we're going to jump on some bigger things, right? So just getting you familiar, right? Spending some goody times with these arrays. Okay. Surin, you can have different data types as well, right? So that's not an issue. Okay. X, Y, Z equals to np dot array, and this time I'm going to mention 1, 2, t type equals to np dot int 64. Okay. Print z dot t type. Okay. So d type is a property, guys, we used to know the data type of the given array. So here you can see that in the first example, we saw that it is int 32. And then in the second example, we have float 64. And in the next demonstration, we have a medium, a mechanism to specify what data type we want, right? So this is how we do that. So this is how it is going to be done, right? So just giving some time, just giving us a pause of 15 to 30 seconds so that I can help Saurav Kamal. Saurav, you said that updation was done. I close the command prompt. Saurav, you do one thing. You simply Google online compiler for Python and just start programming on that thing, right? So that will be helpful in today's session. Okay. So here in this Z wala part, right? So in this section, basically, I just explain you exactly in case if you want to specify data type, right? It's supposed to be in 32 first of all, right? But let's say for some reason you want the data type of this array to be in 64. So instead of in 32, so that's why you can that's how you can specify the data type. It's like that. No, Reshma, dtype is not for listing of properties and methods. Dtype is for data type, right? It's for knowing the data type or for specifying the data type. So you can use in both the ways. Okay, fine. So I hope everybody is getting along with NumPy, right? Once again, I would like to tell you that once again, I would like to tell you that the main reason why we are using the arrays from NumPy is for performances, and there are three reasons I will say, right? I will say three reasons. One, memory efficiency. Two, performance, and three, huge sets of functions for array manipulation. So I'm going to discuss this thing also. No, Shivani, data cannot be used with the normal Python programs. Yeah, Jeffrey, it can have. Okay. Asim, when you have less than U11 something data type, and that is for string representation, right? It's for Unicode kind of thing. Rohit, multidimensional arrays are possible in Python. That's always there. Okay. Okay, everyone. Now just sit back, relax, and now I'm going to show you how NumPy is memory efficient, right? So how NumPy is memory efficient, right? So I'm going to show you a demonstration here. And in that demonstration, I'm going to show you exactly how NumPy can be a memory efficient thing. And Ravina, as per your question, by all the arrays that I've created till now are one dimensional only. They're not 2D arrays. I'll show you how to create 2D arrays. Okay, I'm sorry for that. So, I'm going to, tell you exactly how NumPy is memory efficient. This explanation will give you a strong foundation exactly why you need to learn NumPy, why you cannot exclude NumPy. Do you know that NumPy is mandatory for, all the data science programs? You cannot skip it. So let's see a demonstration where we'll find that how NumPy is memory efficient. And for that, I'm going to introduce one more module here, and that is something called time. Right, time is one of the module which deals with the time, time related activities, time, day, hours, minutes, isn't it, like that? And it has a function called ticks, right? That I'm going to use in my further demonstrations. So just giving you, a hint here of overview that there is a module called time that I'm going to use in my further demonstrations, right? On in this demonstration also. So how NumPy is memory efficient? So what we are going to do is we are going to, okay, let me tell you the plan. We are going to create a list and a list in Python and an array in NumPy of size 1000. You got this, guys? So what we're going to do is we're going to create a list of in Python and array in NumPy of size 1000 elements. And we are going to check the total memory occupancy of each list and array. So that's how we'll come to know that exactly you know, exactly what size they are occupying, and if there is a huge difference, it will give us a strong reason to to go with the NumPy part. So here it goes like this. Import sys. This is once again one more module in Python, right? And why we are using sys, I'll tell you, because sys has a function called sys.getSizeOf. So sys has a function called getSizeOf, which returns the size, in bytes. So whatever value you pass, let's say I pass an integer here. Let's say I pass integer 1. So it's an integer, right? So what it is going to do, it is going to give me the size of integer, not the one. Sys is system, that's true. So you can see here that how much size, how much memory, sorry, integer occupies in Python. And here you can see that it occupies 28 bytes. Sorry, that's huge. All right, guys, so I'm back. Just had a trouble with the network connections. Okay, so that is a get size of, and let's proceed further. So we have something called Python list, and here I'm going to use a function called range, and I'm passing the value 100. When I says you got 14, right? That depends on maybe the difference in the Python version probably, and the operating system also. In case if you're using a different operating system or a different Python version, there are chances of differences, right? Because in different operating systems, the memory occupancy is different. And I'm using 64-bit. Okay. No, Palak, it gets size off. Okay. Arrays are homogeneous, right, Nivas? Okay, so let me complete the demonstration here, right? So that I can show you the things here. So here I'm generating numbers. So range function generates numbers from 0 to n minus 1. So it is going to generate uh, numbers, right? I'm just showing you, right? So okay, it shows like that, but believe me, it has numbers within it. I can iterate through that. Now, in the next demonstration, what I'm going to do is I'm going to generate a NumPy array of the same size, NumPy array, and here I'm going to generate you know 1000, right? So NumPy has a function called arange, does the same work as range in Python, right? So here you can see that I'm using I've created two lists here. One is the Python list, and second is a NumPy array. Now here, for generating the NumPy array, I'm using the arange function from the NumPy library, and the size is the same. The size is 100, so it's also 100 elements. And so what I'm saying, it's 1000, right? So it is 1000 elements in the Python and 1000 elements in the array. Now, what I'm going to do is printing. Okay, the total size occupied by Python list is comma. So we have Python underscore list, right? The total number of elements in Python list into sys.get size of a number, because all the numbers are integers in Python. So here, okay, let me explain this thing, right? Shagun, both are same. KD, you are using double R. It's single R in arange. Okay, sorry for the interruption. Okay, so here I'm retrieving the number of elements in the list. Okay, so len is for number of elements in a list into the size of one integer. Okay, number of integers in a list into size of one integer. That's how it is going to do. Okay. Okay. Print Coming to the questions, right? Just give me a moment. The total size of the total size of NumPy array, right? So for this, what I'm going to do is NumPy array an array dot size into NumPy underscore array dot item size, like that. Okay, so that's how it goes like. So here we have a function, okay, property, right? It's getting complex, I know, but just be with me, right? NumPy array dot size, it returns equivalent to len, okay? It returns equivalent to len into item size. Item size is okay, fine. Okay, fine. NumPy underscore array dot size returns number of elements in array. This will be better, right? If I write it here, NumPy underscore array dot item size returns size occupied by one element in NumPy array. Okay, like that. So in case if you want to print these values differently or separately, you can do that, right? I'm just trying to show you exactly what the output is and how it is working. Oops, where is the error? Okay, I forgot one. Okay, just give me a moment, guys. Okay. Okay, fine. So here is the difference, guys. The total size occupied by Python list is 28,000 bytes, whereas the total size of NumPy array is 4,000 bytes. So you can see the difference here. It's huge difference, and the difference is such huge that it is, many times manifold, right? It's manifold what it is actually is. So we have the same number of elements, 1,000 and 1,000. So if we do the same thing in Python, so it is 20,000 bytes, and if we do use the same thing in NumPy, it is 4,000. So it's such a huge memory saving, isn't it? So that's too much. Okay, so coming back to the questions here, guys. So I have a lot of questions which are going in the chatting window. So guys, in case, okay, fine. So here's a small formula for all of you. In case if you are finding different sizes in your systems, that's completely okay. That depends on what kind of operating system, what kind of Python version you're using. So whether it is a 32-bit OS, 64-bit OS, Python, which version, right? So there are a lot of factors which affects all these things. So, and that's okay. For the time being, I would like to encourage you to see the difference, right? And no matter what numbers you're getting, but the size of the general Python must be at the higher side. That's what I'm trying to show here, right? Okay, now what I'm going to do is I'm going to show you another demonstration that is going to be a little more tricky, and it is going to take some more concentration, right, from my participants. So here in this demonstration, I'm going to show you exactly performance, right? Performance vector in NumPy, right? So this is something that we're going to talk. Performance is something, which is always been the number one priority when compared to space occupancy. So we already have learned in data structures that we give priority to performance, the time, complexity compared to the space complexity. So this is what it is all about here. So in this demonstration, I'll just show you the plot. Exactly what I'm going to do here is, so in order to show you the performance factor, I'm going to show you the output in the milliseconds sense, right? So what is this output in the millisecond sense? So let me tell you the whole plot here. So I'm going to create two Python list and two NumPy arrays, right? So I'm going to create two lists, which is like L1 and L2 in Python, and N1 and N2 in arrays, and I'm going to see the difference in time or time comparison, right? And we will compare exactly how much time did it took to, add exactly, right? I'm saying different time comparison while adding, right? While adding the two list, right? So I'm going to see the difference in time, right? It's a time comparison while adding the two list. So I'm going to add the two Python list, and I'll check the time consumed in adding the two Python, and then I'm going to check the time consumed in adding the two NumPy arrays. Uh, Hi, Josh. That's good, but it is going to make the program complex here. So I'm just keeping it simple and letting the same thing on you, so that after I'm done with the basics, you can extend that, and or else I can do it offline. Import time, as I told you earlier, right? So that's why I discussed this thing. Import time is one of the module that deals with the time part, and time module has a function called time, right? What it does, it returns something called ticks or seconds, right? So this is like that. So here there's a function called time.time, right? So what I'm going to do is I'm going to use this function, and returns the number. What is this number? This number is actually a seconds, right? So basically it's basically like from 1st Jan 1970, how many seconds have elapsed. So it's like that, right? Sounds, yeah, epoch. That's true, Shruti. So, okay, you remember all these things, right? That's good. That's good. Okay. So this is seconds, right? So I'm just going to use these seconds. And I'm just going to show you the some basic thing here, right? Start and end, right? So basically, end minus start. So that's how we see the difference, right? So that's how we see the difference, basically like how much time has crossed, and there was no difference in the time. So I'm going to make some difference here, like 0.2. Okay, fine. So you can see here, so it's a delay of 200 millisecond. So there's a function called type, right? I'm not confusing you, right? I'm not confusing you. So I just wanted to show you that when you compare the computation, you get the response in less than 1 second, right? So you get this kind of value. So what I'm trying to say here is that in order to show you the difference in the milliseconds, I'm going to multiply the number by 1,000, so that you have a precise idea about how many milliseconds have passed by. So the output is going to be in milliseconds. I'm just preparing you for this magic or this math here, right? So in 1 second there are 1,000 milliseconds. So this is something which is there, right? So 1,000 milliseconds is something is the unit for 1 second. So because the difference is going to be very, very less, it's going to be some 0.00 something. So if I want to tell you exactly how much, like, because we cannot understand 0.00, isn't it? So that time is something that that it's difficult for us to imagine or visualize. So what I'm going to do is I'm going to convert the difference of 0. something 002 something 3 in by multiplying it into 1,000. So that gives us the time in milliseconds. So that's how it is going to work, right? So guys, is this concept clear to all of you, right? So I was just preparing, right? I've not started my demonstration. Okay. Okay, that's great. That's great. Okay, fine. So here, let's get started. So this is list one, and in list one, I'm going to prepare. Okay. It is difficult for me to count, isn't it? Okay, it's 10 lakh. I got it. Okay, so this is how it is going to work, right? So I've created a list of numbers, right? I'll do this because I'm going to use it. Okay, now this makes more sense. So I have two lists here, right? And can I ask, this list belongs to Python or NumPy? Okay, Python, that's true, because obviously that's true. And here A1, we have np.arange, and we have the same size, and we have A2 here, np dot np dot a range, and here we have the same size. So guys, as I told you that we are going to create two lists here. One pair is for Python, and one pair is for NumPy. What I'm going to do is I'm going to add both the list, and we're going to calculate the time difference here, right? So let's do this. So first of all, let's do this for the Python part, right? So what I'm going to do is start time, right? Started the meter, right? Or the count, the time tracking, right? Started the time tracking. Now in the further code, what I'm going to do is result equals to, okay, for x comma y and zip L1 comma L2. Okay, guys, it's a beautiful expression here, right? So what this for loop is doing, basically, I'm using a built-in function called zip. What zip function does, it extracts one item from L1, one item from L2. It stores that one item in X and the one item in Y, right? So it is going to pull one item from, okay, zip function is going to pull one item from each list, and it is going to assign one item into X and Y. That's true, Shruti. Yeah, that's true, right? Okay. Zip is from Python, right? Zip is from Python, not from NumPy. So once again, I'm repeating, zip is a function which is going to pull one item from list 1 and list 2, and it is going to assign into X and Y, right? So this is going to run 10 lakh times, and every time the value of X and Y is getting replaced. So what I'm doing with that X and Y, I'm going to add the values, right? So look at this expression. Okay, thanks. Is it okay? I'm sorry. Oh, zeros. You're bad. Okay, fine. Thank you very much, guys. I really appreciate your attention, right? And one more thing I want to say here, right? So when the participants are asking the question, in case if my other participant knows the answer, please type in the chat window. That will help me, continuing with my content. Thank you, Shruti. Okay, so guys, I hope this expression is understood here. And whatever it is going to return in the form of list, square bracket represents list. Remember, square bracket represents list, and it is going to store it inside result, right? Okay. So guys, what we have done here, I extracted the item using the zip function. I extracted one item from list 1, assign into X, one item from list 2, assign into Y. What happened with that X and Y? What happened is that those X and Y got added, right? And whatever the number was generated, like 0 and 0 plus 0, 0, 1 plus 1, 2. So it's like 0 comma 2, right? So that's why, yeah, it's a comprehension, you can say, right? So this is the beauty of Python also, right? That's how it works, like. And NumPy is more beautiful than this, right? I'm telling you, right? Just give me some more time to show you. So it is going to contain the addition of all the list, right? And now this is stop here, time dot time, okay, getting the current time after addition, right? I think this makes sense, isn't it? So we basically stored the start time, we did some math magic here, and then we pulled the current time in the stop. So what I'm going to do is I'm going to show you the difference. Print list took comma stop minus start into 1000. I think this should make sense, isn't it? Okay, am I missing any bracket? No, fine. So list took stop minus start into 1000 milliseconds. So that's how it works, right? So this should be understood by my participants, right? This time tracking, right? How I have done this. Thank you, Sneh. Now in the next phase, let's do time tracking for NumPy now. Okay, let's do time tracking for NumPy. So what I'm going to do is I'm going to start once again time.take, right? And I'm going to add the arrays. So result equals to a1 plus a2. Now first of all, so you can see the beauty of NumPy here, that you don't have to see go through all that complex stuff that was looking beautiful actually. And I'm going to time.take and just retrieving the time, and let's do a small copy paste here so that we can save some time here. And Python took NumPy took milliseconds, right? Okay, that's great. Fine. So let's see the magic here. Let's execute 1, 2, and 3. Oops, my mistake. All right, so here it's a hooping difference, right? Okay, it's a hooping difference. So we can see the huge difference in the time taken by the Python data structures and the time taken by what's that? The NumPy data structure, right? So it took, in my case, it took 230 milliseconds for adding to list in Python, and if I do that with the NumPy array, it merely took 18 milliseconds, right? So it's really a huge difference, right? So yes, MNBGTY, it can be used for more than 2, right? So that's also possible. Fine. So guys, everyone, right? So did you observe the difference in performance and memory efficiency, right? So can I ask you, are you convinced with the efficiency of NumPy, guys? So in my okay, next topics, I'm going to discuss a lot of things here, right? So okay, generating random numbers in Python. Okay, guys. Now, because you have a good, because you have a good base now, so I'm going to, going to do it a little quick here. So I'm not going into details. Just see the code and learn the output, learn the response, and then proceed further. In case if you have a doubt, you can just point me. Otherwise, I'm going to move in a little quicker way here. Okay, fine. Generating random numbers in NumPy, right? So let's do that. Okay. Printing. Okay, print np.random.ran2, 2, right? Okay, fine. So here, this is a function called rand, right? So what it does basically, it prints it generates an array. It generates an array of given dimension, and the numbers will be between 1 and 0. Okay, so it generates an array of given dimension, and the numbers will be between 1 and 0. You can see the numbers are between 1 and 0, right? And the dimension is 2 by 2, right? 2 rows and 2 columns, right? Yes, we can do that. So I'm going to show you, right, 2 rows and 6 columns, like that. Okay, so you can see that you can have, you have a number generator within the range between 1 and 0, right? Yes, we do have, right? I'm just going to answer you a lot of things here. Okay, so another one is np.random.choice. We have a, we have e, we have I. Oh, okay, guys, just keep a gaming sense in mind, right? Just keep a gaming sense in mind. Let's say you have a game where there are a lot of players playing around, and you need to, correlate those players with some sort of array or matrix. So that's how you can do it, right? Okay, so we have the choice here, right? Okay, so you can see here that every time I'm executing, I'm getting a different alphabet, mostly A and U, right? Okay, and this time I got E, and this time I got I. What I can do here is I can specify a size, and I can specify how many characters I want, right? Okay, so here basically what I've done is that out of this choice, out of this list, right? How many random alphabets are needed by me, right? So it's like that. Okay. So fine. Just have a gaming sense in mind, right? You're just creating some game and some random sense of some random sort of behavior you want. So out of a given set of characters, so you can simply have this thing in your mind. Okay, guys, I'll just proceed further. There are a lot of things to be done in random. I'm just going into detail because this is sufficient to give you a strong knowledge. Excuse me. Sorry. Shape of array. Okay, fine. This reminds me of one of the Hollywood songs, I believe. Okay, shape of array we are talking about here. So what is shape of array? For that, I'm going to give you an example here. So here we have something about shape, which basically it tells you about the dimensionality of array, right, or NumPy array. Print a, so it is print a, and print a dot shape. So here you can see that it is 4 comma. Now first of all, why this 4 comma is coming? Okay, so first of all, it's a 1D array or one dimensional array. Okay, now this is something that you need to take care. And what dot shape does, it returns number of elements in 1D array case only, right? So if it is 2D array, it is going to behave differently, but in 1D array, it is going to return the number of elements in the array. So how it behaves in a 2D array, let's see in this another demonstration. So this time I'm going to create one more array, np.array, and this time I'm going to create a 2D array. Okay, fine. And here we have 5, 6, 7, 8. So guys, now especially for the beginners, right? Especially for the beginners, this is a 2D array. Whenever I create a 2D array, creating 2D array, so you need to represent this thing like this, right? So how you visualize that part, right? So that's important here. So it's like 1, 2, 3, sweet, 2, 3, 4. 5, 6, 7, 8, right? So that's how you visualize, guys. Okay, so you need to visualize the array in this sense and make sure that you have you have the logic of rows and columns where the rows index starts from 0 and the one column index also starts from 0, right? It's a matrix. That's true, Sujit. It's a matrix. So what is the shape of this array, right? Let's find out. Print b dot shape. What's the problem here? I did some mistake. Yes, I did a mistake here. And what's that mistake is? I forgot to add a square bracket here because it expects. Okay, good. No, it's not data type. By default, it's in 32. Leave it. Okay, fine. So it's so you can see here, guys, b dot shape. So how many rows and how many columns are there? So you can see here, there are 2 rows and 4 columns, isn't it? So when you see shape, it basically, doesn't count from 0, right? So it's a general counting, right? There are 2 rows and 4 columns. So I think now this shape makes sense, isn't it? So okay. So guys, did you understand that shape function is basically used to know the dimensionality of a given array object in NumPy? Is that clear, guys? Knowledge level here. Fine. So once again, I'm going to use this array object here, right? So once again, I'm using b.array. Yeah, KD can be multi-dimensional too. So here we have this array, and you can see here it is printing in the same way as I visualize it here. Okay. And now what I'm going to do is I'm going to show you the shape of B is comma B, the dot shape. So the shape of B is 2 comma 4. It is right, 2 rows and 4 columns, 1 2 3 4. So that's good. Yeah. Now what I'm going to do is I'm going to reshape the array, right? I'm going to reshape the array. Now this is something which is beautiful, right? Everyone now observe here, right? Okay, so what I'm going to do is I'm going to reshape it. B equals to B dot reshape. This time I'm going to make it you know okay, 4 comma 2, right? Okay, print B. Okay, print /n/n. So does this make sense, guys? Is it 4 comma 2, right? Just check after resizing. Is it 4 comma 2? Yeah, that's true. So you can see the beauty of NumPy here is that how easily you can simply change the structure. Print shape, and that is B dot shape once again. So here you can see that the shape of B initially was 2 rows and 4 columns, and here it is 4 rows and 2 columns after calling the reshape method here, right? So this is something which is beautiful about NumPy, right? So it's like that. So I hope this makes more sense now, right? How we reshape it. Apart from that, we have one more function, right? Flatten, right? Okay, so what does flatten does, right? For that, I'm going to give you an example here. B equals to B dot flatten. So as the name suggests, right? As the name says, it brings all the values in 1D order, right? So what do you mean by 1D order, right? Let's print after flattening. Yes, Asim, that's true. After flattening, the value of B looks like this. Okay, so what do you have here? We have all the values of that 2D array, or the 4 row 2 and 3 row 2. So it basically flats all the values and simply in the one dimension, right? So that's how you get it. So as I told you in the beginning of my session that it's all about array play today, how you're going to play with the array, and it's going to be more fun ahead, right? There's a huge fun waiting further. Vani, for 3D array, right? I'll just give you a hint here. Vani 3D array goes like this, right? 2 comma 3 comma 4, right? And then we have here 5 comma 6 comma 7. Okay. Okay, Vani, I hope this makes some sense, right? So I'm just giving you a hint here, right? I hope that helps. Sujit, what's the use of flattening? It depends. According to your requirement. Let's say you want your data to be in linear fashion, right? So if you want your data to be in linear fashion, you can use the flattening. So here we are not learning any question or any property or a method because of a reason, but we may require it or we might require it in further future while doing the data analytics or machine learning. That's why it's going like that, right? Okay, moving further, right? Moving further. Okay, just a small test, guys, right? Okay, just a small test out of this NumPy array. I'm going to write some codes here, and I'm not going to execute. I just want your responses to be there on the chat screen, right? So let's get started. A equals to, and it's going to be quick, right? A equals to dot array, and I'm going to create 1 comma 2 comma 3 comma 4 comma 5. Okay, print type A, right? Just yeah, Allegheny, I'll do that. Just type the answers, right? Comma A2. Just verifying, right? Print A0. Okay. And okay, I'll do that. A0 equals to 5. Print Okay. Okay, guys, this will be fun if you can execute, right? Because whatever you're thinking of output is not there. Oh, that's good, Ravina, Snehal. That's good. Suhamati, please check the code and observe, right? What is happening? Observe. So first of all, in order to, okay, I think you're asking about this one, right? So I'm just explaining this one. Rest should be okay. Yeah. So 1, 2, 3, 4, 5, 6. First of all, you need to learn exactly how you visualize the 2D array, right? So there are two lists here, one list and second list. So this is the first list and this is the second list. Now, basically, this position is basically 0, 0. Oops, I missed something. My insert is on. Okay. 1, 2, and 3. This position is 0. Okay, this is called 0 row. Okay, this is called 0 row, and this is called 1 row. Okay, you need to observe this one. 0 row and 1 row. And this is 0 column, 1 column, 2 column. Once again, 0 column, 1 column, and 2 column. Okay, so from 0 row and 0 column. So this is 0 row and 0 column. So it is going to print 1. 0 row and 1 column, 0 row and 1 column, 2, 1 row and 0 column, 1 row and 0 column is this 4. So it's like 1, 2, and 4. Thank you, Katie. Thank you very much. I hope this makes sense, right? Thank you, Anthony. Thank you very much. Now it is going to be more complicated, guys. Everyone just buck up, just tighten your seat belts, and we are just moving forward with some more complex things here, right? So let's get started. Here we are talking about something called slicing, right? And slicing in 2D array, right? So this is going to be a little complex part. So I hope so everybody is ready for this. Now here I'm going to create an array here, np.array, and this time I'm going to create an array, right? In case if you can tell me the structure in chat window, it will be very good. 2, 3, 4, 5, 6. How it's gonna look like. Oopsie, 7, 8, 9. Let's make it more complicated. 4, 5, 6, 7, 8. Okay, I just made it more complicated, guys. 11. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Buddy, where are you? 9, 10, 11, and 12. Okay. Okay. I don't know what shape it is. Let's check it out. Oopsie, what happened, buddy? Did I miss some? Okay. Oh, come on. Every time I'm missing these brackets. Okay, got it. So it's 3 rows and 4 columns, right? Thank you, Shruti. Thank you. Okay, fine. That's great. So for the beginners, right, I'm just going to construct this array here for the visualization sake. So it's going to be 1, 2, 3, and 4, 5, 6, 7, and 8, 9, 10, 11, and 12. All right. So this is how this array is going to look like, right? Okay. Now, what we want basically, I want to extract. Okay, we are doing slicing here, right? So basically, slicing means that just retrieving the values out of this array. So how we are gonna retrieve the values from this array? Now here, the challenge is to retrieve the first row. Okay, the first row. Okay, when I say first row, can you tell me what row I'm talking about here? Okay, okay, fine. First index. Okay, fine. So okay, now can I'm more clear now, right? So when I say index, that becomes a technical term. When I say first row, it is English. So when I say first index, that becomes technical, isn't it? So the first index row is the one index row is this one, 5, 6, 7, 8. So the challenge here is to retrieve this whole row, right? We don't want any other data out of this matrix. So how are we going to do that? So this is something called slicing, right? So we have done this in string manipulations as well. So we're going to do this in an array, right? NumPy array. So let's do this. How are we going to do it, right? Okay. So first of all, okay, A, and specify the row and specify the column here. Okay, everyone. So specify the row and the column. Okay. Some people are trying. I want to, okay, from row 1, I want the first row and all the columns. Yeah, that's true. Oops. A10:4 Sakshi says, fine. Every person is trying. Okay. Why it's not working? I've done the right way, I believe. What is happening here? Am I missing something? Yes, I'm missing. I'm tangled in the questions, I believe. Okay. Fine. Sweta Kumari. Okay, 1:1:01. 1:2 KDI. You sure? Okay. Fine. So here you can see, guys, right? So how this syntax goes like? This syntax goes like A, row index, comma, star, means all columns. Okay, column index. Okay, it's like this. So in case if you're new to this, right, if you're facing trouble, so the syntax for this expression goes like this. A, the row index. So the row index is 1, right? And the column index, I want all the columns, right? So that is colon, like that. Colon is for all. So we can do the same thing in different sense, right? So for that, it's going to be a little complicated this time also. Row 1 copy, right? And this time it's going to be right. Okay, A, and I'm going to make 1:2, I believe. 1:2, and then I'm going to push a comma and then colon, I believe. Colon, and I'm going to print row _1 copy. Okay, fine. So fine. So guys, you can see here, right? So here, this is starting from 1 till 2 minus 1. That is 1 only, right? It's like, so the expression is like here. The expression is like 1 minus n minus 1. 1, 2. Okay, fine. So in case if this is complicated for you, right? You can see here, this expression is like from 1 row to n minus 1. So 2n is 2 here. So 2 minus 1, 1. So it's the one and the same thing, right? I'm just trying to show you the alternate way. It's an alternate way, but it's one and the same thing. It's an expression, right, Salai? That's the expression of how we do it. So guys, can I ask you for the third whole row? Can I ask you for the third whole row? So what you're going to write for the third row, 9, 10, 11, and 12? 2, 0, 1, 2, 2, that's true. Rajesh, Vaki, that's good. Yagna, that's going great. I'm very much sure that the participants who are doing the parallel programming are also doing the things. That's okay, Kenshu? Okay. Fine. Now, fine. Okay, let's give it a challenge, right? Okay, let's give it a try. What if I want 2, 6, 10? Right? What if I want 2, 6, 10? Print the second column, right? Or the first index column, 2, 6, 10. Okay, so the output would be like 2, 6, and 10. Prabhu, that's because of the different shape as per your question, Beta. So there. 2, 6, 10. That's good. So let's do it, guys. So let's print it. Print. What we have? A:1. Okay, so this works, right? So this is going good. That's great. That's great. Excellent, guys. Excellent. Another challenge. Pull 2, and 3. I'm encouraging my participants to do the parallel practicals so that they can, I want you to do exactly, right? So that is the ultimate strategy behind, asking the questions. Print A equals colon 2, 1 colon 3. Okay, observe guys, observe. Just giving you some time to, just go through this, observe what I've done.
Yeah, thank you, Rajan, for the informative session.
Yeah, thank you, Argo.
Yeah, so Rajan, as soon you send me the deck, so I can forward it to the learners.
Definitely, I'm going to send you in a moment.
Sure. Okay, thank you everyone for joining today's session.
Let me explain the structure of the session. So if you look at the notebook, what you will see is that there are many examples. Okay, so you will see titles, you will see various sections, NumPy arrays, whatever, and you will see examples. Okay, so there are many examples, and then you will see there are some quizzes. Now some of those quizzes are just quiz, some of them are marked as homework. Okay, so ideally the structure that I have prepared for this session, including I think the next session on what is that, pandas also, on Wednesday, will be similar. So what we'll do, this is we'll call this a workbook. Okay, because a lot of these topics are, I would say, in the beginning it's more practice and programming and tool related, and slowly it becomes more conceptual. So initially we need to spend more time experimenting and getting familiar with the tool. So that's the idea here. So the way that I'll go ahead with this session today is I will explain the concepts while demonstrating those concepts practically using these various examples. So don't worry about all these different commands. Okay, I'll explain all the different commands. These are all very simple commands. It just looks like there are so many commands. So don't worry. I have here, almost like 11 commands or something, but you don't need to worry about that. Okay, these are all simple commands that you will learn, and same commands we'll be using again and again. Right? So the whole idea of programming is to become familiar with the tool. Okay, so I'll go through these examples. I'll explain what's happening. I'll show you the results, right? And then when sufficient time has been given to a certain concept, we've gone through example 1, 2, 3, 4, 5, whatever, there will be 1 or 2 quizzes. Okay, now the expectation from the audience is that you try to solve the quiz. Okay, like in this session, right? So we'll do a few examples, we'll discuss the concepts, we'll see the results, and then you will try to attempt the quiz. Okay, and then there are some additional interesting questions which I felt is good for practice. Those quizzes I have marked as homework. Now if we have some time in the session, then we can consider discussing some of the homework questions. Of course, I'll give 1 or 2 hints as I go through the workbook, but we will not solve them right now. If there is time, then we can think about it. Okay, then I think we should start. Let's begin the session. So welcome to the session on NumPy, everyone. This is where we start transitioning from programming to data science. Okay, this is where data science starts. And right off the bat, I have to tell you, and I have to make it very clear, that NumPy stands for Numerical Python. It is the most popular and most stable and most reliable mathematical computing package. Okay, in other words, its focus is mathematical elements, and that is something that we will need going ahead. When we work with anything, any kind of data that we work with, on the back end, it's going to be NumPy powering a lot of the operations. Okay, so we'll explore NumPy in detail today. There are many aspects of NumPy which you will use and encounter visibly, right? Visibly means what? You will be using commands like np.mean, np.median, np.std, standard deviation. All these things visibly you will use later in the program or later in your data science journey. Visibly you will use, and large amount of NumPy you will be using invisibly, okay, because packages like pandas, matplotlib, and all the other data science packages at the lowest level, they need NumPy. Okay, they need NumPy. They work. NumPy works on the backend. So it's important for us, as I said, we'll be visibly using NumPy, and invisibly also we'll be using NumPy, which is why the session today is designed so that we get a lot of familiarity with this package called NumPy. Okay, and it's very important for analysis and data manipulation, and its focus is that it's trying to bring mathematical concepts into a programming level. Okay, we will see how that is. So first I'm going to import the package. Now typically people give the short form NP. Okay, when you import NumPy, people usually just give the short form NP, and you can just import NumPy like this, no problem. But everywhere you have to say numpy.array, numpy.sum, numpy.mean. So the more conventional thing is to import NumPy and rename it to NP. Okay, so let me run this. And all of you can run the cells that I am running, and follow me, right? As I walk through the workbook, follow me. So I've imported NumPy, and as you can see, it has run. All right. Okay. So directly now we are going to start with one of the most important objects in NumPy, which is called NumPy array. Okay. So arrays are the primary way of storing data when you use the NumPy library. The class is called ND array. Okay, on the back end it's called ND array, which stands for n-dimensional array. We will see why it is called n-dimensional array, but the command is pretty simple. So let's start with creating empty arrays. Let's see if we can create an empty array, because we all know how to create empty list, correct? So if I just say list equal to something, right, and then I print list, oh no, I can't call it list A equal to this, and then I'll print list A. So list A, as you can see, it's an empty list. So we all know how to create empty list. How do you create empty array? So the command is np.array. Now if I just take np.array and call the class, right? So it is a method. Okay, it's a method, which means you need to use parentheses. Okay, not like this. You can't use square bracket. It's not an object yet. You need to call the object. So once you call the class array using the method by the name of array, then this thing becomes an object. Now let's try running what happens. So if you see here, this method is missing a required argument called object. So the NumPy array needs a starting object. Now suppose I use object equal to none. Okay, none in Python is some kind of placeholder. It's actually null value. Okay, it doesn't have any size. So suppose I say object equal to none. So if I just say, for example, len none. Okay, len none. So it says object of none type has no length because it's null value. In Python, this capital NONE is a null value. There is no size. It just means nothing. Okay, but I can put that nothing in an object. Basically, if I specify my object as none and then call the array method, now I can print the array. It says that it's an array with the data type object. Okay, and if I just use the type command of Python on this object, it says that it's a NumPy ND array. Okay, now of course you can just print the array using the variable name itself, but you can also use the print command. We know this, right? Now if you print this, it says none. In other words, it is a non-sizable array. Okay, and I want to get this blank array out of the way, then we will go into proper arrays. So if you see length of NP array right now, it's an unsized object because we use the none data type. Okay, now you can take a blank list, right? You can obviously take a blank list and put it inside the array method. So the object here, basically the parameter name is what? Object. Okay, so np.array object equal to blank list. That's what it's doing here. Even if you don't specify the parameter, by default, if you put one parameter, it's going to be object. So let's say what happens with the empty list. Now if you see, this array is different from this array. Okay, so here it says array none and it does not have a length because the array itself is unsized because you used NONE. This is the only exception case, by the way. Every other case is going to have a length. This is the only exception case. Now in this case, what do you think length is going to be? Let me print the length one first. Okay, length has to be 0. So it is a sizable array now. Okay, if you use a list input, it is now a sizable array. Okay, and of course you can check the type of this object. It is called numpy.nd array, and you can print it just to get what is inside the array. So if you directly just output the variable, it will come like this: array bracket the value of the array and then the data type which is used. By default it is using float 64. This should tell you that there is a parameter called data type, by the way. Okay, obviously this method must have a parameter called data type. We will see that later. So this is, the exceptional cases that I wanted to discuss before moving into the more typical cases. So please feel free to learn more about these blank arrays, unsized arrays and things like that. It's not really the most important thing, but I think it is important to know what the exception is. Then when we talk about lists like 1 4 5 6 2 3 4 5 whatever, then we know, okay, all this is sized arrays with different sizes, and then there are some exceptions. So whenever you meet an exception, you should know what is happening. Okay, so you can also check the empty method from NumPy, and how to create more blank arrays. You can take your time later to do this. So with that introduction, let's actually start with proper arrays. So typically, you can create arrays from lists. It's the easiest way. Okay, so suppose I have some list here and it has 4 numbers, 1 4 5 6. If I just declare this sum list variable and print it, it says bracket 1 4 5 6 bracket. Okay, this is a list. And if you check the type, it says list. Okay, all I need to do is I need to take this object and pass it in this object parameter, right? And then use the np.array method. It's going to convert this object into an array. So now if you just output np array, this variable, the list is inside this object called array. So the value is 1456, but the data type has changed. So you can check the data type using type again. It will say numpy.nd array. Okay. In fact, the array itself has an attribute called dtype. And by now we should be familiar with this dot method, dot syntax. So if you have an object of a class and then you just do dot and tab, you will get all the various methods and attributes that you can apply to that. We will be seeing some of these methods and attributes today, not all. It's not possible to do all. We'll see most of the important ones. Okay. So here dtype is actually one of those attributes of the object. So now if you do np.arr dtype, right, it will give you the data type of the value inside. Now if you see I put 1 4 5 6, obviously these are integers. So these are integers. If you just type 1 4 5 and 6 like this inside a list, Python recognizes these as integers. Okay, so it's stored as integers, and when you convert it to array, nothing changed. The data type that was before, and if you see here it's green color, right, so it's an integer. The same data type has gone to the array also. So 1 4 5 and 6 inside the np array are also int 32 integers. Now are numbers the only thing that you can do with arrays? No. Okay, just like lists, you can have list of strings also. So here I have a list, apple, orange, banana, watermelon, jackfruit, all are strings. It's a list. Okay, and I'm passing it into the np.array method and then storing it in the variable. So now if you see, the list is here, the array is here, this is all fine. But here you see there's this thing dtype is equal to this character here. So these are actually memory levels, right? So what Python is doing is assigning memory sizes depending on the kind of data that you're passing into the array. Okay, so for 1 4 5 6, int 32 was enough to store the information. Okay, these are larger strings, so now it has changed the data type to something else. It is a string, but even in strings there are different memory levels. Okay, so then you can again check it is still a numpy nd array. All right, and if you check the dtype attribute from the array, you will get this. Okay, this is a kind of string attribute, data type. Now what you can also do, as I told you, is that dtype is a parameter in this method. So basically this np.array is a method and a class, right? The class is called ndarray, this one, numpy.ndarray. The way to create it is this method called numpy.array. Now in that, suppose I have object 1, 2, 3, and suppose I pass my data type parameter as int. Okay. Now I'll get, see, 1, 2, 3. This is obvious. Even if I don't pass this parameter, by default, it's going to take 1, 2, and 3 as integers because Python recognizes these as integers. The same thing if I say dtype equal to float instead of int, right? Same object, and I create a new array. Now you see it stores it as 1 point, 2 point, 3 point. So I have forced these things to be float numbers. That is why you have this decimal here. In this previous case, you did not have the decimal because it is int. Okay. So what are we learning here? We are learning that NumPy array is essentially a collection of values, just like lists, and it has data type for each of these values. Okay. We'll see a few more examples. Now, if you see this, what am I passing here? -1, 5.5, 2, 3.5. This is my list. I'm not specifying the data type, right? What will happen? So here, see, 2 is an integer, -1 is an integer, 5.5 and 3.5 are floating numbers. What's going to happen? These integers will be forced to convert to float because you need to maintain the same data type inside an array. So that is one of the restrictions or conditions of NumPy arrays. Okay. So in my list, it's not a condition, right? So if I just say, if I just copy this list and put it here and print it, I just printed this list, right? Look at this. This is still an integer. This is floating. This is integer. This is floating. No problem in list. In NumPy arrays, what happens is that all the data inside the array will be of the same data type. So if you see in this case, the integer got converted to floats. The reason for this, because these are mathematical constructs, the expectation is that when you use this for programming later, if you maintain a consistent data type, then you can use consistent transformations and functions on the data. Later, when you do some programming, it shouldn't happen that a certain function you are applying works only for float, does not work for integer, and that causes a lot of problem. All this is very common when you work with especially data science, machine learning, these kinds of things. This is very common. You get all sorts of errors if you have not accounted for various data types. But accounting for each and every data type for each and every function is not easy. It's quite complicated. The easier way is to convert everything to one data type, which is what NumPy is doing. Okay, so in this case, if you see, it's all converted to floats. What will happen if you have a string and a number, integer, and another string and a float? What will happen in this case? Now, see, this is a list, okay, but I am now creating an array from the list. What will happen? If you notice, this integer got converted to string. Can you see these two quotation marks? So now the array has forced this integer to be string, and this 4.5 float number, that also has been converted to string. And the string memory usage is this data type here. And if you saw previously, it was U10, now it's U32. As I said, these are different memory sizes to store the data type, right? But these are strings. In the end, these are now strings. So note that the numbers have now been converted to strings. So the restriction in arrays is very clear, right? You cannot have various data types in the same array. The reason for that is that we want consistency so that whenever we use arrays in the backend, and if you remember in the beginning of the session, I said that visibly we will use NumPy methods, and invisibly it is used many places. Like all the data science packages in Python, all the machine learning packages in Python, they use NumPy invisibly on the backend. For them to work, we need this consistency in the data type. Okay, so this is just a short introduction into data types of arrays. I hope there is some clarity here, right? You can, of course, query your GPT or something else, to learn more about these things. You can go deeper into this. Okay, all of these, by the way, I have given, a lot of statements in the workbook where I have written, hey, try querying a language AI model. That's something you can do in your free time. Okay, so first let's get all the basics nice and strong. Then in your free time, you can investigate more. Okay, or, if your interest so decides. Now, creating from list is very obvious, right? Creating arrays from list is very obvious. What happens when you create from tuples? Now see, for some of these things you will not spend so much time. Typically creating from tuple is not something that we do. There may be some cases where it helps, but it's the same thing, right? A tuple is nothing but an ordered collection of numbers, just like a list. So for example, I have this tuple here, -5 1 -4 7 2. Okay, and I just print this, and as you can see it says class tuple. All I need to do is I need to pass this tuple to np.array. That's all, and print and see what happens. So if you see here, you have these what do you call, the curved brackets. That means it's a tuple. Now you have your list brackets, so which by the way means that it's a list of numbers in the form of an array. Okay, think of it that way. So right now it's, and if you're confused or doubtful about what the class is, data type is, just do type of object, right? This command is very, very useful. I've used it so many times. This type of whatever. If you have a variable called x or any variable called var, at any time if you're doing any debugging, check the data type or check the object type. Okay. So here it says numpy.ndarray. We won't go more into tuples. It's something that's typically not frequently done. Okay, mostly people will just convert from lists. From sets, what about creating arrays from sets? Now we know sets, right? And we also know that sets are not ordered, which means you cannot. Okay, that's something we should talk about, right? So suppose I have list equal to 0 1 2. Okay, so it's a list of not 0 1 2. Let's say ABC. List A B C. Okay, I can't call it list A. Okay, so suppose I want to pull out the letter B. So I'm going to say list 1, correct? So that is going to, list A. So that's going to give me B. Same way, if I do tuple A equal to, and I'll just create a tuple with ABC. I'll just copy this from here. Okay, tuple ABC, and then I say I want the letter B. What do? I just need to do this, right? Again, I get the letter B. In sets, it's not like that. No? Sets are not indexed. So if I say set A equal to, and I just put this thing inside the set. Okay. So if I just put it like this, and then I say set A of 1. If you see, it says set object is not subscriptable because it's not indexed. Okay, it's not ordered. So does it make sense to create NumPy arrays from sets? Definitely not. Arrays are strictly ordered list-like objects. Okay, so just to prove the point, here is some set. Okay, and if I just print it, you can see already here I have the value 1.3 minus 5.6 2.8, but when you print it, the value gets changed. Sets don't have any inherent ordering. So if you try to convert into NP array, if you see here, it still preserves the set brackets, the parentheses. It did not become the square brackets. So now obviously the set also you cannot index. What about the NumPy array? You may think, okay, right now it's an array, so maybe I can index it. No, if you try to index and pull out the 1 by 1 elements, you cannot do that, because see, the array is 0 dimensional, which means this is not having any array element. Okay, so typically we don't convert sets to arrays. It causes all these issues, and primarily the reason is that sets are unordered, arrays are ordered. So converting set data to array data is almost makes no sense, right? I have not come across a single case where we do that. Now I have shown you creation of arrays of different data types. So if you see here, string, integer, float, and what we learned was that it selects the suitable data type and converts everything to the same data type. Okay, so in this case it got converted to string. In this previous case, everything got converted to float, right? That's what it does. What about if I use different data structures? Is that possible? So for example, I have this thing called mixed list. If you see, the first element in this list is actually a list. So this list, first element is list, second element is string, third element is float, fourth element is integer, and so on. Okay, so this list can exist without any problem, right? This list definitely exists, no problem. So if you just print it, you can see the list. No issues. It's a list, and we've studied list before. It can hold a lot of objects. Fine. You can index the list. The first element is another list, by the way, here 231. If you check the type of the first element, as I said, it's another list. Second element, it's the string New York here, right? And the type of this one, it is string. So each original data type is preserved, and even the original data structure is preserved. So list is a very, 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 very generic kind of data structure in Python. Okay. Now, what happens if you convert to array? That's exactly what we are trying to learn. If you convert to array, you run into an error, right? It says setting an array with element with a sequence requires that array has inhomogeneous shape after one dimension. So there is something called shape, and we will get to that a little later in this session. But the problem is that it's not able to find a proper data type for this object. This is a list. If I remove this, it will be okay. It will select something like what is that, U32, something like that. It will convert everything to string. Fine. But what about this? So it's not able to find any object data type for that. So the most generic data type that I have come across in Python programming for data science is the object data type. So what if I set data type to object? What's going to happen, right? And obviously my my data is the mixed list, this one. So let's try running this while setting the data type to object. It runs, okay, it runs and it preserves this. Okay. Now, is this useful? That is something that you need to ask, right? So now if I say np array and I pull out this, I get the list, no problem. I pull the second element from np array, I get the string. I pull the third element, I get the float, whatever. But what has happened in this case? In this case, you did nothing but created a list. How is this any different from list? All right. Yeah, Pratim, it's somewhat following a hierarchy. Yes, there is a hierarchy of data types, by the way. Correct. So it's like object, string, float, int. That's the very, I think, simplest hierarchy I can tell you. Object, string, float, int. Right? For all practical purposes, that's the hierarchy. All right. Let's all try to solve the quiz. Okay. And then we'll move to the next session. Next section, sorry. I hope we all remember functions. Define a function that takes in a positive integer n and returns an array of the first n even numbers. Assume 0 as the first even number. So do you need hints for this? One hint I will give, maybe list comprehension, if you remember. Do we all remember list comprehension? Try that. Okay. So in terms of the define function part, I'll just give it to you. So define return even or something, and you need to return what? You need to return the even nums. Okay. And it needs to take in a positive integer n. So n equal to positive means what? We'll start with one. Default value I'm putting 1, by the way. So I can also have safety conditions. If n is less than 0. Okay. So let me redefine the function. Okay. So I'm going to say def return events n and return even nums. This is what I want. Okay. So now I'm going to say even nums equal to list 2 star I for I in range n. And I'll just convert it. In fact, you can just convert into array in one statement, np dot array. So obviously you can store the list first, and then you can do this even nums equal to even nums equal to np dot array even nums. You can do this in 2 steps, or you can do it in 1 step also, right? So whatever even nums is, which is nothing but this list with a comprehension inside, that you can directly put here, and you don't need this one extra statement. Interestingly enough, you don't even need a variable here. You can directly take this and put it in return, and you don't even need 2 lines here. You can put this whole thing in 1 line. So now if I say return events and 3, answer should be 0 to 4. So when you are starting out with programming, I would suggest and recommend that you use temporary variables, right? You go step by step. But once you get more familiar with all of these things, how to chain commands and all, then you will get, this will become easier for you. Okay. So what I've done is I've chained a lot of commands together. All right. Okay, so as I was saying, ChatGPT will sometimes give you bigger answers. You need to try to talk to it and say, look, can you do it using a simpler method? Can you do it using list comprehension? Talk freely to GPT. Say that, look, your method is complex. Can you simplify it? Right? Try that and see whether it's able to give you a simpler answer. When you do data analysis and ML, you don't want complicated code. Okay, typically you want simple code, because the concept itself might get more complicated. So typically it's better to have simple code which you can easily pull out, understand, and debug. All right, great. So yeah, what we'll do is we'll continue. Now, as you can see here, there are some homework questions. I won't spend too much time on this because we need to cover some of the other concepts. I'll just give some hints. So again, this is a define function type of question. It says return an array of n random real numbers between a and b. So one hint is that I think you should go and check the random library. This is a library of Python. Okay, so Python itself has a library called random. So you just import random and then you please explore the methods that are available. One of those methods will generate random number between 0 and 1. So you can try to use that 0 and 1 generator and transform it to A and B. Okay. So don't do this right now, guys. Okay. Do it in your free time. And of course, you can query your GPT and try to see if you're getting what is required. Okay. There's another homework quiz here. What does it say? It says define a function that takes in a list, okay, and returns two arrays, one with all the numeric values and one with all the string values in the same order as the list. So obviously this input list is a mixed list which has string and number, right? So what your function should do, it should take the list as the input and it has to return two arrays. One array is going to have all the number values and one array is going to have the string values. Okay, assume that the input list only contains some combination of numerical and string values. This is also a fairly straightforward question. You should be able to return two arrays, and again you can take help from GPT if required, but if your code is becoming really big for something simple like this, then talk to GPT and say, look, you have I don't need this step, or say please simplify it further, whatever. Okay, so that's the idea, guys. We will not what happened, what's giving error, import numbers np. Let me check this. Pratim, let me check your answer. What you're saying is if import import numbers np, that's fine. Even list is blank, j equal to 0, f even check. This is unnecessarily complicated, I feel. For I in range 0 n, yeah, that's the thing, right? This is fine. It may give error. I'm not going to debug the error right now, Pratim, but it's fine. The logic is okay, but it's inefficient. See, now in this case, you're generating every number and then checking, are you odd, are you even, are you odd, are you even? Why? Because the first n even numbers are nothing but 2 times the first integers. So all you need to do is you need to use this range function, right? Very basic Python method. Range 3. So what does this range do? For example, if you just say range 3, it gives 0 to 3. Now if you say for I in range 3, print I. What are these I over the ranges? As you can see, it is 0, 1, 2. What is range 5? 0, 1, 2, 3, 4. So it's printing for you the first n integers, non-negative integers, starting with 0. What you need to do? You just need to multiply this by 2. Then you will get all the even numbers. 0 into 2 is 0, 1 into 2 is 2, 2 into 2 is 4. So 0, 2, 4, 6. So you don't need to use this if-else condition to solve this problem. You can, but you don't need to. Okay. I won't debug the error now in the interest of time. I would suggest that you take your time and do that. Yeah. Great, Pratim. Thanks. All right. So nice, what do you say, warm up to NumPy arrays. Okay. And what we have learned till now is that essentially we are using list to create arrays. Now, what you need to understand, till now we have seen one-dimensional arrays. Okay. The biggest feature of NumPy array is that you can store multi-dimensional data. Okay, and that's what we're going to understand now. This is the biggest, most important power of NumPy arrays. So we'll start with an example. So if you see here, the object I'm passing is list within a list. So you have the outer list here, and within that list you have two lists, 1, 2, 3, and 4, 5, 6. Okay. So if I just directly just print the list, what you will get is nothing. It's just a list with two lists. So if I say, a equal to this list and then say a0, you will get the first list. If I say a1, you will get the second list. Nothing special. Okay. If you convert it to array, what you will see is that it is now stored hierarchically. So if you see these two things, if you printed as list, it will not print this way, right? Just print it here and see what happens. It prints as a linear. But if you print it as an array, if you convert to array and print, now it is starting to show rows and columns. So I hope we can all appreciate where we are going with this. Data science is essentially the study of data, analysis of data. Most of your data is going to be rows and columns. In fact, we spent almost 15 minutes in the beginning of the session talking about that image, sun image. Images are nothing but more than 2 dimensions. It's 3 dimensions. And we'll see that soon. Okay. First, we'll look at 2D arrays. So this is row number 1, guys. Okay. So whatever my first list is here, that's row number 1, 1, 2, 3. And this is row number 2, 4, 5, 6. Now, when you put these two rows together properly, you will start getting columns. So if you see column number 1, 1 and 4, column number 2, 2 and 5, column number 3, 3 and 6. By the way, I say number 1, 2, 3. When you index, it is 0, 1, 2. I hope we understand that. Python indexing starts with 0. Okay. So this is a 2-dimensional array. It has 2 dimensions, 2 axes. Similarly, if you do list within list within list, and this is, it looks complicated. I would say ask GPT to break this down for you. But what's happening is it's creating dimension by dimension. Okay. So it's creating ijk for k in range 3. So it's generating 3 values for k. Then it's generating 3 values for j. Gen is generating 3 values for I. So you're going to get all the combinations. Okay. And then if you just print it as list, okay, just, print it as list and see what happens. 0, 0, 0, 0, 0, 1, 0, 0, 2, right? So there is no structure here. Okay. It's all actually a linear object, right? And you have all combinations 0, 0, 0, 0, 0, 1. That's what it's doing. So totally how many combination you'll get? 3 into 3 into 3, 27 basically, right? You will get 27 objects in this list. Now, if I convert this to array and print, what happens? Notice it prints in a very different way. Okay. What you're seeing here, it's showing you cross section. It's showing you cross section. So this is the row and column, right? And then you have row and column again. And then you have row and column again. And then you have row and column again. So you have like this, 1, 2, 3, 4, 5, 6, 7, 8, 9. You have like 9 rows and columns. There are 3 dimensions in this object. Now this will become clearer when we do the image thing. So have some patience till we go to the image, okay, which is obviously the next example, right? But what you need to understand is that these are lists within lists, okay, which are being converted to arrays. So at this stage, I'm going to use a package to read the image and show the image. Now this package is something that we will do in our later session on data visualization. So don't worry about it right now. Okay, just run it. We'll discuss matplotlib in matplotlib session. But if you import this matplotlib.pyplot, pyplot is the plotting library or plotting package used with Python. Okay, typically. And the short form given is PLT. If you just Google anywhere, you will find PLT, PLT, PLT. Same. Import NumPy as NP. NP is the short form convention given to NumPy. Same way for pyplot, matplotlib pyplot. PLT is what we use. So I'm importing matplotlib as PLT, and then I'm using this method called imRead, which is self-explanatory. Read image. That's all it says. Okay, now I'm storing that in a variable called img. Okay, and then I'm going to use show image. So I read the image file, stored it in a variable, okay, using plt.imread. Then I'm using plt.imshow to show the image. That's all. So if you run this cell, you will get this very bad looking image. The reason it's bad is because the dimension is very, very less. The resolution is very less. I believe it is 32 pixels, 32 pixels. I mean, most of us should be familiar with images, right? So if it was a high resolution image, then it would have 1000 something pixels. You will get very nice, image, right? Later, if you want, you replace the sun image with some other image and, explore more on your own, right? I'm using this very bad resolution image because I want to track the values. Okay, and if I want to track the values, then if I have 1000 values, it's not easy to have a discussion, right, in a live session. So that's why I'm taking this very, very bad resolution small image. Okay, cool. Now, as I said, this is a very low resolution image. Visualizations we will cover later. Don't worry about matplotlib right now. Okay, if you're interested, if you have free time, GPT is always your friend. Okay, now what I'm really trying to show here is not this exquisitely bad image of the sun, but believe it or not, this white patch in the middle is supposed to be the sun. This is some sand or something, and this is the sky. Okay, but that's not the point. What I want to show is this variable here. Okay, you read the image, you loaded the image into some variable img. Let's print this variable and see what it is. Surprise, right? Everybody surprised? It's an array. It's a NumPy array, right? So when I said earlier that invisibly arrays are used everywhere, matplotlib.pyplot based on arrays, pandas based on arrays, right? Everything in data science is mostly based on how NumPy operates. So this variable where you stored your image is essentially an n-dimensional array with 3 dimensions. If you see here, there are 3 brackets. Okay, so these are your values. By the way, pixel values go from 0 to 255. Don't worry too much about that. Just understand that 0 means black and 255 means white. In other words, 0 means nothing and 255 means everything, brightness. Okay, why is it 3 dimensional? Because it has 3 channels, RGB, red, green, blue. Okay, we'll see one small example on that later. Anyway, so what I tried to show you here is that these images, all images are actually NumPy arrays. Okay, in the backend they are arrays. Now, one interesting thing about this image is that if you just check the flags attribute, which is not very important right now. Okay, this flags attribute is not something I expect everybody to understand or know. The only reason I am putting the flags attribute in this session to show you, the only reason is because unfortunately my image is not writable. It's read only. So later, if you see here, the flag writable says false. So later, we'll be doing some manipulation of the values inside this array. I can't do that to this array, unfortunately. Okay, this is a property of the file. So if you choose another file, maybe you can manipulate it. Okay, but anyway, there are ways to handle that. So I'm just putting this here to show that my file, my sun image file, is not writable. And if you print in your system right now, you should also get not writable. Okay. Anyway, so we can definitely copy it into new array and manipulate. It's nothing hard. Okay. So what we have seen till now, let's summarize. One-dimensional arrays using lists is very simple and easy. Two-dimensional arrays are essentially matrices, right? Back in school, we used to study something called matrices. That's exactly what two-dimensional arrays are. And when you convert this list within list object with 2 levels into an array, it automatically becomes rows and columns. That is the structure of the array. And we will see the structure using little bit more methods very soon now. And for 3-dimensional array, same concept. Okay, list within list within list, 3 levels, right? Therefore 3 dimensions. And as an example, I've shown you just reading an image, and if you just check the variable of the image, it is in fact a NumPy array, and then you will see values from 0 to 255 basically. Okay, that's just the pixel value. But the main point is that these are 3-dimensional arrays. Okay, great. Let's see the questions. Akash Asthana, how? What's the question? So just given color. Don't worry about that right now. Okay, I'll explain when the example comes. I'll explain. You will get more understanding as you go through. Don't worry right now, because this session is more on the array part. Image part we'll discuss in other sessions. Don't worry. But long story short, if everyone wants to know the within a minute what's happening, image array, what's happening, each image has 3 channels: RGB, red, green, blue. Okay, so and all these channels are having screens. Very simple. It's like my camera screen, whatever laptop screen, X and Y, right? You have row and column. That is an image, correct? The same screen, think of in red color, green color, blue color. By varying the values in these 3 different screens and putting together, you get color, basically. Okay, so if all 3 screens are 0 0 0, you'll get black. If all 3 screens are 255 255 255, you'll get white. Why 255? Because 0 to 255 is 256 integers. Okay, so it's a bitwise operation. All right, and any value in between, if you put 120 130 240 whatever, it may give you some color, brown, green, whatever, right? You will get various colors. That's all it is. But to achieve this, we need this structure called multi-dimensional array, which in NumPy is called ND array. Okay, n-dimensional array. Okay, please attempt these quizzes now, guys. There are 2 quizzes. Both are on your screen. Attempt it, and any volunteer can just put the answer in the chat, right? Consider this list. I've already given the list here. Just copy paste into the cell. What happens when you convert to NumPy array? Can anyone tell me? Okay, Anshul gave me an answer. Others? It's this one. This quiz is pretty simple, right? You just copy this list, put here np dot array, and then put the list, and then execute. What is happening? I have raised hand. Sonal, is it a misclick or this is second time? Hello? Cannot hear you, Sonal. Hello. Put in the chat. I can't hear you. There's some problem. No, Sonal, there's some issue. Others, what's happening? Did we run this? Okay, let me just run this here. Now, Anshul says he's getting an array. I don't know how. Because you'll get an error. Of course, you'll get an array, right? But what will happen is that the requested array has an inhomogeneous shape after 1 dimension. This means, and see this very carefully, okay? You have here 1, 2, 3, 4, 5 elements, and you have here 1, 2, 3, 4 elements. Typically, yeah, you'll get an error, correct? Typically, guys, if you're getting an error, put in the chat. Don't worry, okay? Programming is all about error and debugging, okay? So, yeah. Why this is happening error? Because NumPy is telling you that you cannot have different length row and column. What you gonna have in the missing value then? Because array is trying to convert it into a graph. Yeah. So ChatGPT will give you that. Yeah. So I can't answer whether ChatGPT is able to understand error. In fact, Anshul, you can just take this error and put it in ChatGPT. Try it. Right? Take the error and put it in ChatGPT. Then it will tell you. Then ChatGPT will tell you, oh, the dimension should match. Okay, ChatGPT is like that. You need to keep giving push. Okay. Yeah, dimensions are not matching. The whole point of NumPy array is that it's a very strictly mathematical object. A matrix should have all the values. You cannot have 4 elements in the first row and 3 elements in second row. You cannot have 5 elements in the first row, 4 elements in second row. Why? Again, I told you this very basic fundamental object called NumPy array is used everywhere, right? Yes, Mahalakshmi, correct. You will get error. NP import NP. I don't know what happened, but just import NumPy as NP again. Sure whether there's an issue, but you can just import NumPy as NP and check. n cross m equal to n cross m. Okay. Yeah. All right. So the whole point is that your things like pandas, things like machine learning, and all of these data analysis ML stuff, right? It assumes a certain structure of your data. Okay. So you cannot have randomly varying, data types, varying sizes of data, and then call it a structured data. Okay. Unstructured data is different, by the way. Unstructured data will be like text data, document, all that is a different kind of data analysis. But now we are talking about structured data, and this is the strictest structure that we have. Okay, NumPy arrays. What about this? And I mean, this is again simple answer, right? You just take this list and just put here np dot array, put the list, and how many dimensions are we getting? Clearly, I can see 2 dimensions. Correct? You can see the rows and you can see the columns. Okay, these are all very simple quizzes to motivate what's going on here. All right. So here, as you can see, -1 1, this became my first row. 0 1, this became my second row. But it's not a single line anymore. They are placed on top of each other correctly. Okay. So you have the first column -1 0 and the second column 1 1. All right. So yeah, 2 dimension. Correct. This is 2 dimension. And by the way, number of dimensions you can just check here. Okay. So how many square brackets are there in the beginning? That's how I check quickly. But of course, there's a more easier way to check, which we'll study soon, which are the attributes. All right. So what we've seen is we understood that NumPy arrays are essentially multidimensional in nature. It is able to store any number of dimensions. I have shown you 1D, 2D, 3D. You can store 4D, 5D, 6D, wherever. Any type of n number of dimensions you can store, and it can handle that kind of complex data, which is not required for us, by the way. Throughout this program, mostly we will stick to 2D, maybe 3D in a few places, right? Now that we've studied NumPy arrays to some extent, and we have some familiarity with these things, let's look at some of the attributes. As I told you, whenever you instantiate a class, right, into an object, you will get many attributes and functions associated with that object. Okay. So one specific object like that is the NumPy array. So for example, suppose I have this 1 minus 1 and 0 1. I'll convert to array. Obviously 1 minus 1 is the first row and 0 1 is the second row. So there is this attribute called ndim, okay, which tells me the number of dimensions. So you take the object npr dot ndim. It is an attribute. Okay, so you don't need to put brackets like this. It's an attribute. So if you just run ndim, it will give you the number of dimensions. 2, obviously 2. I have 2 rows, 2 columns. Obviously, it's just rows and columns. It doesn't have depth, right? You have X, you have Y. You don't have Z. Okay. Now, what about this image thing? This image. Already we have the hint here. If you see on the top where it starts, there are 3 brackets, which means it should be 3 dimension. And if you just do image.ndim, you will get 3. Okay, this is 3 dimensional. What about this? The stuff that we were learning in example number 1 in section number 1. So here you have a single list, right? It's not a list within a list. It's a single list. And suppose I convert it to array. What will be the ndim? Obviously, it should be 1 dimensional array. So this has only 1 dimension. Think of it like number line, right? Your number line is a single dimension. This thing has 2 dimensions, X and Y. The image obviously has 3 dimensions. What are the 3 dimensions in the image, by the way? It's the rows and the columns, and then the channels. I told you red, green, blue. There are 3 channels. Okay. So ndim quickly gives you the number of dimensions. It's a fairly simple attribute. One of the most important attributes in NumPy array and everything else in the future, pandas, whatever, is shape. This shape thing, if you get it correctly, then half of data analysis you got, right? If you understand the shape business. So suppose I have a list within a list. What is this going to be? This is obviously going to be 2 dimensional, correct? So I have apple, banana in my first row, and I have cherry and date in the second row. Obviously 2 dimensional. Okay. So apple, cherry first column, apple, banana first row, banana, date second column, so on and so forth. And ndim is obviously 2, right? So if I just say np air dot ndim, we know that it should be 2. there's this attribute called shape, which is quite the important attribute. It tells you the length of each dimension. It's telling you how many items are there in each dimension. So suppose instead of apple banana, I do apple banana cake, and instead of cherry and date, I do cherry date eagle. I don't know why eagle, but whatever. So I have now 3. Okay. Endim is still 2. Number of dimension is obviously 2. You have row, you have column. You can see that here. Row is one kind of dimension, column is another kind of dimension, right? X, Y. But what is the shape? Now if you see, the shape is 2, 3. What it's telling you is you have 2 rows and 3 columns, basically, right? The shape is telling you how many items are there if you look at a certain axis. If you're looking at the rows, then you have 2 items. This thing is 1 item, this thing is 1 item. If you're looking at the column, you have 3 items. Apple cherry is 1 item, banana date is 1 item, cake eagle is 1 item. 1, 2, 3. So shape actually tells you how many or the length of each of the dimension. Okay. And by the way, how many items are there in this shape output? I hope everybody is able to see that this is a tuple. Okay. This shape business, this is a tuple. What is the length of this tuple? Obviously, it should be equal to endim. Okay. So if I just do length of shape in this case, I will get 2. And endim is obviously 2. Why is it 2? Because there are 2 dimensions. So whatever values you have inside, which is the length of each dimension, how many such length should you find in your shape? Equal to number of dimension. If you had 3 dimension, then you will get 3 values. Okay. So the shape attribute is something that we will encounter again and again. Okay. In this session, Matplotlib, elsewhere also, shape is very important because it tells you how much data you have. It's exactly telling you how much data you have, how many rows you have, how many columns you have, which is, I guess, the most important thing, right? Anyway, so we all know how to access items from tuples, right? Indexing we have already learned. So please use this shape attribute and solve the first question. It says extract the size of the array np.array, this one, in its first dimension. How would you do this? Please try it. I might just do it like this. I want to, yeah. Lakshmi is showing error. What is showing error? Import NumPy as NP showing error for you. Like just reset your notebook, open it again if you want. Others, please solve this quiz. Please use the shape command and pull out the size in the first dimension. Lakshmi, can you tell me, is it working or still error or what? I didn't see the chat, sorry, I was still error. What is giving error? Import NumPy as NP. This simple statement is giving you error. Anusha, I pull out the first element from that tuple. You're almost there. So here I will do dot shape. And what is the size of the first dimension? In other words, how many rows do you have? Like if I have to rephrase the question, how many rows do you have? I mean, you can immediately see 1, 2, 3 rows. I know. The way to do is you just do shape 0. Print array shape, array np array print array shape, print len array shape. Abhishek, you are getting the length of the shape attribute. What you should get is the number of rows. Okay. So what it's saying here is size of the array in the first dimension. First dimension means row. Okay. So if I just do shape, if I just do here shape, I will get 3, 4 because it has 1, 2, 3 rows, right? And then when you put it on top of each other, you will get 4 columns. So that also we can just print here and show. Right? If you just print this, I have 4 columns and 3 rows. That is visible, right? We can easily see there are 3 rows and 4 columns. But what is the size of this array in the rows? That is first dimension, that is rows. So for that, I will use dot shape, right? Because I cannot use length. If I just do length of this thing, right? Length of this NumPy array. Let's now continue with accessing elements. Okay, so we won't spend too much time on 1D because I think we are all aware. I'm just going to revise. So here, if you see, I have a one-dimensional list of numbers and convert to array. So clearly this is one-dimensional. So you can check ndim and all that. np air.ndim, that should be 1, right? And here you can use length, right? That's not a problem. Here you can use length. You can also use shape, right? np air.shape. Notice that the shape is still a tuple, by the way. That's how strict NumPy is. Even if your array is 1D, shape will output tuple. So if you want length, you have to do shape 0 again. Okay. Anyway, so how do you pull out element from this? Now we've already done indexing in lists. So for example, what does npr2 do? It will give me the third element, right? 0, 1, 2. This should give me 32. Okay. What is 1 to 4 going to do? 1:4. It will generate 1, 2, 3. And 1, 2, 3 for me is minus 36, 32, 47. Okay? Minus 36, 32, 47. What will happen now? You can also index it, not contiguously, right? You can just put the elements that you want using commas. So np array, if you do 1, 2, 3 inside a list, that will still give you the same array, minus 36, 32, 47. All of these is very similar to lists. Okay. Here you have open-ended. So 2 colon nothing, that means 2 to end. Okay, so 2 is 0, 1, 2. So 32, 47, 71 minus 45. 32, 47, 71 minus 45, and so on. Right? We remember all this. And by the way, 6 I think is the length of this array. So if I do here 2 to 6, I will still get this. I can also do 2 and then use length command to go to the last element, right? Which will still give me this from starting from the third element, 0, 1, 2, 32 to minus 45. You can also use, colon 3, which will give me up to the second element, third element, 0, 1, 2. Okay, so this will give me 22 minus 36, 32. And you can do the same using 0. Instead of not putting anything here, you can put 0. It will count 0, 0, 1, 2, gives the same result. Minus 1, I hope we remember what this negative indexing does. Minus 1 gives me the last element. Okay, so if you do minus 2, it will give me second last element. Cyclic indexing, right? What will happen if you do colon minus 1? It will give everything up to the second last element, right? It will exclude this and give me everything up to. So 22 to 71. And if you do np array colon minus 2, what's it going to do? It's going to skip the last 2 and it'll give 22 to 47, right? So these are all very similar to lists. I've kept a homework here. Not going to spend too much time on this. Reversing of a 1D array. You have reversed lists before, so you can solve this on your own. Now, this is where the funny business starts. Okay, 1D array element access was simple. Obviously, accessing 2D, 3D arrays is going to be slightly more complicated, right? Now I have here 1, 2, 3, 4, 5, 6. This is our very friendly 2-dimensional array. It has 2 columns. It has 2 rows, and 3 columns. Now, I'm just going to show you level-wise access. So if I do here np array 0, notice that it gives me the first row. Okay. Now, if I want the first element in the first row, then I do np array 0 and then 0. Okay. So if you do this, this will give me the element 1. If you change this to 1, this will give me element 2. If you change this to 2, this will give me element 3. If you change this to 3, it will give error. Because obviously it's out of bounds. You only have 0, 1, 2. Only 3 is the length of the each row, which you can get from shape also, by the way. Number of columns is 3. So you cannot access 3, which is the fourth column. Doesn't exist. Okay. So if you want now second row, what do you do? np array 1. This gives you second row. So now in this you can also do first element is 0, second element you will get 1, you will get 5, and then if you do 2 here you will get 6. Okay. Another way of accessing is comma. So instead of doing bracket, if you want the first element here, which is 1, you can do 0, 0. That will give you 1. So if you do 0, 1, you will get 2. Okay, so this is a tuple, isn't it? In Python, when you do 0, something, I mean, if you do something, comma something, that's a tuple. So NumPy array accessing allows for tuples. Here it's a tuple because it's a 2-dimensional array. Okay, otherwise the tuple will fail. And for 3-dimensional array, you can have 3 numbers. We will see 3-dimensional soon. So similarly, if you want the second row and third column. So as I showed you before, second row, third column, 6. Okay, second row, third column is 6. Okay, now if you see the shape of the first row, that's 3. That number of columns is 3. We already discussed this. You can also access arrays while maintaining the shape of the array. That is something very interesting in NumPy. So here if you do np.array0 like this, you will get the first row. Okay, but if you notice that it is a 1-dimensional array, if you see the list here, it has only 1 bracket. The same thing if I put 2 brackets like this and access the first row, I will get 2 list brackets here. And if you see the shape, it will say 1,3. Interesting. So np array 0 gave me a 1-dimensional array of length 3, obviously, right? 3 items, 1, 2, 3. But np array 0 with 2 list indexing parentheses will give me a 2-dimensional array, which is why the shape is 1,3, and you can see 2 list brackets here. So this is a 2-dimensional array with 1 row and 3 columns. But this is a 1-dimensional array with only 3 elements. Okay, this is one way of accessing things in different ways. Now you can of course also access the same slicing which we've learned in lists and things like that. So 0 colon is going to give me 0 till end. In my case it is 0 and 1, right? Now what is this? What is this kind of indexing? So this is obviously telling take the first row. Okay, this means give me all the columns. So if you do this, you will get the first row and all the columns 1, 2, 3. Okay, what happens if you don't specify anything? You still get the same thing. So if you do 0 comma and just leave it, right, you are essentially calling the first row. So this is one way again to access the first row. You can also do this, right? np array first row and then do this colon here, right? This also means give me all the columns. So same way you can now slice the columns. So what does npr 0 and then 1 colon mean? This means get the first row, and then in the first row start with the second column. Please remember Python is slightly like that. 1 means second item, 0 means first item, correct? So npr 0 means first row. Okay, and then the second indexer says start from second column till the end. I will get first row, which is 1, 2, 3, start from second column till the end, 2 and 3. So you can see the answer here is 2 and 3. Okay, please try solving this quiz, and I want to see some answer in the chat. I'll try to print it here. Okay, hey Mahalakshmi, didn't see that. Thanks Anusha for sharing the link. Okay guys, please solve this quiz and give me your code in the chat, and please don't go to ChatGPT for everything. Okay, this should be very simple. I've taught you all these access techniques. Just declare the array in your answer here, and how will you print fig? Where is fig? Just access it and give me a code, please. Correct? So second row, I came here. Second column is this element here, fig. Perfect. So obviously you can use multiple access methods. You can do 1, 1. You can do 1, 1, right? There are many ways to access this. And I urge everyone to try various access methods. Okay, which is why I have a lot of practice questions for you guys here. I'll not solve these right now. Please don't solve these right now. Okay, there's lots more to cover. You can go through these questions. These are all the same array, right? Same array is here. I'm asking you to print lemon, print kiwi, lemon, mango, print banana, cherry, whatever. Okay, great. Now we'll move on to all right. Abhishek is giving other answer. Okay, we are moving on to 3D arrays, guys. Okay, so as I was saying, the shape of this image array right now, obviously it has 3 dimensions, and here it says 25, 32, 3. Right? So what you're seeing is, so if you see one full list here, this is of the shape 2532. Okay, it is showing you, 2532, 2532, like that is showing, and there are 3 such channels. So basically now what will happen if I do image of 0? What is image of 0? Image of 0 is nothing but the first row, but it will show you all the columns and all the channels. So I have 32 columns and I have 3 channels, right? I have 25 rows in my image, and if you want, you can show the image here. Let me see. Right? Was it root value? One second. Oh, sorry, I am show. PLT dot I am show image. Yeah. So I have, if you can see, the axis actually shows 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 till 25. And then you can see 0, 1, 2, 3, 4, 5, 6 till 32. Okay. So obviously it has 25 rows here, right? And 30 columns. And each intersection you can see, you can actually see the square. See, everywhere you can see square, small squares. So each square is one number. Okay. So if I just say img 0, it is going to give me the first row, all of these. So I have dark blue, light blue, whatever. I have these 32 squares here, but it's going to give me 32 squares of red channel, green channel, and blue channel. So totally I will be having 96 elements here. So if you just check the shape of img 0, which is only the first row, shape of the first row of this object only. Okay. So img 0 shape, it is 32 by 3. As I said, it is 32 columns and 3 channels, RGB. So you're getting 32, 3. Now, if you want to maintain the original shape, then you just use the double brackets and pull out the row. In this case, see, you will get 3 brackets. It's the same information, right? 0, 62, 176, 268, 181, all these things, same thing is here, right? But now you have 3 brackets, which means that you are retaining the original shape of the object, which is 3 dimensional. So here if you do img double bracket 0 dot shape, you will get 1 row, 32 columns, 3 channels. Now very similar kind of access method works here also. So if I do image 0, 0, what is going to happen? It's going to give me first row, first column. Okay. By the way, the first column is here and the first row is here. For images, everything starts at the top left. Okay. So this blue color pixel here, that is the object I'm going to extract, img00. So if I just do img00, what I should get? I will get 3 dimensions. Okay, RGB. Very interestingly, just as a side point, see, the value of blue is high. Okay, and the value of green is okay. Value of red is 0. So these are your RGB values for the first pixel, where this one. And it should be very intuitive that dark blue color should have a high value in blue and moderate value in green, and obviously will not have so much value in red. So this is the 3 channels which you cannot see in the image. It is in the 3rd dimension, right? You cannot see it, but you can extract and see for yourself that these 3 values are there for the first pixel. Now if you want only the red channel value, then just img000. That's it. Whatever you did in 2, you're doing here also. One interesting thing is that this kind of accessing will not work, right? So here you expect how would you expect this to work? The way to read this would be img of first row, all columns, 32 columns, and the first channel, which is red channel. That means you should get a 32 length array, but you are not getting. Okay, so this kind of accessing ceases to work. Okay, if you use even a combination of comma and this kind of indexing, still you will not get what you're looking for. The best way is to use commas. So in 3D array, if I wanted all 32 columns, now you can see this is length 32. Okay, so what's happening here? This is the red channel, which means just imagine the image to be like a sandwich, red and then behind green and then behind blue. So what I'm pulling out here is the red channel, the first channel, the first row of the pixels, and all the columns, right? So I am getting all of these values in the red channel. Okay, so I will get 32 values of the red channel. So I think it's becoming clear that you know, the reason that this thing is called numerical Python is because it's a very powerful attempt to try to structurize mathematical structures like, you know, matrices, n-dimensional structures, things like that, right? It's not so easy to imagine right now. With images it is somewhat easy to imagine. Okay, I have row, I have column, I have channel, right? So it's somewhat easy to imagine. When you work with slightly more complex stuff like some ML models, things like that, then you need to start understanding the math behind it. Okay, at this stage just getting a familiarity for it is more than enough. Okay, you can obviously use slicing. I'm not going to go more into this. It's all the same, right? This means what? 0 1 2, start from the third row. What does 4 to 9 means? 4 5 6 7 8. Give me from 4 to 8th column. And then what does up to 2 means? 0 and 1, right? So it's just going to give you that piece of the n-dimensional array. Okay, cool. Yes, Akash, like this the green and blue will have some value. Yes, try it out. Okay, try it out. See, the idea of this session is to enable and empower you guys. Okay, we are discussing all the different basic and fundamental methods related to NumPy. And then you guys, all of these practice questions are available, and on top of that, please feel free to explore. Okay, I'm using some very bad resolution image. Use a good image and see, no problem. Okay, now this is something that you may have seen before. Boolean indexing. It's nothing but extracting or accessing element based on condition. Okay, so for example, let's continue with our two-dimensional array. 1 2 3 4 5 6, 2 rows, 3 columns. What will happen if I just say condition np array greater than 2? So this is essentially going to give me an array. So when you put np array greater than 2, see, is 1 greater than 2? False. Is 2 greater than 2? False. Is 3 greater than true? Yes, true. Is 4 greater than 2? True. So it gives me the Boolean value for each of the indices when you apply a condition. Now you can use this Boolean index array to index the array. So you take this condition and then just index the array. It will give you the values which satisfy the condition. One thing you should note is that the shape is destroyed. Obviously the shape will be destroyed, because when you do conditional access, are you ensuring that you maintain the same number of elements? No, obviously not. In conditional access you just want some elements and not other elements. So when you conditionally access a NumPy array, it collapses to one dimension. Why? Because we know if you do 2D or 3D and there are missing elements, then there will be an error. So to prevent the error, it collapses to one dimension. Okay. All right. So one thing you also need to understand is that these are not in place operations, because even after doing all this conditional access, if I print my NP array, it is still the same array. Same array, obviously. This is not in place. So in Python, most of the manipulation that you do will give you an output, but it will not disturb the original object. So here I've done conditional access on NP array, right? NPR. It has given me, it has collapsed my original array into a 1D array, and it has retained every value greater than 2. Okay. Did my original array change? No. Try printing. Your original array did not change. So if you really want to replace your original array, then you have to assign it, right? So you take this collapsed version and assign it to a variable, and in that case your original array will be rewritten. I don't want that, so I'm going to redefine my original array again. Now we can also see more complex logical conditions. So greater than 2, we know it's going to give false, false, true, true, true. Okay. Less than 5, what is less than 5? 1 2 3 4, these are less than 5, so true, 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 and the other two false. And logical conditions you may have seen before. Just and means both should be true, we know that, and or means either or, right? Either this is true or that is true. One thing to note here is that if you do not put the brackets, then there is ambiguity in the logical condition. So if you put NPR greater than 2 and NPR less than 5, you will get ambiguity. So it's written here, see, truth value with more than one element is ambiguous. You're learning right now, practice over time, and one fine day when you're doing course number 3, all this will be like, I know everything. Anyone wants to share the answer in the chat, the code? What are the steps here? Very simple. ठीक है 60 लगा लो, you might get 13, no problem. No, 60 में 12 आ रहा है. Taker, greater than 60, I'm getting 12, man. Question says 50, by the way. Others, have you solved the quizzes? No, please code it. The whole point of this session is for you guys to code along some of these quizzes and see the results. I hope, is everyone doing the quizzes or not? And it's, I mean, maybe I didn't make myself clear. It's written here, code here. Use what you're learning here and practice. Code and find out. Yeah, this is perfect, Pratim. This is perfect. Let me just copy Pratim's answer and see. So Pratim has done NumPy array is this, L equal to len print L. 14, correct. Yeah, 14 is correct. Okay, great. Next quiz. Load the sun image JPG into an array. I think the array is already accessible. So, just print img. So you don't need to load again and again. If you have been following the code till now, if you've been running it. Oh, okay. If you've been running it till now and following the session, then this img array should be available to you. If not, just run the matplotlib import and image load code. Okay, what we need is the array. Now what I want you guys to do is count the number of pixels in the red channel of the image whose gray level means value. Okay, don't worry about gray level, it just means value. Okay, count the number of pixels in the red channel whose value are within 25 and 255 both inclusive. Can I get a code for this? So red channel means, how do you access the red channel? Anyone? Red channel means the first channel, right? But how do you access it? What is the way to access? Any volunteers? So red channel means what? It's the first diamond. It's the first slice in the third dimension. Think of that way. So when I access, the first number is the number of rows. The second number is the number of columns. The third one is the depth. So the question says, obtain the red channel, which means I need all the rows. So I put colon. I need all the columns. So I put another colon. And then red channel is the first channel in the third dimension. So I put 0. This will give you the full image in the red channel. Okay, so you can see here. And if you do dot shape, you will get 2532. So out of the 3 channels, RGB, which was 3, if you remember, shape had a third element 3. Now we have only the red channel, which is 0. Okay. Okay. Suppose I store this in red image equal to. Okay. So I have my red channel. How should I count the number of pixels in my red channel whose values are within 25 255 both inclusive? Simple conditions. So I need red image greater than equal to 25 and I need red image less than equal to 225. These are the conditions, right? So within 25 225 both inclusive means what? Greater than 225 and should be less than 225. This is my logical condition. This I will use to access the values from the red image variable. So red image and then access it using this Boolean condition. So this will give me all the pixels which are between 25 to 55. Now check the values. Once you run this command, check all the values 39, 28, 26, right? So you will get all the values which are within 25 and 225. You will not get 24, you will not get 226. All these values satisfy this condition. Now if I want the length, I can just find length of this object, which is 545, or I can do shape and then extract or I can do directly shape, but it will give me a tuple. So if you want the element, you just do shape of 0. Okay. So what did we learn in this quiz? Accessing. Okay, accessing from multidimensional arrays, you need to be careful, and the best way, as I've mentioned, is commas. So this colon means what? It means all the rows. This column means what? All the columns. This 0 means what? Only the first slice from the third dimension. Now the third dimension has 3 slices, right? So I'm getting only the first slice. Red is the first slice, by the way. Green is the second slice. Blue is the third slice. So 0, 1, 2. All right. Yeah, R is 0. R is 0. G is 1 and B is 2. Good question. Answer in the chat. R is 0. G is 1. B is 2. 3 values, 3 slices. Which is why your shape third element says 3. The length, the size of that third dimension has 3 slices. Okay. 0, 1 and 2 are the indexers for that. Okay. Again, there are a couple of homework questions here, which should not be hard to solve. Okay, you can try it out. Again, this is Boolean indexing. Okay, so use and conditions, things like that. And there's a very interesting question here. Try to see when you can solve later. Try to see what happens here. Okay, so basically, what we've learned till now is we've learned how to declare arrays. We've learned 1D, 2D, 3D, n-dimensional arrays. We understood that actually, if you see the 4-dimensional, 5-dimensional arrays, we can't even imagine, by the way. There's no visuals for 4-dimensional, 5-dimensional array. There is no visual. Mathematical constructs. Up to 3 dimension, there is, something we can do. Humans can visualize up to 3 dimension. 2 dimension, rows and columns. 3rd dimension being depth. More than that, it's hard for humans to visualize. But the NumPy array class allows for any number of dimensions. Okay. So that's very interesting. As I said, mostly we'll be working with 2D, 3D arrays invisibly. So anyone who is getting kind of, oh no, do I have to keep looking at these array slices and all? No, you don't, because all of this stuff is used in the back end of many data analysis, data science, and machine learning techniques. What I need from you guys is to understand this to some extent, right? That is the main, say, outcome, okay, of the session. So there are a couple of other methods here, that I've mentioned. I've given some hints here. Okay, there is a method called numpy.where. There's a method called numpy.nonzero. Try exploring these, solve it however you can, use help of GPT and C. Okay. Now moving on. Operations on NumPy arrays. Okay, so we've seen declaration, size, attributes, things like that. One of the key features of NumPy is the ability to perform vectorized operations. Okay, so it's faster than for loops, basically. Okay, suppose, for example, first we'll do some simple operations like append. This should be very clear, right? How to add elements. So if I have an array 1, 2, 3, the append method in NumPy, it has 2 important parameters. One is the original array on which you want to do the appending. The other is the value that you want to append. So my input array is npr, which is this value here, 1, 2, 3, this array, and value I want to append 4. So if I just do np.append, give the input array, give the appending value. Now you will get array 1, 2, 3, 4. Notice if you print original np array, it is not disturbed. Okay, again remember, many of these operations will not be in place. They will be temporary. The output is temporary. Okay, so the original object is not changed. If you really want to change the original object, you need to assign. Okay, so now in this case, np.append, and each time you don't need to provide the name of the parameter as long as you provide the values in the correct order. So here I'm providing np array and 4. So, and I'm changing the original, by the way. So I'm doing append np array with 4 and then store it in np array itself. So now your original object itself will change. So here we have seen appending one integer or one value. You can obviously append list-like objects to arrays. So if you want to append more than one, right? So right now the array is 1, 2, 3, 4. So this thing np array right now is 1, 2, 3, 4. I can even append 5, 6. So it's going to append 2 more elements. So if I do that, I'll get 1, 2, 3, 4, 5, 6. See how seamlessly it goes in, appends, and sits in the array. Okay, and this is obviously a list, not an array. The thing you're appending is a list. You can append a list, you can append an array also. So right now my array is 1, 2, 3, 4, 5, 6, which is my array here. Let me append np array 7, 8. What is the output? Again, very seamlessly it goes in 1, 2, 3, 4, 5, 6, 7, 8. Appended very easily. Okay. Deleting and removing elements is something we will not worry too much about, but it's good to know. Okay, so for example, right now my array is 1, 2, 3, 4, 5, 6, 7, 8. The method used is np.delete. It's very similar to append. Okay, you put your input array here. The only thing here is that in append you give values. Okay, in delete the parameter is called object. It is the actual object that you want to delete. So if I do np delete array equal to np array and object equal to 2, then what will happen is the sorry, it's not the actual object, it's the index. Okay, it's the index of the object that you want to delete. So here if you see, the index is 0, 1 and 2. Okay, that's the difference between append and delete. In append, when you append the value, you are providing the actual object. In delete, you can't provide the actual object because objects can't repeat. So if it's like 2, 3, 4 and then 2, 3, 4, which 2 or which 3 should I delete? So obj, and I know it sounds very counterintuitive. Why would they call it object? They can call it something else, right? Index or whatever. But that's how it is. Okay, the parameter name is object. I guess it means object number 2, right? So object number 2 in Python language is 0, 1, 2. So this 3 will get deleted. Again, this is not an in-place operation, which means your original array will not be disturbed. If you really want to delete from original, assign it. Okay, so in this case, I have assigned it to np array, and the second, which means the third object with index 2, has been deleted. 0, 1, 2, 3 has been deleted. You can also delete multiple objects, so you can give the indices here, right? So in this array, if I say object 0, 2, 0 means what? It's this 1. 2 means what? Right now it is 0, 1, 2, which is 4. So ideally 1 and 4 should get deleted. If you see in the output, 1 and 4 got deleted. You have 2, 5, 6, 7, 8. Okay. And I mean, of course, you can continue the same, and this is how delete works for 1D arrays. Okay. Replacing is very simple. It's a simple equal to sign. Okay. And by the way, I'm using the word assignment. You can even use the word equal to. That's what is going on here. But in programming language, equal to means assignment. Okay. Equal to means equal to, right? So if you have double equal to, that is the mathematical equality condition. Equal to means assignment in programming. So suppose I have this NumPy array here, 0, 2, 4, 6, 8 and so on. If you want to replace some element, just index that position. So np array 1 means what? It is the object 2. Just assign 5 and 2 will change to 5. Very simple, right? You can directly assign objects into the array. You can replace elements like that. Of course, you can replace sections of the array also. This also you can do, not just one by one. So np array 0 to 2 means what? Right now my array is like this. What does 0 to 2 meaning? 0 to 2 means 0 and 1. So 0 to 2 means 0 and 1, up to 2 excluding 2. So these two, 0 and 5. I can replace these two with two more numbers, -1 and -2. So it's a list. You can run this. So 0 and 5 will be replaced by -1 and -2. Okay. And I can also, do indexing, slicing, all the usual stuff, right? However you want, you can access the array. So -2 colon means what, right? It means that from the last 2. Okay. So -2 colon, it means from the second last up to the end. So -6, -4. These two will be replaced with these two, 100 and 200. All right. So I've given a few quizzes here. I won't go more into this. These are quite simple operations, which if you practice and sort of see, you'll get better at. So for one dimensional, at least, I'll not be, going into the quizzes right now. So they're all homework. You can try these on your own. Okay. Now, 2D. This is where the interesting stuff starts, right? So one dimensional, we know it's very easy, right? Two-dimensional is where we need to be a little careful. Okay, so let me declare an array. Okay, this is a two-dimensional array, obviously. 1, 2, 3, 4, minus 4, minus 3, minus 2, minus 1. So I have 2 rows, I have 4 columns. You can check the shape. 2 rows, 4 columns, and totally 2 dimensions. Now, if I just say np.append and I use np-array, 0, what is the output? Let us see. Interestingly enough, it collapses to 1 dimension. Okay, so if you append an integer to 1-dimensional array, no problem. But if you append an integer to 2-dimensional array, the array collapses into 1 dimension because NumPy doesn't know where to add. Okay, NumPy has no idea where to add. So it collapses this thing into 1-dimensional array and then adds the 0. Again, notice this is not in place. Okay, it is a temporary output. So your original object is still there. Okay, let us say, I will use the same command, np-array and 0. There is something called axis, right? And by now we know what axis means. Axis is nothing but the position of the dimension you're looking at. So I am using the word dimension. Axis is just another word for dimension. So somebody asked, for example, right, if my image, suppose I have image.shape, right? So I have these 3 dimensions, basically 3 axes, right? X is 1 axis, Y is 1 axis, Z is 1 axis. Okay. The first axis will be here, 0th axis, right, in Python language. And then the first axis is here, second axis is here, totally 3. So what does axis equal to 0 mean? It means row. So right now, 1, 2, 3, 4 is the first row, minus 4, minus 3, minus 2, minus 1 is the second row. What will happen if I append this array with a 0 and I specify axis 0? Interestingly enough, there's an error. Why it is error? Because this is an integer. Okay. And what you're trying to append in the row, if you append here, what will happen to the second row? Just think about it. If you append this to the first row, what will happen to second row? There's nothing to be appended to second row. Again, this is going against the structure of the NumPy array. See how restrictive this thing is, which is also good because it's a very foolproof and very safe object, right? NumPy objects are very safe, right? You cannot do random changes like this. Okay, so let's go back to 1-dimensional. Okay, so here if you have a new array, suppose we'll come back to this. Let's go to 1-dimensional. Minus 5, 2, 5, 7. I just have a random array here. See the shape right now. Okay, we know that the shape is a tuple. Right now it is 4, nothing. The number of numbers in the shape is 1, which means it is 1-dimensional. If I append, I am getting an error. Very, very interesting, right? What am I appending? I am appending np array with new array. So this array, right, 1, 2, 3, 4, minus 4, minus 3, minus 2, minus 1. This array I am appending with this array. Okay, so what do you think should happen? This minus 5 to 5, 7, it should come below here. Then it'll look nice, right? I'm appending this row here. What went wrong? What went wrong in this, right? Axis equal to 0 means row. So if I have a new row and I'm specifying axis equal to 0, why is the row not being added? That's because of a mismatch in shape. If you see the shape of the original NP array, that is 2, 4, it has 2 values, 2, 4. If you see the shape of this new array, it is 4, nothing. It has only 1 number. So in terms of ndim, np array.ndim is 2 and new array.ndim is 1. The dimensions are not matching. Even though for us it looks like, okay, minus 5, 2, 5, 7, it should just come beneath this. It should come like the third row, right? But for NumPy, it's not like that. The dimensions need to match. Okay, which is where there is a very important method called reshape, which is used to handle these kinds of problems. So right now, your new array is of the shape 4, nothing. It has only 1 dimension. I need to reshape into what? If you want to add minus 5, 2, 5, 7 as the third row here, then what should be the shape? It should be 1 row, 4 columns. Right now, my NP array is 2 rows, 4 columns. How to add another row here? That thing, the new row should be 1 row, 4 columns. That 1 is missing in the shape right now. The way to bring it is reshape. So there is a method called reshape, and you give the new shape inside the bracket. So what is the new shape that you want? You want 1 row, 4 columns. So when you do this, notice suddenly you have 2 list brackets. Above, if you see new array, it had only 1 list bracket. It's a one-dimensional object. Now the shape matches. Okay, now the shape matches. Again, just to show you, this is not an in-place method. This is a temporary output. So you need to assign it. Okay, so let's go ahead and assign new array dot reshape 1, 4 to new array. Okay, so it's the same object, but then notice how the structure is different. Okay, in one case it was a single dimensional object with 4 objects, -5, 2, 5, 7. In this case it is actually a 2-dimensional object with 1 row and 4 columns. That's how strictly you need to match the shapes. Okay, so let me go ahead and reshape and assign. Okay, so now my new array is overwritten with the reshaped version. Now if you check the shape, you will get 1, 4. Initial shape was 4, 1-dimensional. Now it is 2-dimensional. Now you try to append. Okay, after all of this hard work, now we'll try to append np error, which is this one, 1, 2, 3, 4, -4, -3, that one, with new array, which is -5, 2, 5, 7. Which dimension do you want to append? I want to append as a row. So axis equal to 0. To finally run this, and now you are able to append -5, 2, 5, 7 to the array. And I have assigned it, so my original array has changed. Okay, what do you think the shape should be right now? 1, 2, 3, 3 rows and 4 columns. So if you do np array.shape, now you get 3 rows and 4 columns. So the moral of the story here is shape is very important when you're trying to work with NumPy arrays, right? In very mathematical terms, what we are talking about are finite values on various axes. So you have x-axis, y-axis, z-axis, whatever, and we have different values on these axes. That's exactly what is being represented here. Okay, and if you remember some kind of high school maths, suppose vector or something, right? If I have a vector 2, 3, 5, which is a coordinate point, I cannot show that in 2-dimensional graph. Same way, if I have a point 2, 3 in 2-dimensional graph, it's not a point in 3 dimension at all. Where is it in 3 dimension? The 3rd dimension information is missing. So that's how strictly the shape and structure of these arrays is maintained, okay, in Python. As another example, suppose I have a list of lists, and this thing, if you see, the first row is just 2, second row is -3, third row is 4. This is a column vector, basically, right? This is called a column vector. What do you think the shape is here? By now, I think we should be very comfortable with shape. If you look at this, it says 1, 2, 3, 3 rows. I see 2 list brackets, so ndim is 2. So the shape must be 3 cross 1, correct? Cross 1 column. So let me just check that. New array dot shape 3, 1. Okay. Now let me try appending this to this. What do you think should happen? See, right now the shape here is 3, 4. Right? It has 3 rows and 4 columns. And now I have a column vector of the shape 3, 1. Right? It will append as a column. So you will get 4, and after that you will get 2, -1, after that you will get -3, 4, after that you will get 7. So let's see. And yeah, you have to specify the axis in which you are appending. So here, if you just change axis to 0 and you append this column vector here, that's not going to work. You're going to get error, dimension mismatch. This error, okay, as you go through this program, this error will come so many times. Okay, whatever you're working with, pandas and everything else, this dimension and shape mismatch error is something that you will quite frequently encounter. Okay, so here I need to specify axis as 1. Okay, column. So if I do this, 4, and then this 2 got appended as a new column here, and then I have -1, and then -3 got appended here. Similarly, I have 7, and then 4 got appended here. Now what is the shape of this array? Obviously 1, 2, 3 cross 5, 3, 5. Similarly, suppose now I have, let me just expand it even further. So now I have 5, 9 first row, -4, -2 second row, 7, 1 third row. So this is obviously, and I've used 2 brackets, by the way. So this is 3 cross 2. Right now it is 3 cross 2. array, and this thing is 3 cross 5. So 3 3 matching, right? Number of rows is matching, number of dimensions also matching. Here you have 2 dimension, here also you have 2 dimension. So 5 columns, and now if I append this one with this one and specify axis equal to 1, I will get 5 plus 2 more columns. I should get 7 columns. As you can see here, 5 9 has appended here to this row, -4 -2 appended here, 7 1 appended here, and this shape is obviously 3 7. Make this example even more obvious, more informative. I am declaring, I don't know what this is, 1 2 3 4 5 6 7, 3 cross, another 3 cross 7. Wow. So I'm declaring another 3 cross 7 array here, and I want to append this row wise. So right now this is 3 cross 7, this is also 3 cross 7. To append this to this row wise, use np.append, and then the input array is np array, the new array is this one, new array. Choose axis equal to 0. So this will go append as the new row here, this will go append as new row here, and so on. As you can see, these things have been appended to these. What is the shape of this? Obviously 3 cross 7, 3 cross 7. So now it has to be 6 cross 7. Okay. So this reshape method is very important. It helps you to maintain the dimensions when you are doing inter-array operations. Okay. And I've shown you how the append method also works with axis. So let's try some couple of quizzes here. Okay. And these are just, kind of try and experiment and get it done. Any shape and reshape may different. Shape is an attribute, Parul. Reshape is a method. Shape is an attribute. So if you have an array called x dot shape is a tuple which is already stored. When you declare an array and save it in x, variable x, its size, dimension, shape, these are all attributes. These are all characteristics. Okay, these are all static values. Static values. So when you do x dot shape, you're just calling the shape. It's not a function. It's not a routine. It's not doing anything. It's only telling you the shape. Reshape is a method. Okay, reshape is a method. It changes the structure of an array into another shape. It's a method. Okay, great. So let's try one quiz here. Consider this array shown here, transform it to this array. Okay, anyone else was able to crack this one? Let me also query GPT and see why are we facing this issue. 1 second. Yeah, I'm getting similar what you got. So I'm just going to tell GPT your code is, I'll say your code is giving me 5 -7 in the first row and -2 in the second row. And this is not matching with your output. This is not matching with your output. So if you do that, it will give you something. Okay. So let me, let me just disclose, that method here. So if I just do result dot transpose, now if you see, I'm getting 5 -2 here and 7 3 here. Okay. Yeah, transpose. And I believe there's a shortcut in NumPy for this, capital T or something. Yeah, see, instead of dot transpose bracket, you can directly use dot T. For 2 dimension, this should work. In 3 dimension, transpose will do something else. We will get to that. But transpose you can think of as nothing but interchanging the dimensions. That's all. In 2 dimension, there is a shortcut dot capital T, which is, by the way, a reference to high school mathematics. I hope everyone gets the reference to high school mathematics, right? In high school maths, we say A and then capital T. That's what the shortcut is here. Okay, so Python developers have programmed that reference into the code. The actual method is called transpose. Okay. Great. So GPT, I hope you're getting it now. It doesn't have all the answers. Okay, GPT is not, it won't give you. It doesn't know what you're trying to ask. So there's a lot of conversation you need to have, and as I said, use it as a reference. Okay, don't use it as a. Last time also I told you, it's not going to give you all the answers you seek. You have to use it to learn. Sometimes it will fail. Sometimes it's good enough. Gives you some code, but you need to debug it. You need to, look more. Anyway, so this is interesting. What does it say? Consider the array shown below. NP arrays, whatever. So let me just print it and see what this is. Obviously 2 by 3, right? This thing is obviously 2 by 3. Transform this to -4, 2, 1, 3, -1, 7, 4. Okay, this should be pretty obvious, right, guys? What's happening here? So -4 is all -5, 4 is already here. We are appending 2, 1. 3, -1 is the second row here. We are appending 7, 4. 6, -3 is here. We are appending 5, -5. This much is obvious. Okay. We basically need to have new array 1, let's say, equal to np dot array. And since this shape is 2, 2, these 2, 1, 7, 4, 5, -5 also I need in shape 2, 2. So new array 1 will be, and you know what, let me just create a new cell so that we understand. So new array 1 should be what? NP array double list, because we need 2 by 2. What are the elements? 2, 1, 7, 4, then 5, -5. Oh no, this is string 5, -5. Now if you print new array 1, see, it is a 2 by 2. So this -5, 4, 2, 1 should be the first row. 3, -1, 7, 4 should be the second row. 6, -3, 5, whatever, this should be third row. This much is easy. What I should do? I should do np dot append np array new array 1. Which axis we are appending? Like this. So column axis equal to 1. -4, -5, 4 to 1, 3, -1, 7, 4, whatever. We got these. And then we have another row. So next what I need to do? I need to, by the way, let us store this in a, new array or whatever, right? Then I'll print it. So next I need a single row, but remember, we cannot use a one-dimensional array. We need to reshape this to 2-dimension. Okay, one way to do that, directly use double bracket, correct? So one way to do that is new array 2 equal to, I will take this list from here, I'll just copy it. Okay. One way to do that is use double bracket. Okay, and that should ideally give you, as you can see. And if I just do shape and check, oh, it's a list. I forgot to, yeah, np dot array, yeah. So shape is 1, 4. Okay, this is what we need. So one way to do is declare here itself. The other way to do is reshape, correct? So the other way, if I redeclare this, but this time I will not use double brackets. This time I will use single brackets, suppose. Okay. So now if I do new array dot shape, it is 4 elements, but only 1 dimension. And if you print it, you will get only 1 list bracket. If you try to append here, it will fail. So what you can do is new array 2 dot reshape, and the shape that you want is 1, 4. Okay. So now let's print new array 2. Now it has double brackets. Now if you do dot shape, you will get 1 row, 4 columns. So now it will go as a new row here, and there are 4 columns for it to match, right? And that's what the question is asking. -3, -5, 4, 8 should be the 4th row. Okay. So after this, all I need to do is np dot append. What am I appending? This one, which is new array. And sorry, that's the input array. And what am I appending? I'm appending this array. So new array 2. Which axis I'm appending? I'm appending as a row. So axis equal to 0. This produces. So we went from this to this using a combination of append, reshape, and things like that. Okay. There are a few questions. One question here for homework. Similar methodology. You can use a combination of transpose, reshape, things like that. Use everything that you have learned to go from this array to this array. All right. Okay. Great. So deleting. Now we saw deleting in 1D. Okay. Let's quickly see deleting in 2D. So suppose I have this array 4.7, 1.4 minus 4.6. I have 3 rows here. All right. What's going to happen if I do np.delete? And I hope we remember the arguments. Okay. So ARR, that's the array, and the object is the index that you want to delete. In fact, you can check the documentation. This indicates the indices of the subarrays. So this is the index. What will happen if I do np delete of this array, and I'll just put index as 0? What happened? Are we able to see what happened? So what happened was these elements were retained. You deleted the first element 4.7, but the rest of it collapsed. So what's happening really is when you apply this, without talking about axis and shape and things like that, it's collapsing this into 1D. And remember, when you delete one by one elements, obviously you cannot maintain the same shape. Not possible. So if you delete this one element 4.7, it's missing now. So there's a gap. Okay, and NumPy arrays do not allow that gap. It has to be a fixed, number of rows and columns and other dimensions. So 4.7 has been deleted, but the rest of it is collapsed. Again, this is not an in-place operation. Okay, this is temporary outputs. Now suppose I say I specify axis equal to 0. Here I did not specify axis. Suppose I say, okay, take this array, delete 0th element, whatever it is, and axis equal to 0. Now if you notice, it has deleted the 0th row, which means the first row in Python language. So this index with this axis specification means what? Axis 0 means axis equal to 0 means the 0th dimension, which means the first object in the shape. What is the first object in the shape? It's the number of rows. So axis equal to 0 means row wise operation. In row wise operation, what is the 0th element? It is the first row. So when you delete using np array, the first element in axis 0, that is actually the first row, which is what got deleted here. Okay. So now if you, these are obviously temporary print outputs. Original object is not changed. If you want to change, assign it. If you assign it, you will delete the row from the original object. Now I said you can, give multiple indices, right, for deleting. So right now my np underscore array object is this thing here, which is 2-dimensional with 2 rows and 3 columns. Sorry. What does 0,1 mean in axis equal to 0? Again, axis equal to 0 means row wise. What is the 0th item row wise? It is the 0th row. 2.6 minus 1.2, this whole row. And what does 1 refer to? 1 refers to the second row. So now if I delete 0th row and first row, which means first and second row in axis 0, right, which is y rows, then what should be the output? Output is null. Done. You have deleted these 2 rows. So now your output array is null. But notice that interestingly enough, your blank array still retains the shape. So funny, right? NumPy arrays. There's nothing in this array, but this array has a shape. 0 rows and 3 columns. Okay, that's how important this shape attribute is in NumPy, and that's so important. It becomes, in future in pandas and things like that. Okay, in data analysis, the shape is still maintained, even the data type. Anyway, so let's redefine our array. Okay, we've deleted all our rows, so let's redefine. Now, how do you delete rows? I think, how do you delete columns? Pretty obvious at this point, right? np.delete input array. Choose the item number. In Python, it is 0, 1, 2, whatever. So item number 1 in the first axis, which means second axis, by the way. So columns. What is item number 1 in the column wise? It is the second column. So when I say np array axis equal to 1, I am talking about this column here, this column here, this column here. The 0th column is this one, first column is this one, second column is this one. So when I say delete np array item number 1 in the column axis, that is the middle column here. So this column should disappear. 1.4 minus 1.2 whatever should disappear. It has disappeared. It has been deleted. Okay. And similarly, you want to delete everything, you can go ahead and delete everything. Okay. Notice that right now the shape is 3, 0. Okay. So here 0, 3. Here you started deleting column wise, so it is maintaining number of rows. Here you're deleting row wise, it's maintaining number of columns. Very interesting. Right? So what you've learned here is that if you delete randomly, element wise, then it will collapse into 1D array. But if you correctly delete axis wise, it will retain the original shape. Okay. And I mean, it's a very obvious question here, which is homework, but I think the answer is very obvious. Can you delete individual elements from arrays? Yes, you can, but what happens if you delete individual arrays? It collapses into 1D. You will lose all the data structure information. You will lose all that information. Right? Okay. Empty. Yeah, it collapsed. Correct. Great. So deleting is fairly simple, and we won't go too much into it because, as I said, in your data science journey, you may use delete here and there, but mostly we will be using operations and things like that. Let's see replacing elements, right? Now, I hope by this point we are understanding that arrays are very, very different from lists and things like that. Okay, this is where your data science is really starting. Okay, this is the, you can say, the ground on which you're taking off, right? You understand all of this mathematical structure, and that's how everything on top is built. Okay, up to list, strings, and all of those other things, that's basic programming. It doesn't care so much about mathematical analysis. Of course, programming is mathematics, I'm not saying that, but it doesn't really care about things like matrices, vectors, transformation, transpose. These are all data techniques, data science techniques, right? So up to lists and all those other things you studied, basic programming. From here on, which is why this is called Python for data science, right? From here on, we have to start thinking of our data as structured. Okay, number of rows, number of columns, what's the data type, so on and so forth. Anyway, so and why am I saying all this? Because now I think all of this should be obvious. So if I say np array 0, what does this mean for a 2-dimensional array? It means the first row, 4.7, 1.4 minus 4.6, correct? So now if I replace with this list, what should happen? The first row will be replaced with the new replacement. So easy, right? When you start understanding, okay, what exactly the indexing is accessing? Is it accessing a row? Is it accessing a column? Is it accessing a section of that? When you start understanding what it is accessing, then it becomes really easy. By the way, obviously you can index like this and replace. What is this, by the way? What is this? This is all rows 0th column, right? All rows 0th column, which means what? Minus 0.5, 2.6, 6.6. Okay, now I can replace that set of 3 numbers with new set of 3 numbers. So minus 0.5, 2.6, 6.6. This has been replaced with these 3. 1.5 minus 2.4, 5.2. Notice that this is list. Still NumPy array is able to understand. As long as you match the 1-dimensional objects correctly, it will do this. Okay. When you do 2-dimensional, you may want to do arrays. So I think, for example, here you get an error. Why you're getting error? What is this? First of all, what is np array all rows and from first column? Which means what? I want all the rows, but I want from column number 1, which means this one. So I need 2.5, 1.7 minus 1.2 whatever minus 3.2, 4.9, right? So if you see, this is what I've extracted. Obviously, you cannot replace this with 3 by 3, right? You have to replace this only by 2 by 2, right? So here I have 3 rows. So if you just take this, right, and suppose I just say np dot array and print the list. How can I replace these with this? The shape is not matching. Very simple answer, shape is not matching. And when shape is not matching, what is the first thing we try? We try to reshape. Okay. So if I just take this element here, right, the thing I'm trying to replace, which has 6 elements. Right now it has 2 rows and 3 columns. Suppose I reshape to 3, 2. Now I'll get 3 rows and 2 columns. This I can replace on this, no problem. Shape is matching, I can replace. So if you do this, it is able to replace that. Okay. So the one small problem you can see here, right? I think there's one small problem which you can observe. We expected these things to be replaced here, but something went wrong, correct? So if you see NP array, by the way, I have only selected from first column, okay, which means these elements, right? So this 0.6 1.5 I expected to be here, 0.6 1.5, and then 4.3 0.8 that I've expected to be here, right? Which is that's done here, and minus 5.4 minus 4.3 I have expected it to be here, which it has done. Now if you wanted to actually, if your intention was something else, the most easiest interpretation of something like this will be what? This is a column. So in my original NumPy array, right, I have 3 columns, right? I want this to come here in 0.6 4.3 minus 5.4, and I want this 0.8 minus 5.4 minus 4.3 to come here. Reshape is not enough. Obviously reshape is not enough, and we have seen an example of this before. The best way to do that is to reshape and then transpose, or transpose and reshape. Both will give you same result. So if I just take this one and reshape and transpose, this 0.6 1.5 4.3 will now appear as a column. This 0.2 minus 5.3 5.4 minus 4.3 will appear as the second column. This you are replacing on the second 2 column of the original NumPy array. So this one, right? So my original actually had other value 2.5 1.7 whatever, right? So this column and this column we want to replace with this column 0.6 1.5 4.3, and then this column 0.8 minus 5.4 4.3. So combination of transpose and reshape is what would replace those 2 columns with the intention that I had, which is I want this to be a new column, I want this to be a new column. So if you do all of that, then you will get this 3 numbers in this column and these 3 numbers in this column. Again, the moral of the story is that as long as shapes match, you will be able to add, delete, replace and things like that. Okay, so reshape method is used for that. But if you want to correctly place elements in the right place, then you should see what's going on. Okay, so this transpose gave me these 3 values in the column. Otherwise, if you use as NumPy array, we know that this is going to first row. We know that, right? We have seen this in our previous examples. If I just do NumPy array list 1, list 2, then list 1 will be row, list 2 will be row. And now if you reshape this thinking, okay, I want column, and I have 6 elements, so I can just reshape 3, 2. What's going to happen? The elements get split up. So if you wanted this as a column, that's not happening here. Why? Because your reshape 3, 2, what did it do? It took 2 elements from here, put it in the first row. It took 4.3 0.8 from these 2 and put it here, right? Which makes no sense because this is in a different vector and this is in a different vector. But it has taken these 2 and put it here, and then these 2 is coming here. Now you can replace. Now you can obviously replace the second 2 column, right? Everything except the first column. You can replace this chunk here, no problem. But is that the intention? No. So then you may want to use transpose to by the way, directly you can just build it. So how to directly build it? That's obvious, right? You just take this list of lists and convert to array. That's all. You just do this np.array and give list of 3 lists. No problem. But this only works for very small number of items. When you're working with immense amount of data, we need to use methods like transpose, reshape, and things like that. So yeah, this is what I've written here. Another way to achieve this would be to actually define it in the actual shape that you want when you start. Okay, so that's one way to do it. So if you do all that, it works. Okay, so I'm going to take a pause here, and probably we will take up this at another time. What do we have remaining here? We have 3-dimensional, and then I think we have operations on arrays. Okay, so just a quick survey of opinions. We obviously need one more session to go with the rest of the content, rest of the topics. Is everyone okay with the session tomorrow? Please let me know in the chat. Is it okay with everyone? I'm going to need way more yeses than that. I have 26, around 30 learners. Come on, guys. Okay. Okay, fine. So, fine. I'll, mostly I'll get a session scheduled for tomorrow evening. Let me just see what is left. We have. Okay, 1 second. I'm just checking things. Sorry. So we have three-dimensional replacement. We have vector operations, matrix operations, things like that. We have, okay, all of this is mathematics. If you are learning to code, you probably want to master the tech world. Join our job-linked data science and AI advanced bootcamp program at upGrad and gain the skills employers are looking for with a practical, industry-focused curriculum and hands-on projects. You will learn from seasoned experts and apply your knowledge to real-world problems. To start your data science journey today, click the link in the description box below. So we'll be continuing where we left off yesterday. But to do that, I usually, find it easier to run the previous cells because we've been using the same variable names. And mainly because this is a workbook for learning purposes, right? If you were doing actual programming, then you would be careful in terms of variable names, and you wouldn't overwrite the same variable again and again and things like that. But since we are using this for learning purposes, we are using the same variable name almost everywhere in the code. So it's probably better to run the previous cells, and then continue where we left off. So that's what I'm going to do. And I request everyone to do the same. Those using Colab, please upload the image file and start running the cells. Those using Jupyter, you can directly run. Okay. And as I run through the cells, we'll just quickly summarize the things that we saw yesterday. Okay. Please let me know once everything is set up, then we can continue. Okay, and in the meantime, I'll start running my cells and maybe giving some commentary in terms of recall. So we are discussing NumPy, numerical Python, which is the fundamental package, the most basic and most reliable and most universal package for mathematical computing in Python. So we import NumPy typically as NP. Then we discussed things like, what is a NumPy array? What kinds of elements can you put inside NumPy array? So we saw, for example, arrays from lists. We saw that each array will have a data type depending on the kinds of elements that you put inside. We also discussed that, tuples and sets, it doesn't make too much sense to use as inputs for arrays. Sets because it's not ordered, tuples because you can typically do the same thing with lists, right? And mixed arrays are also usually not used that much. So this is something, this mixed array business is something that we'll see in tomorrow's session when we do pandas, right? How do you handle this different data type thing in the same list? How do you handle it is something we'll see in pandas tomorrow. Okay. Then we spoke about multidimensional arrays, and I should say at this point that I think we all understand that why should I separately call it multidimensional array, right? All NumPy arrays are multidimensional arrays. That's what we understood yesterday, right? And we saw that the method used to create these arrays is called NumPy.array, and the class, the array class, is called ND array, NumPy.ND array, n-dimensional array. Then we saw 2D arrays. We saw some examples of 2D, 3D. Then we went into attributes of arrays like ndim, there's number of dimensions, and the most important attribute which we saw yesterday was the shape attribute. And we also how important the shape attribute is if you want to work on NumPy arrays. Then we saw how to access elements from arrays. So typically it's the same access method as lists, which is integer indexing, right? So you can do that for 1D, and for 2D it was a little bit more complicated than that, right? So we saw, okay, the first element in the tuple for accessing is the position on the 0th axis, which is the row. Then the second will be the position on the first axis, which is the column. So for 2D, you're just selecting row number, column number, and whatever intersection is there, that element will be extracted. Similarly, for 3 dimension, you will have 3 numbers in the tuple that you use for extracting, right? One second. There's something wrong with my mouse. Give me a second. Yeah, okay, better. Right. So yeah, accessing methods is something that we saw. Shape is something that we saw. Reshape is something that we saw. So reshape we encountered when we were trying to replace elements in the array and do operations between arrays and things like that, right? Appending arrays, appending a row, appending a new column, those kinds of things. We also saw simple Boolean indexing, logical conditions like greater than 2, less than 5, and how you can access elements using logical conditions. Okay. So yeah, this is what we saw in terms of adding elements to arrays, removing elements to arrays. We saw that 1D arrays is pretty simple, right? 1-dimensional arrays is very simple. But when you come to 2-dimensional and 3-dimension and more dimensions, then you need to be careful what is the shape of the item or the object that you're trying to append, and what is the shape of the actual base array on which you are trying to append the new object, right? So in that we saw that the shape plays a very big role in getting the right output. And we also used methods such as transpose to flip the dimensions of the array, right? So I think mostly this is what this is where we left off yesterday. I think we completed up to 2D. Yeah, so we were here where we deleted one element from 2D, it collapsed to 1-dimensional array. Then if you select the axis, then you can the number that you're using here is actually the index of the item along that axis. So for example, in this code here, the original object from where you want to delete is npr, which is this object here, and I put axis equal to 0. So now it is checking the rows, and in the rows, what is the 0th row? It is this one, the first one, right? So then it deletes that. Correct. So these are the things that we saw. Let me see. Oh no. Okay. These are the things that we saw. Let me just rerun these. Yeah. Don't run the cells twice. Okay. Some of these operations are in place, so that may mess up some of the values. Regardless, let's come up to this point. Yeah, we did this. We reshaped. And then we saw column appending and things like that. Yeah. So this is where we are continuing, right? Okay. So has everyone set up their environment and run the code up to that point? Please note that run all will not work because there are some errors in there, intentional errors, right? But as I said, it's for learning purposes. So are we all at this stage now? I hope we've all opened our environment, set it up, and run till this stage. And by the way, even after this, if your variables don't have values, just go back to where you loaded that variable. So what is img? Img is nothing but the array that you get when you load that sun image, right? So just search for that code and put it here. All right. But hopefully we shouldn't be facing that kind of issue. Hopefully everybody has run all the cells up to this one, right? Up to this. This is where we stopped. There is an easy way to do that. So what you do is, you introduce an error on purpose, like where you want to execute, right? Introduce an error on purpose. So what I can do is I can just go select any error. For example, this is an error, right? So I can go to the location in my code where I want to run everything till that point. So for example, I want to run till this point. So this is going to give error, right? So I'm intentionally introducing this error here. And then I just scroll up. Wherever there's an error, I can comment out the code. For Jupyter, it is control and // I think same for Colab. Okay. So for example, right now this is code. I can just comment. Now when you run it, it will not run. So it won't give error. And then it will continue to run because it did not run this code, right? So I'm just going to go and see in my code where are my errors, right? And it's a foolproof way, by the way, right? So here there's an error. I'll just comment. There's another error here. Comment. Right? I'll just go through the code and see if there are any other errors here. Because errors in Jupyter don't allow you to continuously run the code. It will not go to the next cell. So let me just find out where are my other errors. Accessing, what is this? Attributes will not have errors. Yeah, here's an error. Comment that. And somewhere here there should be some errors. Yeah, it's one. This is an error, obviously. Accessing from set, that's an error. And here again, it's a blank array, I think. Yeah, not a blank array, it's a dimensionless array. Yeah, okay. So I commented out every cell that gives me an error up to the point that I want to run, which is somewhere here, right? Here. Yeah. So up to this point here. So we were like yesterday, we stopped at this array here where we were trying to get this row into column format and then append it to the array. Okay. So this is the point. So I've introduced an error on purpose here, and every previous error I've commented. Now I can just restart and run all. Ideally, it should run everything without any problem till the position where I have intentionally given an error. Let's see if that worked. Yeah, so it has run everything smoothly till the point where I gave it an error. Now I can just comment this out. So we were discussing addition, deletion, and changing values in NumPy arrays. And we saw that whenever we do any of these kinds of activities in NumPy arrays, the shape may or may not change. So if you want to preserve the shape of your array, then you should be careful with your operations, right? That is what we saw. Now, for example, take this array. And by the way, at this point, we should be comfortable enough to read an array in list form. Okay, so obviously when I print this array here, np.array 1 2 3 minus 2 0 5, when I print it, I will get 3 rows and 2 columns. But before printing itself, we should know. I think we should be at that stage. Okay, which is, by the way, the whole point of these rigorous exercises is to build familiarity with the programming language and tools and objects, right? So by just looking at this, I know it's going to be row number 1 is 1, 2, row number 2 is 3, minus 2, row number 3 is 0, 5, correct? So as you can see, right, 1, 2, 3 minus 2, 0, 5. Now I've printed np array, so you can only see the list notation because I've used the print command, and I've also printed the shape of this array. So this array has a shape 3, 2, okay, 3 rows, 2 columns. And transpose, what is the method transpose? What does it do? So obviously we saw that it interchanges the two dimensions. So your rows become columns and column become row. So 1, 3, 0, this column became the row here. 2 minus 2, 5, this column became the second row. and notice that the dimensions actually have changed, interchanged. So here it is 3 comma 2, here it is 2 comma 3. Okay. The interesting thing about reshape is that you can reshape it into other dimension distribution also. For example, 2 into 3 equal to 6. So I can actually reshape this into 1 comma 6, right? So if you take the same array, which is this one, 1 3 0 2 minus 2 5, that's why it's the transpose here, right? The same array, if I take it and if I do dot reshape 1 comma 6, then what happens? If you see, this 2 minus 2 5 has appended here. So here you have 1 3 0 2 minus 2 5. Same way, if you do for this array, if you do np dot array 1 2 3 2 0 5 without the transpose, the shape is 3 comma 2. So if you take this and reshape, for example, if you take this one and reshape it with 1 comma 6, then 1 2 3 minus 2 0 5. That is what you should get here. So as you can see, 1 2 3 minus 2 0 5. Basically, the point I'm trying to make here is, don't expect NumPy to know what is in your mind, basically, right? It has a certain set of rules that it is following, and typically it follows integer indexing rules. Okay, so here this is the first row, this is second row. Now you are asking it to convert to 1 row and 6 column. What is the most obvious thing to do in this case? Most obvious thing is take second row and put it after the first row, which is what was done. Similarly, if you give this format and then say reshape it to 1 comma 6, most obvious thing here is take 3 comma minus 2, put it in the top, take 0 comma 5, put it next to that. So NumPy has a very strict way of doing these operations, and you need to understand what is happening due to these commands. Okay, that's essentially the point that I'm trying to make here. So now let's quickly have a look at the three-dimensional array. So this is the image, which shape is I think 25 32 3. So it has 3 dimensions, right? One dimension being rows, number of rows, one dimension being number of columns, and the other one being number of channels. So for example, in fact, I don't need this. Yeah, I'm just deleting those 2 cells. If you want, you can comment it, guys. I don't need those. I'm just going to take this and put it here. Yeah, image. Yeah. So those, by the way, delete shortcut is escape and then press D twice. Okay, escape D. Okay. Let me just write it here. If you want to delete a cell, it is escape D. Okay, escape, press D. Okay. Learn Jupyter shortcuts also as you go through this, and same way Colab also has similar shortcuts. This will be very useful. Anyway, so I did not want that temp image at all because my image shape is already 25 32 3. I think that that was for 32 32 3, so forget that. So anyway, here my image shape is 25 32 3, and what am I doing here? Notice this. Okay, now I'm doing np.transpose. Okay, that is different from array.transpose. Now here, if you see, this is np.array.transpose. This transpose method is applied to the object. Okay, the transpose method is part of the object. Okay, the array object has a method, inbuilt method. It's associated with the object. This np.transpose is a global function. It is NumPy transpose function. It is not associated with any object. A NumPy.transpose. Okay, it's a function. In that function, I'm passing my input array, which is img, and I'm also passing the new ordering of the dimensions. Okay, now let's see what this means. So right now my image shape is 25 32 3. Okay, in this, what are the positions of these numbers? How do you do that? img.shape 0, that gives me 25. Okay, img.shape 1, that gives me 32. Simple tuple, right? This is nothing but a simple tuple. Then you have img.shape 2. This thing gives me 3. Okay, obvious. 25 32 3. 0 1 2. This exact 0 1 2, what order do you want to change? That is what I'm passing it here. So 0, 1, 2, I now want 0 to go to second position, 1 to come in 0th position, so on and so forth, right? So I'm giving the new ordering. So this function allows you to, and by the way, of course it produces an array. Okay, it gives you an output array. What is really interesting is, and also this is, not an in-place method. So if you want to retain the new array, this new array, you need to assign it somewhere. So I'll assign it to this new variable, new temp image, right? This one. And if you see the shape, notice that it is 32, 25, 3. Go back here and see. This shape is 25, 32, 3. 0 was 25, 1 was 32, 2 was 3. And you told I want 102. So now 32 will come in this 0th position because you put 1 here, correct? So this 32 will come to this position. Then the next one is 0. So 25 will come in this position and 2 remains the same. 3 is here itself. So if you see here, now the shape is 32, 25, 3. So for more than 2 dimensions, because it's not obvious, right? For up till 2 dimensions, what you have is a matrix, right? And transpose of matrix is obvious. You have only 2 dimensions. So transpose means it will change the rows and the columns. Sorry. But when you're dealing with 3-dimensional and higher dimensional arrays, you have the choice to specify what is the order of the dimensions that you want. So if you have 3 dimensions 0, 1 and 2, if you do just dot transpose, it will take the default values, which you can check, check the documentation and see what is the default values. There must be some kind of default, but you can specify the order. Okay. So for 3-dimensional and above, transpose works the same way. Transpose just means interchange of dimension, but since you have more dimension, you need to specify. Okay. So these are very interesting methods, reshape and transpose, especially the combination of reshape transpose. I have used multiple times when I was working with NumPy arrays, when I typically work with slightly more advanced ML models. These two are important on their own, but combinations of these two really help out. Okay. Suppose let's go to quiz 10. Consider array shown below. This is NP array 100, 200, 300, 400, 500, 600. Okay. So it has what? First row, second row, third row, and it has 3 columns. So obviously this is 3 by 3, 2-dimensional. Question is, what does NP array dot reshape minus 1 do? Okay. So this is a very useful method, this reshape minus 1. Everybody please try it out. And can you put in the chat like what is your output? Obviously, I mean I'm not going to tell you guys to run this. In this case, nothing will happen in the quiz number 11 because already you have 1D. Okay, already you have 1D, so it's going to remain 1D. Please attempt quiz number 12. Can everyone attempt quiz number 12 and tell me what's happening to the output? Quiz number 11, as I said, it's pretty simple. You can run it on your end, no problem. Run it if you want. The original array is also 1D and shortcut method is converting 1D to 1D, so nothing will happen. You will get the same array. Quiz number 12 should be a little interesting. np.array reshape minus 1, 1. This. What is the output? Try quiz number 13. Again, there is an array here which looks like a 2D array, and so we can investigate the output of this as well as this. Please try quiz number 13 and see what output you're getting. What are we getting for quiz number 13? So you can just copy this from the question, by the way. You don't need to type the array. I hope nobody is typing all this. You can just copy this from the question and put it in the cell. So I've copied, put it here. And first I'm executing this command. Again, I'm copying this code here and executing this command. So what do you think minus 1, what's going to happen? You're going to get single array collapsed into 1D. Excellent. Correct. Okay, let me run that. So here it is collapsing to 1D. This is obvious. What about minus 1, 1? I think we have some answer here. It's changing into 2D. So what happened though? it's changing into 2D, but what was the original shape? The original shape here is 2 cross 3. Now the shape is 6 cross 1, isn't it? So these are your shortcuts for creating column vectors and row vectors. So if you want this to convert into row vector, then just try this. Okay, make one more cell here. Oh, by the way, the shortcut for cell is escape A. Okay, in Jupyter, escape A. I think same shortcut for Colab also. So just press escape and A, you will get a cell. Okay. So try doing the same command, but this time interchange -1 and 1. Okay, interchange this. Do np.array reshape 1 minus 1 and see the output. Page link. Just wanted to share some very interesting commands that we might use a few times in backend when we are programming things into the back, right? Wherever we want to collapse into column vector, wherever we want to collapse into row vector. So there are some of these very interesting shortcuts from reshape which are available. Okay, couple of homework questions. I will again leave it for you guys to do, and we will move on with the, you can say, conceptual second half of the NumPy topic. So till now we have spent our time familiarizing ourselves with the NumPy array class and very important attributes and methods such as shape, size, how to add things, how to subtract things. Those are the things we focused. Now we will go into the second half of NumPy arrays or NumPy session or NumPy topic, call it what you want. So the second half is mathematical operations. Okay, the page which we are doing now, for example, here I have a vector -1 3 4 -6, and then I have one more 0 -5 -2 10, and I'll print both. So this is my first array, this is my second array. Now just to make it very obvious, right, if I just add the two lists instead of the arrays, what is going to happen? That's an output. I'm very sorry, that's an output. I can't add outputs without commas. I forgot the commas, obviously. So let me just put the commas. So right now these are lists. So you all remember lists, right? If you use plus, what's going to happen is it's just going to append this list to this list. You don't have vector operations in lists. You don't have any particularly focused mathematical operations feature in lists. Okay, that's the advantage or the reason why NumPy arrays came into existence. That's why people built the NumPy library. So now these things are actually arrays, right? So NP array first array and NP array second array. So vector number 1, vector number 2. So suppose I add this vector number 1 plus vector number 2, and I'm printing the addition. So if I just do v1 plus v2, what do you expect? The components should be adding, correct? If we remember vector addition from school, then we expect that -1 plus 0 should be -1, 3 minus 5 is -2, 4 minus 2 is 2, so on. So I just need to do v1 plus v2. Let us see. As you can see, it gives me the exact vector answer. -1 plus 0 is -1, 3 minus 5 is -2, 4 minus 2 is 2. Okay. Similarly, you can do difference also, right? -1 minus 0 should give me -1, 3 minus -5 is 8, and then 4 minus -2 is 6, and then -6 minus 10 is 16. So v1 minus v2, -1, 8, 6, -16. Okay. So clearly, the whole reason of working with NumPy arrays is for performing mathematical and vector operations, right? And it does it very seamlessly, very fast, very clean, right? Now let me take this vector, the first vector, -1, 3, 4, -6. Okay. Suppose I just add 10. Now we have seen, okay, what happens when you do v1 plus v2. So v2 is array whose length is same as v1, right? So you can experiment later what happens if you use different length, but maybe you already have some hint about that, right? But here I'm adding this with this, right? These are same length arrays. So then component wise addition is happening. Same way component wise subtraction is happening. What if I just add plus 10? So v1 is this 4 element array here. What's going to happen if I add 10? Interestingly enough, this 10 is added to each element. Okay, this is called broadcasting, right? The value, this operation called plus 10 is broadcast to all the elements here. So -1 plus 10 is 9, 3 plus 10 is 13, 4 plus 10 is 14, -6 plus 10 is 4, right? So essentially it's creating a same shape array in the backend. So when you do v1 plus 10, the plus 10 operator on the array is creating 10, 10, 10, 10, and then adding it to the array. Now suppose I have different shape. So here we are talking about 1 dimension. Let's go to 2 dimension. So I am printing my v1 array here, and it's okay to call it matrix, but typically in data science we just call it 2-dimensional array. Okay, so it's almost as if the word matrix is some kind of old-fashioned term, right? I don't know, but whatever. So we have a 2D array here, and obviously first row is 5 minus 4, second row is -3 2. Again I have another 2D array here, 3 minus 8 minus 6 0. Okay, now if I add these two, what is the expectation? I think everyone knows, right? What's the expectation? 5 plus 3 should give me 8, minus 4 minus 8 should give me -12, -3 minus 6 should give me -9, and 2 and 0 should add and give me 2. 8 minus 12 minus 9, 2. Okay, clean, perfect mathematical operations, which is exactly why this thing is called numerical Python. Okay, NumPy. Similarly, you can do difference between the 2D arrays. You will get component-wise subtraction, and so on. What do you think will happen if I now broadcast plus 8 to this array? So v1 is 2-dimensional, right? What will happen if I broadcast plus 8 to this array? Well, it is going to make an array of 8, 8, 8, 8, 8 in the shape of the v1 array, and then it's going to add. So 5 plus 8 is 13, minus 4 plus 8 is 4, minus 3 plus 8 is 5, 2 plus 8 is 10. So I think you're starting to see where this is going. Why all these things need to be perfectly reliably sorted out at the NumPy library stage. Because after this, when you do data science, data analysis, data manipulation using the other tools and other packages, those tools and packages are expecting such behavior. Correct? So think of any use case, right? Suppose I have a group of data, and suppose there was mistake in measurement. Okay, suppose dollar was confused with rupees, and now I have to convert all of this money data back to dollar. So I need an ability to broadcast numerical operation on like millions of data. I am showing you example with 4 numbers. Same thing can be done with millions of numbers. Yes, right? So that's exactly where this is going now, right? We understand all of these operations, and then when we use pandas and other tools and techniques for data science, all those are expecting NumPy behavior at the backend. Okay, which is why those things are even possible in the first place. If I did not have such strict mathematical foundation, it wouldn't be possible to make a data analyst life easy. It wouldn't be possible. Okay, so just a little bit of input there. Anyway, now again we can do some more interesting things. So for example, sum array, right? I have this new array here, sum array. And what do you think sum array 0 is? What exactly is this? What is the sum array 0? We all know what this is, right? This is the first row. So I can do 0, or I can do 0 and colon, right? It will give me the first row. Okay. So by the way, why is it giving even if you don't access with a tuple? Because by default it goes to the 0th dimension. So if you actually want the first column, then you have to do colon comma 0. Okay, then you will get 13.5. Okay, so and if you want to retain the shape, I think we all remember how to do that. Oh, sorry, that's yeah. So you do this, and if you want this thing as a column, then reshape -1, 1. Yeah, that gives you column. Anyway, so now sum array 0 is actually extracting the first row. Okay. And I'm broadcasting +3 to the first row. So 13 plus 3, 16, 4 plus 3, 7. So what will be output be of the total array? I am only broadcasting to first row. So the first row is replaced with first row plus 3, which means 13 plus 3, 4 plus 3. So now I will get 16, 7, 5, 10. As you can see here, 16, 7, 5, 10. Okay. So the point of this is that you can use various kinds of indexing to achieve what you want. Okay. So for example, here, what is this supposed to be? This is obviously the first column. So right now my sum array is 16, 7, 5, 10. What does this extract? Colon, comma 1. It should obviously extract 7, comma 10. Correct. So now this 7, comma 10, right? This column I'm extracting here, and I am subtracting 5 from the column. So what should I get? 7 minus 5 is what? 2, and 10 minus 5 is 5. So only by manipulating this column, then I can print the full array. And as you can see, 7 minus 5 is 2, 10 minus 5 is 5. The other column is not disturbed. So you can actually identify pieces and sections of your data where you need to do some corrections, where you need to do some processing. Okay, and all of this is based on the indexing. You can also, for example, add column, add vector, do vector addition with the column. So right now, my colon, comma 1, this will extract 2, comma 5, correct? Because as you can see in all of these previous cells, I am overwriting my original array. So right now, sum array is this one, 16, 2, 5, 5. So what is colon, comma 1? It gives me 2 and 5. That 2 and 5, I am adding 3 and 7. So now 2 plus 3 is 5, 5 plus 7 is 12. Now if I print the full array, I will get 16, 5, 5, 12. Yeah. So this is pretty simple, right? Mathematical vector addition and subtraction is position based, and it's very neat and clean, right? As long as you maintain the shape. So now I think it's time to go to image, the 3-dimensional array, right? So here, for example, okay, and so this is obviously very, very big. It is 25, 32, 3. So I am going to work with a smaller section of the image. So suppose I extract the, first 0 and 1. So first 2 rows, first 2 columns, bottom patch. Yeah. So no, top patch. Yeah. In images, 0, 0 starts at the top left. Okay. Just to give you visual, what I'm doing is I'm extracting these 4 pixels here, top left. Right. So I'm extracting those using slicing, right? 0, colon 2, 0, colon 2, right? This gives me 2, 2, and I'm taking all the channels. So now you will get, 1, 2, 3, 4 pixels. Okay. And you have 3 channels. So you have red, green, blue, red, green, blue, red, green, blue values you have here, and you have 4 pixels that you extracted. Okay. Notice that the data type here is integer. This will be very interesting right now in a while. Similarly, I'm also going to take the next 4 pixels. Okay, 2 to 4, 2 to 4. So this will give me 2, 3, 2, 3, right? 4 pixels in a square with the row and column indices 2, 3, and then 2, 3. Okay. So, and all 3 channels I will extract. So now I have the next 4 pixels with all 3 channels. Both these shapes are the same. Okay. Now you can check img1 dot shape equal to img2 dot shape, right? True. The shapes are the same. I can obviously now add them. So if I add img1 and img2, what's going to happen? 0 plus 11, just position wise you check. 0 plus 11 has to come, and then 62 plus 83 has to come, 176 plus 204 has to come, so on, right? So if I just add it, you will notice a very interesting thing. Now 62 plus 83 is 145, no problem. 0 plus 11 is, plus 11 is 11, no problem. But 176 plus 204 should give me 124. That doesn't look right, obviously. 176 plus 204 is 380, right? Why is it giving me 124? The reason is that you're working in integers. Okay, if you're working in uint 8, so it only knows values from 0 to 255, and the size of that cycle is 256. So what's happening is 176 plus 204, which is 380. How much more than 256 it is? It is actually 124 more than 256. So it's going in that integer cycle. Okay, that's why you're getting this value. We can change that obviously by specifying the data type. This is where data type, it's of use, right? Similarly, even in the negative ones, you might expect to find negative values, but why are you getting big values? For example, 0 minus 11 should be minus 11. Why is it 245? Again, because it is 256 minus 11. Okay, you're working in base 8 integers. So to avoid that, you can specify the data type. You can say float 32, for example, very common data type. So now every data is float point. So 181 point, 176 point. These are floating point numbers. And this time, for example, let me take slightly bigger section. I am taking 2 rows and 3 columns and all 3 channels. Okay, so 3 columns for the first row, 3 columns for the second row, and 3 channels. Okay, so I do that for image 1, and I'm also doing it for image 2. And now if you add, you will not run into cyclic integer problems because your data type is now float. So 176 plus 204 is now correctly giving me 380. Same way, 0 minus 11 will correctly give me minus 11. Okay. Again, we can do broadcasting operations like this. So for example, if I just take image 1, which is, what is the shape of this? It is 2 by 3 by 3. Okay, you can check that. 2 by 3 by 3, right? 2 rows, 3 columns. You have these 2 are the row dimension. These 3 are the column dimensions here. 3 here and 3 here for each row, right? And then 3 channels for each combination of row and column. Okay, the way to read this, again, just to iterate, the way to read this, you have 2 rows, which is the first level. Okay, first level is 2 rows. Then within each row you have 3 columns. So within the first row you have 3 columns, within second row you have 3 columns. Within each combination of row and column. So within the first row, first column, you have 3 channel. Within first row, second column, you have 3 channel. Within first row, third column, you have 3 channel. Within second row, first column, you have 3 channel, so on. Okay, so this again, just to reiterate the point that arrays are structured like nested lists. Okay, the only difference between nested list and array is that arrays allow for mathematical operations, lists typically don't. Okay, that's the only major difference. Anyway, so now if I take this section of the image and I broadcast 20, what is going to happen? Obviously it's going to add 20 to all of these. So we've already seen that you can broadcast. Now what have I added actually? This is all rows, no, not all rows. So out of image 1, I have taken 1 channel and all the rows and columns. That's what I have done here. Which channel is this? It is the second channel, RGB, green. So it has taken where is it? The second channel, which is green. So it has taken 62, 68, 67, 63, 74, 70. Okay, I hope that accessing is making sense to you guys. All rows, all columns, second channel. So first row, first column, second channel, 62. First row, second column, second channel, 68. Okay, it's taking the second channel from each combination of row and column because that's what I've specified here. So this subset of this, if I add 20, then 62 plus 20, 82, 68 plus 20, 88, 67 plus 20, 87, 63 plus 20, 83, 74 plus 20, 94, 70 plus 20, 90. Okay, so now I can replace this section back here and only these column values will change, which is what I've done here. So if you do that, 022195, 022195, and only the columns, the values that you changed, you can replace it here. Okay. All right. Yes, Akash, the image will change. I would request you to, explore methods for saving image. Matplotlib, I think plt.save or image.save. There is a method. Just Google it or ChatGPT it. There is a method for saving the image, and yes, the image will change. And when you view the image, it will change. In fact, I mean, right now this is a subset, so it won't make sense if I show the image. Maybe you can do the similar operation for the whole image. In fact, we have a quiz coming up on the same, what you mentioned just now. We have a small quiz on that. Okay, great. Right. So let me like solve one of these. Maybe, you guys can solve the one after that. Okay. So consider the arrays shown below. I'm just going to take these arrays, put it here. Clearly I have, what is the shape of this array, guys? Just by looking at it, can we tell the shape? I have 3 rows and 2 columns. This is 3 by 2. Here I have 2 rows and 3 columns. This is 2 by 3. The question is, add the 2 arrays to produce the following array. Now, before we even attempt this question, right, what will happen if I just add array 1 and array 2? First of all, let us just get the shapes, right? Array 1 and array 2. Okay, so 3, 2, 2, 3. Now, what will happen if I just add the 2? Sorry. Operands could not be broadcast together with shape 3, 2, 2, 3. Shape mismatch. Obviously, you cannot add. Okay, you cannot add directly. The question says add these two to produce these. Now try to take some hint from the question. See, 1 plus 1 is 2. Okay. This minus 2 plus minus 7 is minus 9. Okay. I have 5 plus 8, which is 13. So obviously some addition is going on here. Alright. So to solve this, what you can try is you can print the arrays like this, right? Just to get some visuals. You can print the array. And suppose you do, dot transpose here, right? One method that we've learned is dot transpose. What will happen if I add these two? 1 plus 1 is 2, 3 plus 0 is 3. So I already got my first row. Okay. Minus 2 minus 7 is minus 9. Okay, I got this number. 5 plus 8 is 13. Great, I got this number. Pretty obvious, right? I just need to do array 1 plus array 2 dot transpose. So I just need to do here array 1 plus array 2 transpose, and you get the required array. 2, 3, minus 9, 13, 10, 3. As you can see here, 2, 3, minus 9, 13, 10, 3. Yeah, pretty straightforward, correct? So do this one, right? Do this quiz 16, confirm your result, and then try to do quiz number 17. Okay. So whoever has done quiz 17, you can put your final command in the chat and we will check it out. Okay. Have we all validated quiz number 16? Please tell me in the chat. Quiz number 16, have we done? That one was kind of straightforward. Quiz number 17, I've printed the arrays here, and I'll give a small hint. See, these are my two arrays, right? If you see 1, 3, minus 2, 5, 6, 7, that is the first array. Then 1, minus 7, 0, 8, that is my second array. Question is add to produce this. Okay, 2 minus 4 minus 2, 13, 6, 7. Now, obviously 1 plus 1 is 2. 3 minus 7 is minus 4. So directly adding these two rows will give me this. Similarly, directly adding minus 2, 5 and 0, 8 will give me minus 2, 13. And the third row in the answer, 6, 7 is already there. You don't need to add anything. I hope that is enough hint. Okay, so let me just print the result that we need, then we will check. This is the array that I need. What? There's a bracket missing here. This is the result I need from these two. Okay, 1 comma 3 plus 1 comma minus 7. This is correct. 2 minus 4. Okay, minus 2 5 plus 0 8 is minus 2 13. 6 comma 7 is there. Now, how do you add? What is the correct command to add these two arrays to produce this one? That's the question. GPT may or may not help you out. Okay, already we saw that it has some limitations in arithmetic and numbers and things like that. Okay, hint number 2, we have to use indexing. Okay, if you remember, we for example, this kind of thing, right? We change section of the array and then assign it to that section of the array and then print the original array. Okay, where is this? Here. Anyone able to solve it? So typically I can give around 1-2 minutes and then I will have to demonstrate and continue. Okay. Anyone? Has anyone done it? No. Okay, guys, then look at the screen. Okay, if you're still trying, it's fine. Right, this is a learning session, so please check the screen. I mean, view the screen. Please stop what you're doing, look at the screen. Now, the question says use array 1 and use array 2 to produce this array here. I know that 1 comma 3 and 1 comma minus 7, if I add, I will get 2 comma minus 4. No problem. I know minus 2 5 and 0 8, if I add, I will get minus 2 plus 0, which is minus 2, and 5 plus 8 is 13. No problem. The only problem here is this, the third element, 6 comma 7, but that I already have in this array. The only other problem is, obviously, as I showed you just a while back, you cannot directly add these two arrays because the shape is not matching. Now, ideally, when the shape is not matching, you may think of reshaping and things like that. But if you reshape here, what will happen? If you reshape here, you will run into position mismatch problems. So that's not necessarily a good idea. You can do it. You can. There are many methods to do it. The easiest method I can think of is to pull out this section and then add it this. Right? So how to pull out the section from array 1? I need the first 2 rows and all columns. Correct? First 2 rows and all the columns. So one way of doing that is up to 2 comma all columns. Right? Array 1 rows up to 2, which means 0 and 1. So you pull out these two, and comma colon, which means all the columns. So this actually pulls out these 2 rows. Okay. Now I know that I can add this with this. They have the same shape. This subsection of the array and this array 2 have the same shape. So if I just do array 1 plus array 2, right? 1 1 gave me 2, minus 7 3 gave me minus 4, 0 and minus 2 gave me minus 2, and 8 and 5 gave me 13. So I got these two. So the only thing I need to do now is I need to substitute this back in the section. So this is the section that you started with. Replace that section with this result. Okay. And then the original array itself would have been updated. Now if you see array 1, this is exactly the output that we need. Okay, I hope it is clear. So you can, now this is one method. What did I do? I basically, what did I do? I indexed this section of the first array. I added the second array back into this section of the first array, and then I printed the first array. That's all. So where is that operation? Here. Not this one, sorry, here. So I have indexed the first array, added the second array to that subsection, and then replaced it to that subsection. So basically, in a sense, I have taken this and overlaid it on this, the first two rows, and I've added. Then I've printed the array. Now, of course, you can try other methods if you want. Okay. Now another. Okay. Now, the array is already printed. Just to give you alternate method, you can try collapsing both arrays into 1D arrays, add them, and then reshaping it to the required shape. Please try it later. Okay. Those who want to try it later. All right. Now we have seen addition. Okay. We can start talking about multiplication. So suppose I have this array, and this is 3 cross 3, right? 0.7, 2, 1.3, minus 3, 4, 2.5. Notice that here I have integer 2, but it has been converted to float. Okay, you have to maintain data type. Why it got converted to float? Because I have floating numbers, 2.5, 1.6, whatever. So 3 cross 3 array I have declared. Okay, now what is going to happen if I multiply by the scalar 2? It's going to broadcast into 2 to all my elements. So 0.7 into 2 is 1.4, 2 into 2 is 4, 1.3 into 2 is 2.6, whatever. Notice that again, this is not an in-place operation. It is a temporary output. So many of these things, as I mentioned yesterday also, a lot of these things are temporary outputs. So if you really want to update your array, then you need to assign it back. So this result you can compute here and assign it back to your array. So now your original array will be updated. Okay, now all the elements in this array have been multiplied by 2. You can also do indexing as shown before. If you do, what is this, right? Let's try to read this. Currently this is my array, right? What will np array colon 2 comma colon give me? This means give me every row up to 2 excluding 2. This is another thing with Python we should remember. Indexing is exclusive. So it will exclude the position number 2. It will give me everything from starting to 2 except 2. So 0 and 1. 0 and 1 means this row, this row. Now in these two rows, I am saying give me all the columns. So 1.4, 4, 2.6, minus 6, 8, 5. Okay. So this section, I am saying multiply by 2. Okay. So it pulls out this section and it has multiplied by 2. Okay. You want to reassign it back to the array, you can do that. But obviously you cannot broadcast this into a different shape. Okay. Different shape you cannot broadcast. What shape you can broadcast? You can broadcast into 3 by 2 because the operation that you're doing here, it is resulting in a, sorry, not 3 by 2, 2 by 3. The operation you're doing here is resulting in a 2 by 3 n-dimensional array. So this you can broadcast back into any 2 by 2 section, by the way. I can change this indexing here to actually index the second 2 rows and it will still replace. But that is obviously not what we intended here. So I will replace it in the same section, which is the first 2 rows. Okay, so 1.46, all of these will be multiplied by 2. This should be as it is. Minus 3.2, 9.8 should be as it is. As you can see, it does the same. Okay. Similarly, you can also do division, right? So division by 5. Now this is my current array. If you divide by 5, what will happen? 10 divided by 5, 16 divided by 5, 2.8 divided by 5. It will divide all the elements by 5. So 16 by 5, 3.2, 10 by 5 is 2, 2.8 by 5 is 0.56, whatever. You want to assign it back, you have to use npr equal to npr by 5. You can assign it back to the original. Section wise also you can do divisions. All rows and from first column up to end. Let's try to read this now. All the rows and then from first column up to end. When I say first column, I mean column number 1. Okay, and in Python, column number 1 is this, the second column. Okay, so all the rows starting from column number 1. So this section 1.6, 1.04, 3.2, 2, 0, 1.96. Okay, So what should I get? 1.6 divided by 2 is 0.8, and then this will be 0.52, whatever, 0.8, 0.52, 3 by 2 divided by 2 is 1.6, whatever. Correct? You can assign it back and update your array. Okay. Now this is obviously sort of scalar multiplication, right? Suppose you take something like this. Suppose you take one row. So I am taking from vector 1, I am taking the first row, which is 0.6, 0.8, 0.52, and from vector for vector 2, I am taking the second row, which is minus 2.4, 1.6, 1 point nothing. That's 1. So basically this row I have extracted here and this row I have extracted here. What will happen if I do vector 1 into vector 2? Interestingly enough, it does position wise multiplication. Okay, very interesting stuff. Position wise multiplication. I hope everybody is now remembering something called dot product. Right, this was something that we studied in vectors and vector algebra, those kinds of things. So as you can see, NumPy is bit by bit, step by step, giving you all the stepwise operations for all the mathematical operations that exist out there. It could be anything, area of triangle, it could be finding the resultant force vector, whatever, right? NumPy has all the fundamental steps covered. So here you can see it is doing element wise multiplication. 0.56 into minus 2.4 is here, 0.8 into 1.6 is 1.28, 0.52 into 1 is 0.52. Okay. Of course, again, this is not in place. So if you want to save it in a new vector, then you can save it. All right. Okay. So do you guys, I think we are ready to try a quiz on our own. So please try this one. These two arrays multiply to produce this. And a bracket is missing. So these are my arrays. Array 1 is this. Array 2 is this. Okay, these two should be multiplied to produce this. Feel free to use additional operations if you want, but I think it should be very obvious what's going on here. Okay, quick hint: 3 into 7 is 21, or 3 into minus 7 is minus 21. Minus 21 into 10 is minus 210. So can we give the one line command for this, guys? Okay, anyone who solved it, put your one line command in the answer in the chat. Straightforward, right? No, not straightforward, Akash. You're saying 1 into 1 into 10 is 10, 3 into minus 7 into 10 is minus 210, minus 2 into 0 into 10 is 0, 5 into 8 into 10 is 400. This is not straightforward. If you're talking about the NumPy not being straightforward, I agree. But the mathematics here is very straightforward. Anyone? What can you do? Array 1, what is the set of operations? What's the simplest set of operations to produce this from these two arrays? And by the way, guys, feel free to raise your doubts. I think as Sonal had raised, if your doubts pertain to the session and the topic, right, and you feel that they are valid, please go ahead and raise. So indexing is obviously the main thing in NumPy and all that. Nobody has the solution yet? Anyone? Okay, maybe I'll solve it and okay. So guys, okay, look, I have array 1 here, which is 3 cross 2, right? 3 rows and 2 columns. And I have array 2 here, which is again 3 cross 2. Okay, both the shape are same. And the question is telling me use these two arrays and produce this array. And if I just take this and print it here, it's again a 3 cross 2 array. Now one pattern I can observe is 1 into 10 is 10, 3 into minus 7 into 10 is minus 210, so on. So what's happening is I can multiply array 1 with array 2. For example, if I multiply, let us see what happens, right? Array 1 star array 2. Notice that I have 1, minus 21, 0, 40, 24, minus 2, 21. I just don't have these additional zeros. That's all, right? I have the exact same array as the question says, except I don't have this factor of 10. So all I need to do is multiply by 10. And as you can see, this simple command, array 1 into array 2 into 10, produces the exact array that is required in the question. This is the simplest set of operations that you can do to go from these two arrays to produce this result. Okay, it's a simple position wise multiplication. And by the way, I showed you position wise multiplication for one dimensional, right? I showed you for 1D. So I showed you this vector 1, which is this one dimensional array here, and vector 2, another one dimensional array. And I showed you multiplication between the two vectors. Obviously, this is not complete dot product or cross product. It is not. It is only doing component wise multiplication. So 0.56 into minus 2.4, right? Position 0. It is matching the two positions, like whichever same position numbers in the two different arrays, and it's multiplying those two and giving the answer. So 0.56 into minus 2.4 came here, 0.8 into 1.6 came here, 0.52 into 1 came here. So when your arrays have the same shape, it's going to produce element wise operation, be it addition, division, subtraction, multiplication. Okay. So in this case, in the quiz, we have two dimensional arrays, but the exact same concept is applied. Exact same technique is executed. If the shape is the same and you multiply the two arrays, it will check the same position in both the arrays and it will perform the operation. So 1 into 1 is 1, 3 into minus 7 is 21, 5 into 8 is 40, minus 2 into 0 is 0, 6 into 4 is 24, 7 into minus 3 is minus 21 again. So array 1 into array 2 produces this 1, minus 21, 40, minus 21, 0, 24. Then I also spoke about broadcasting operations. Broadcasting means apply to all the elements. That was very simple, right? So this result, you just multiply by the number 10, then multiplication by 10 is applied to all the elements of the result. So the intermediate result in this case, that is this, right? 1 minus 21, 0, 40, 24 minus 21. To this result, I can now multiply 10, which will then produce the array asked in the question. Clear? Okay. Okay. So theoretical mathematics may be a different, ball game, right? Maybe that is difficult, but NumPy, as you can see, right? Like, as you can see what I'm doing right now in the session, right? So do you think that I'm facing any difficulty? I'm not. That's just because I have used NumPy so much. Same way you guys need, that's why there are many quizzes, guys. That's why there are many quizzes. And even in the platform, when it becomes live for you, I think there are more practice questions. Please practice NumPy. When we move to pandas and all of that, we will have to learn other things, data analysis and data science related things. So it's better to practice this when we have the chance, and then little by little we'll keep improving. Okay. Great. We've discussed addition, subtraction, division, multiplication. What other mathematical operations you can think about? Exponentiation, right? And I hope we all know the basic exponent. For example, what is 4 power 2? I hope, do we all know the symbol, guys? Double star. We all know double star, exponentiation. Okay. So 4 star 2, 16, right? This is 4 power 2. 2 power 3, 8. Okay. Then minus 2 power, why minus 2? Minus 3 power 5, minus 243. Okay. This is exponentiation. All right. Now suppose I have this array again. I have a NumPy array. Here I have taken 2 rows, 3 columns, 1, 0, minus 1, 2, 0.5, 0.1. And suppose I square the array. So notice what I'm doing here. I am taking the full array and I'm squaring the array. What do you think is going to happen? Each of these elements will be squared. That's exactly what will happen. 1 power 2 is 1, 0 power 2 is 0, minus 1 power 2 is plus 1, 2 power 2 is 4, 0.5 power 2 is 0.25, 0.1 power 2 is 0.01. Again, very straightforward. Okay. Not an in place operation. Does not change the original object. So if you want to change the object, reassign. Okay. So I'm reassigning the result to the object. And now I have the squared array. Now how do you get square root? In mathematics, how do we get square root? Power 1 by 2. Correct? Cube root is power 1 by 3. So same thing. If I take this array and then do square root, which is power 0.5 or power 1 by 2, that will give me what? Square root of 1 is 1, square root of 0 is 1, square root of 1 is 1, square root of 4 is 2, and so on. Notice that it only gives me the positive square root. Okay. For, negative, positive and things like that, you can explore a little bit more advanced NumPy operations, but right now not necessary. Okay. So square root operation, it's just power 0.5. Again, this is not going to change the original object, so I can reassign and print. So what happened here to here? I have this array, I squared it and I got this array here, and then I did square root, I got back this array. Okay. Now of course there is a method called square root, np.sqrt. This is a very common method which is used. So if you do not want to use power 0.5, you can use the more advanced method, which is np.sqrt. Okay. So you can read more, by the way. In Jupyter, whenever you open a method like this, you just click inside the bracket, just put your cursor just next to the first bracket, and you can press shift tab. I hope we all know that in Jupyter. So if you press shift tab, you will get commands and parameters and a bit of documentation. I think there are some examples. Okay, examples are not here. Examples you can find in the documentation page. Anyway, so np.sqrt is a very common method used in NumPy, which is nothing but square root. So now if I take this array and I do np.sqrt of this, that is going to give me the square root of each of these numbers. Okay. Again, this method is not in place. Okay. Again, the phrase I keep using is in place. Okay, this is what I'm saying, in place. These operations are not in place. They don't change your original object. So for example, if you print np array again, it has not changed. Okay, a lot of these operations are not in place. So if you want to change, then you have to assign. All right. So just wanted to give a little bit introduction and insight into exponentiation also. Right. It is not so different from addition, subtraction, multiplication. It behaves in a very similar fashion. All right. Okay, great. I do have a homework quiz here, which you can try it later. Now, maybe we can take a small break here and then reconvene, because now we'll be doing more statistical. So up till this point, we were doing basic mathematics. In other words, basic mathematical operations on NumPy arrays. Now we will get into a bit of statistical operations, right? This is where the entry into data science begins, so to speak, right? Actual entry into data science activities, data analysis activities starts with the statistical operations in NumPy. Okay, that is from here. So in the next part, we will be doing statistical operations and what some of the other methods. We have some interesting methods. So up until this point, we have discussed, you know, structure of NumPy arrays, basic operations such as addition, deletion, replacement, accessing, indexing, those kinds of things, right? And we also saw basic mathematical operations that can be performed between arrays, right? And we also saw some broadcast operations, which applies to all the elements in an array. Okay. Now we'll start with statistical operations, right? Which kind of leads into what we are going to be doing tomorrow and possibly day after in pandas, right? This is where data analysis, data science, all of that starts, right? Essentially data analysis, data science, these are statistical methods applied to real data, essentially. So let's start with some of the very basic statistical methods, right? So suppose I have this array here, npr, which is 1, 2, minus 3, 5, 6. Okay, so there is a method associated with the array object called sum. Okay, sum, and obviously I think we all know what sum is supposed to do. It's essentially going to add up all these elements. Okay, so start thinking in terms of your own domain data, right? If you're from finance background, you must be adding revenue values or profit values, something like that. If you're from management, you might be adding some other kind of values. The very notion of addition of numbers is a kind of statistical operation, right? In maths you can call it addition. In statistics we call it aggregation, right? What is the aggregate of this group? So this is where, as you can see, we are getting into the whole concept of data analysis, right? So one of the most basic statistical operations is sum. So if I just do npr.sum, it's going to add all these and give me, okay, 1 plus 2, 3 minus 3, 0, 5 plus 6, 11. So nparray.sum is giving me 11. Okay, suppose I take two-dimensional. Okay, now I have 1, 2, minus 3, 5, 6, and then I have one more row, minus 4, 3, 2, 5, minus 2. What is going to happen if I do nparray.sum? It is actually adding all the numbers and giving me the answer. So it is doing 1 plus 2 minus 3 plus 5 plus 6, which was 11, and then minus 4 plus 3 plus 2 plus 5 minus 2. So that's minus 1 plus 2, which is 1, 1 plus 3, 4. 4 plus 11 is 15. So on the back end, what is going on is it is collapsing to one dimension. Okay. So when you do something like nparray.sum on a multidimensional array, it is collapsing to 1D and adding everything. Okay, it's as simple as adding all the numbers. Now, typically in data science, we don't want to just add all the numbers, right? Suppose we have one dimension which is say nationality of a customer, right? And suppose another dimension is gender of the customer. So now I can do an analysis which is give me the expenditure by this nationality. So how much are the Indian customers spending? How much are the American customers spending? So on. I can also ask the question, how many are the male customers spending? How many are the female customers spending? How much, sorry, are the female customers spending? So typically in data analysis, we are interested to have control on the axis on which we are applying the statistical operations. Okay. So which is why most of these methods, if you see sum and all of the other statistical methods, they will have a parameter called axis. And remember, axis equal to 0 means row, axis equal to 1 means column. So now when I do NP array sum with axis equal to 0, okay, for NP array, and if you want, we can just print NP array here. Yeah. So you might think that one row got deleted or something, but no, that's not the way to think about this. What it has done is it has collapsed the rows into the columns into one dimension, right? So what it has done is it is preserving the row dimension. So 1 minus 4, it's collapsing the row dimension, sorry. So 1 minus 4 is minus 3. 2 plus 3 is 5. Minus 3 plus 2 is minus 1. 5 plus 5 is 10. 6 plus minus 2 is 4. So what it has done, it has applied this operation along the rows while preserving the columns. So this sum operation has been applied along the rows. Okay. So these are your rows, 1 minus 4. So think of it this way. Column number 0, how many rows? Row 1, row 2. Or in Python language, row 0, row 1. So column number 0, all rows has been applied sum. So 1 minus 4 became minus 3. Then column number 1, again all the rows apply the sum. 2 plus 3 is 5. So what you have done is you have added all the rows for each column. That is what axis equal to 0 is doing. The sum operation is applied on the row elements for each column. Same way, if I do NPRA sum axis equal to 1, now I think we can all guess the answer. What is going to happen? It is going to apply sum for all columns in each row. So now the answer should be just two numbers, isn't it? Row 1 sum and row 2 sum. And if we remember the sum, it is 11 and 4, I think, right? So suppose I do this, now I get 11 and 4. Okay. So axis wise operations are very important typically in data analysis. And we won't just be doing summation, we will be doing mean, median, all sorts of other kinds of analysis, right? So that's very important to note that we can do operations axis wise. Again, just to show you that these are not in place operations, they only give temporary output. So this is my NPRA, which is still the same as the original. Similarly, we have this method called product. Now typically in data analysis, summation, mean, median, transformations, these kinds of things are more common. Product is not so common, but still we have the method. As I told you, NumPy is a universal package. It will have almost all the methods, mathematical methods and statistical methods that are out there. So product also behaves the same way. Suppose I do NPRA.product, just without specifying the axis. Then it is going to multiply all the numbers. So I'm getting minus 43200. What will happen if I do axis equal to 0? It is going to apply product across the rows for each column, right? So it's going to do 1 into minus 4, 2 into 3, minus 3 into 2, 5 into 5, 6 into minus 2, right? So minus 4, 6, minus 6, 25, minus 12, right? Minus 4, 6, minus 6, 25, minus 12. Similarly, if I specify axis equal to 1, it will multiply these numbers. That is giving you minus 80, and these numbers gives you 240. Okay. Now, of course, the most common and the easiest and the simplest statistical method is the mean. And for those who are still wondering mean versus average, there is this very big unjustified debate, I would say, that what is the meaning of mean and what is the meaning of average. Statistically, the correct word is mean. Okay. In mathematics, the word we use is mean. Average is more of a English kind of word, not really a technical statistical word in pure statistics. Okay. Mean is the correct word, which is why in all the methods, you will find the actual statistical term, which is mean. Okay. Average is more of a informal term that we use, but the real terminology is mean. Now, suppose I do NPRA.mean. What is mean? I think we all know what mean is. Mean is nothing but total sum divided by number of elements, correct? Now, in this case, what was our total sum? Total sum was 15, I think, right? Total sum is 15. How many elements do we have? This is 2 cross 5, so I have 10 elements. What should be the mean? 15 divided by 10, 1.5. So when I do NPRA.mean, I will get 1.5. Similarly, you can apply the axis parameter. So axis equal to 0. What it's going to do? It's going to get mean applied along the rows for each column, right? So for column 0, it's going to take row 1 plus row 2 divided by 2. Then for column, see guys, I'm going to interchangeably say row 1, row 0. Okay. I hope we are all comfortable with this language. Sometimes when I say row 1, I'm talking about the 0th row. Sometimes it's the first row, but this is something that we all have to live with. Okay, so sorry for that. Let me just correct myself. What this is going to do, it's going to do column number 0, row number 0 plus row number 1 divided by 2. Column number 1, it is going to do row number 0 plus row number 1 divided by 2. So 1 minus 4 by 2, 2 plus 3 by 2, minus 3 plus 2 by 2, 5 plus 5 by 2, 6 minus 2 by 2. Why divide by 2? Because you are applying mean, right? You are applying statistical mean, whose formula is sum of elements divided by number of elements. So I will get what? Minus 1.5, then 2.5, then minus 0.5, then 5, and then 2. Okay. Minus 1.5, 2.5, minus 0.5, 5, 2. Similarly, axis equal to 1 if you do, it will take the mean of this and mean of this. And we know this is 11, so 11 by 5 is 2.2, and this is 4, so 4 by 5 is 0.8. Okay, so 2.2, 0.8. Okay. Yeah. That the operation that you're trying to apply, and when I say operation, there are multitude of operations. I have shown you some operations. I have shown you sum, I have shown you product, I have shown you something else, maybe I forgot, mean. Yeah. So there are many operations that you can do, many statistical operations you can do with a bunch of numbers, right? All of these methods require a bunch of numbers. Axis is specifying which bunch of numbers do you want to apply the operation to. In one dimension, there is no question. There is only one set of numbers. In two dimension, you can see sets of numbers in two different ways. Okay. For example, if you take this array, the one that I'm highlighting, I can look at it in terms of 2 rows of 5 numbers, or I can look at it as 5 columns of 2 numbers. Correct? Now to just improve that language, I can see it as 2 rows of 5 columns, or I can look at it as 5 columns of 2 rows. Did that make sense, guys, everyone? 2 rows of 5 numbers is the same as 2 rows of 5 columns. Same way 5 columns of 2 numbers is nothing but 5 columns of 2 rows. Okay, now we are making the language more formal. So when I say axis equal to 0, I am saying apply the operation on the rows of each column. Whatever operation I'm specifying, apply to the row elements of each column. That is axis equal to 0. Axis equal to 1 means what? Apply to each column, right? Apply to all the columns of each row. So there are 2 ways of looking. The first way of looking was 2 rows of 5 columns each, right? That way of looking is axis equal to 1. Okay, 2 rows of 5 columns each is axis equal to 1. So each row I'm looking at it as a set of 5 columns, axis equal to 1. Then when I do dot sum, it will summation the 5 columns for each row. Okay, I think this makes clear. If I look at it as 5 columns of 2 rows each, then that is axis equal to 0. Okay, so then if I say do summation for axis equal to 0, for each column it will pick out the 2 rows and it will apply the summation on the rows of each column. So just to summarize, axis equal to 0 means what you're doing is you are applying operations on the rows of each column. Axis equal to 1 means you are applying the operation on the columns of each row. Okay, so just think about it that way, right? And just to make the language even simpler for everyone to remember, collapsing rows means axis equal to 0. Collapsing columns means axis equal to 1. Yeah, great. Okay, and by the way, I hope we appreciate that. If you apply summation on the row elements, it will collapse the row. Correct. So if I have one column with 2 rows, and if I apply sum, it will collapse the 2 rows into one number. Okay. Yeah. All right. Right. So let me demonstrate this with a question here. Okay. So suppose I have coordinates of 2 points in 3D space. So this is 3-dimensional space, and these are my coordinates. This is from coordinate geometry in mathematics. I hope we all remember. Okay. So my first point. So this is my x value, y value, z value. I hope we all remember this XYZ business. What is this array 339, Anusha? You did some subtraction, didn't you? Okay, subtracting the coordinates does not give you the Euclidean distance. NP dot square root of 0.2 minus 0.1 squared. You forgot one small thing, Anusha. You're almost at the correct answer, but you forgot one thing. What did Anusha forget? Can anyone just see that? And guys, let's have open discussions, okay? Then only we are all learning. There's one small thing that Anusha forgot in the formula. Anyone can identify? Almost correct, 90% correct. Point number 2, x coordinate is 1, y coordinate is 0, and z coordinate is -4. Okay, now if I remember my Euclidean distance formula correctly, I need to do x1 minus x2 square plus y1 minus y2 square plus z1 minus z2 square, and then I need to take square root. So Anusha, I think you understood. Are you getting the hint? What you missed? What did you miss? Summation. Exactly, you missed summation. Okay. So here what I can do is 0.1 minus 0.2. Okay. First thing I need to do is square, and I'll print these results one by one so that we can all understand step by step. Okay. So here's my 0.1, here's my 0.2, and I need to first of all do 0.1 minus 0.2 square, which gives me this 9981. The next thing I need to do is summation of this result. So what I need to do is 0.1 minus 0.2 square, which by the way, the result from this operation is an array. I hope we can all see that. When I do 0.1 minus 0.2 square, right, it's giving me array. The moment I can see an array, why should I store a new variable? It's an array. So all I need to do is put it inside another set of brackets, and I can directly use array operation dot sum. An array, right? The answer from here is an array. So I can do directly dot sum. The only thing is you need to put one set of brackets. Okay. So array 9981 dot sum, which means 9 plus 9 plus 81, which is 99. Now I need to do square root of this, and we have used np dot square root, which is fine. So np dot square root, and I take this whole operation and I'll put it in here. So the Euclidean distance between these 2 points is 9.95 something. All right, it is clear. And by the way, Euclidean distance is used almost in all places when you deal with things like machine learning. Anyway, so as I said, we will spend a lot of time in the initial part of the program becoming masters of the tools, and slowly we will start implementing in the various concepts. And as I said, I think someone asked me last time, when we go to the concepts, it is assumed that you know all the tools. Okay. Anyway, so that was pretty straightforward, wasn't it? So this is the thing, right? NumPy, you cannot do this in one statement like this with lists and things like that. You cannot do this with lists. Okay. Which is exactly why NumPy came into existence. It is a universal mathematical library, right? So it was, so you can say that list, string, tuples, these are all very general purpose programming objects, right? So it is more generic. On top of that, you have a subsection called NumPy, okay, which uses all this, of course, but it is specified for mathematics. Okay, there are some couple of interesting questions here, which I will let you guys to solve it later. And let's look at some other interesting methods in NumPy. One of the very typically used method is round, because whenever you are dealing with reporting data, whenever you are dealing with things like storytelling, things like data reports, it's not nice to see values like 9.94987437 in your report, right? It doesn't look that good. So NumPy gives you round operation also. And notice, okay, again, just to iterate the point, NumPy is not just about vector, advanced mathematics, nothing like that. NumPy is about all mathematics. So even the simplest kind of operation that you can think of in mathematics, rounding a number, even that is specified as a proper inbuilt command, right? So here the method we are using is numpy.round. You can specify your input array here. You can also specify the number of decimal points to retain. And notice that again, this is a broadcast operation, right? It will apply to each element. Okay. So in this case, I have 1.56, 2.765, minus 3.33, 5.102, and all these numbers. And I'm just giving you the name of the parameter here. Again, you can use Shift Tab to check what are the parameters of this method, and then you can go study the parameter. Okay, what does it do? Things like that. And you can even check the documentation later. I highly recommend, right? Once we are all somewhat comfortable with the basics, we should start exploring the actual documentations of all of these libraries. Okay, so NumPy documentation is well documented, extremely well documented library. So just go Google NumPy documentation, you will get the whole thing, right? Anyway, so the parameter of the input array is called A for whatever reason. So one thing that I would advise everyone when you are looking at documentations, when you are studying these methods and parameters, don't worry too much about the parameter names. Sometimes somebody would have given the name A here. In some other method, the actual input would be called input, or some other method the input may be called ARR. Okay, these things happen. Okay, but what is important is to understand what is the input. Okay, so the input here is the array, and there is a optional parameter, okay, which is the number of decimals. So if I round my NP array to 2 decimals, what is going to happen? I will get 2 decimals. So if you see 1.56 rounded to 1.56, 2.765 rounded to 2.76. Why? Do we all know the international universal rounding rules? If there is an even number here, then when there is 5, it will not change to the next number. If it's odd number, it will change. Correct? So these are universal mathematical conventions, right? All that is encoded in these NumPy methods. Okay, so numpy.round. And again, it is not an in-place operation, right? You have to assign if you really want to change. Okay. So now if I round it to 2, I will get this array. Now again, if you directly round it without specifying decimals, it rounds to integer, because the decimal default value is 0. So when you round this array without specifying the decimal parameter, it will round everything to integers. Okay, so then you can store it in a variable or whatever. That's fine. Now I've given a very interesting example homework here. This is similar to your Euclidean distance. I would urge learners to try this later. I would urge everyone to try all the quizzes later, actually. Right? And this is regarding the area of a triangle. So this is quite an interesting one. This will kind of motivate you to try to use multiple operations and commands, whatever you have learned. So this question definitely a must try. All right. Okay. So let's move on to some other examples of functions in NumPy, methods in NumPy. So we have seen basic methods. Where are they? Yeah, we have seen basic statistical methods like sum, product, mean, and things like that. Of course, there are others. Now, I'm guessing everybody is wondering, is statistics only mean, product, and sum? No, obviously not. But my point is that we will be learning other methods as we go ahead, and all of that is built on NumPy only. So when we do pandas, when we do EDA and all those other topics that we'll be doing, we'll be using all these statistical methods, right? Either we'll be invisibly using by using the method from the pandas library, for example, which is built on NumPy. So I might do pd dot median, right? Pandas median, but that's actually built from NumPy median. Okay. So same way when you do EDA also, you might use, this is a case where you're using it invisibly. You might even use a different NumPy method somewhere later where it is required, in some data analysis, and that time you may do it visibly. Okay, so this is just an introduction to the set of statistical methods. In fact, if you go to the documentation, it will give you the full list of available methods will be given. You can check that out later. Yeah, so again, back to the thing. So what we saw axis wide methods or axis operations, we saw sum, we saw product, we saw mean. We can also customize axis wide operations. Very interestingly enough, we can customize this stuff. Okay, so suppose I have an array, right? 1, 2, minus 3. I think we've seen this array before, right? Same array. So this sum is 11, this sum is 4, whatever. It's the same array. Now suppose what I want to do is, I want to do a custom operation on these numbers, right? So I'm defining a function here, and what I really want is I want to square the number and add 5. So I want to square 1 and add 5. I want to square minus 4 and add 5, right? So suppose I define this, right? Num transform x, you should return for me square plus 5. Okay, so suppose I do this. Okay, this function is defined. Now there is a method called np.apply along axis. Okay, so in this what you can do is you can provide your user defined function, and then you can specify the axis that you want to apply and give your input array. Okay, so here let us see what the output comes out to be. Now in this case, because you are doing an integer operation, it really doesn't matter. This axis parameter doesn't matter because you're doing integer operation, right? So if you see the documentation, here it says axis integer, axis along which array is sliced. Okay, but this is an integer operation. You're taking x, which is 1, and then you're squaring plus 5, and then 2, and then squaring plus 5. So what is 1 square plus 5? 6. What is 2 square plus 5? 9. What is 3 minus 3 square plus 5? 9 plus 5? 14. So it is it's just taking all of these numbers and it is squaring and it is adding 5. So I can achieve the same thing by doing what? I can just achieve the same thing by doing this, right? np square plus 5, because this is a broadcast operation, right? I can achieve the same thing by doing just broadcasting. Now where this starts to make more sense is when you do statistics. So now if you see here, the same function I'm redefining, but now I'm assuming x not to be integer, but I'm assuming x to be a slice of an array. Either it is a column slice or it is a row slice. So either it's one column or it's one row. Now supposing my input is either a column or a row, then I can actually apply basic statistical aggregation methods on that slice, right? And then I can apply this custom function on my array. So here I have done what? np.mean x plus 3. So for example, suppose I take this 1 minus 4, which is minus 3, and the mean of these two is minus 1.5. So minus 1.5 plus 3 is 1.5. So if I apply this to collapse the rows, which is axis equal to 0, then I will get 1.5 plus 3, which is 4.5, right? 1 minus 4 is minus 3, divided by 2 is minus 1.5, which is this value here. Okay, collapsing this these two rows plus 3. Same way you can do for axis also. So let's see how this works. So suppose I define this. Now again I'm applying this function. I'm passing this function name to the argument func1d, right? And notice that these functions are applied on one-dimensional slices, which is why the parameter is called func1d. Here I'm specifying axis equal to 0 and input is NumPy array. If you see the output, what has happened? Axis equal to 0 means what? You are collapsing the rows, right? So what it has done? it has taken mean of 1 and minus 4, which is 1 minus 4 divided by 2, right? Minus 1.5 plus 3, which is 1.5. Then 2 plus 3 divided by 2 is 2.5. 2.5 plus 3 is 5.5. Okay, I think you are getting the pattern. So you have applied this custom function to collapse the rows, axis equal to 0. Same function you can now apply with axis equal to 1. So in that case, what will happen? It will take this mean and it will add 3. So the mean of this, if I remember, it is 2.2. So 2.2 plus 3 is 5.2. Again, mean of this is 0.8 if I remember. So 0.8 plus 3, 3.8. So now same function, if you apply on axis equal to 1, you will get 5.2 and 3.8. Okay. So just wanted to show that you can customize your own functions, and this will become more important when each of you is more involved in your own domain and your own data analysis in your own domain. You will be having various functions which I don't need, for example, right? If your domain is finance, then you might be having a lot of operations which you will be using, right? But if I am working in weather sciences, then I'm going to have various operations which don't really are not of use to you, right? So this is quite important when you do get into your own analysis. Okay. Now again, this np.apply along axis is a NumPy method. Typically in data science, as I said, this is now used to build more user-friendly functions. For example, in pandas we have something called .apply. Okay, so it uses this NumPy as a base, and it the same behavior is inherited to the libraries which are built on top. Okay. It's good to know what's happening though. The whole point is it's good to know what's happening here. Okay. No, I mean, yeah, you have to pass a function, Anusha. Customized operations using apply along axis. If you're talking about this method, apply along axis, then yes, you have to define a function. It needs to have a parameter, output, all of that. It needs to have a return. Yeah. So it needs to have a name. It needs to have a return. Okay. That's why it's called func1d. You can directly use something like np.mean, I think, right? Because it is a function, right? You can just try np.mean. It may or may not allow. You can try it on your own, right? But typically np.mean is a function. So if I directly use np.mean here, it should work. It is working. See, it's working. Anything which is a function can be passed into the argument, right? func1d. So now you check the documentation. Here it says, it will tell you what is func1d. Apply a function to one-dimensional slices. Func1d. It's a function which takes a set of parameters to a result output. Okay, so this is obviously your tuple, and I hope we all understand now that the input to a function is a tuple, right? I hope you have all studied functions. So in this, you essentially you have a tuple of input parameters, right? So that's what it is telling me in the documentation. Here, if you see, it says that the function which takes input tuple, parameter tuple, and it produces some output, right? This function should accept one-dimensional arrays, obviously, which is why np.mean is working. Okay, if you think of a function which does not work on one-dimensional arrays, then it will give an error, right? So yeah, you can use predefined functions, you can use custom functions. You need to use functions. For this method, you need to use functions. All right. Now in data analysis and typically in programming also, it's quite important to generate numbers. In many cases, we'll be generating numbers. So there are some very standard basic methods to do that. So I think we all know this range method. Are we familiar with range in Python? Is everyone familiar with range? So if you do range 2, it says it's a range. Now I can actually try type range. Type range is range. Okay, so it's not a list. The range method, it's what you say. It's a direct Python method. It's not a library method. So same way, you have int, you have float, you have range, you have sum also, right? All of these are direct Python methods, not associated with any kind of library. Okay, so you will see it become green color in Jupyter. I don't know Colab. I use very sparingly Colab. Mostly I use Jupyter, but yeah, you can see this green color, right? So this range thing, the output is range. Now, how do you get a list out of this, right? Maybe you can do list range 2. Yeah, that gives me 0, 1. Okay, so this range thing is a range object. Then you convert to list, you will get list. So NumPy, what does it do? It takes this and creates a very universal function out of it, right? That's what NumPy does, right? It takes this whole behavior and it generates an array of numbers for you. Okay, so that method is called arange. Okay, np.arange, and this is such an important method. We'll be using it so many times. So it follows the same typical indexing of Python. So there's a start number, there's a stop number, and then there's a step. Stop number is exclusive. So if I do, yeah, it's basically like indexing. Yeah, the only thing is you can produce any number in this. Okay, let's see that, not just integers. Okay, so here start equal to 0, stop equal to 5, step equal to 1. It should give me 0, 1, 2, 3, 4. Array 0, 1, 2, 3, 4. And of course, you don't need to use the parameter name each time. If you remember the correct order, then you can directly skip the parameter name. So here, if I do np.arrange -10, 0, 0.5, what is this going to do? It's going to start at -2. It will exclude 0 and it will go in steps of plus 0.5. If I do this, I will get -10, -9.5, -9, -8.5, so on, so on, so on, till -0.5 exclusive of 0. If you do not specify the third number here, which is the step, the default is, I think, 1. So we can check that. Step default is 1. See, the default step size is 1. So if you don't specify step here, you will get 0, 1, 2, 3, 4. Start number and end number. So, and my point is, you can actually use this to produce any kind of evenly spaced range. Okay. So this is, a very typical common method that that we are using in NumPy. Another similar method is called linspace. So this becomes important when you try to do a bit more advanced visualizations, right? So usually these kinds of methods are used to define axes. Okay, so for example, if I want an x-axis which starts at 0, stops at 1, and the total number of numbers is 2, then in this case I'll get 0 and 1. Notice that for linspace method, this 1 is inclusive. Okay, this is slightly different method. The stop is included. So basically what this method is doing, from 0 to 1, I want 2 numbers inclusive of 0 and 1 which are evenly spaced. So it gives me 0 and 1. Now if I say from 0 to 1, including both, I want 5 numbers which are evenly spaced. So then I will just change num to 5. Now you get 5 numbers including 0 and 1 which are evenly spaced, 0, 0.25, 0.5, 0.75, 1. Okay, pretty simple method, right? Again, you can do the same thing from 0 to 1. I want 50 numbers. And one thing that you should remember in mathematics is when you include the starting and the ending, then the total number of numbers will be plus 1 if you are evenly spacing, right? So if you do 50, then what's happening is totally you have 50 numbers, but the space between number is 49. So if you have 50 numbers, just think of 50 points on a line. How many spaces are there between the points? 49. So if you want to look, if you want to clean, numbers, if you don't want these kinds of very bad float numbers, of course, this is also going to be float. But if you don't want these very weird numbers, then if you put num equal to 51, then it will give you really clean numbers. Why? Because now the number of spaces is 50. So what I'm trying to say again is this is the number of numbers, not the number of spaces. So that's one thing to keep in mind, because this is inclusive, right? In this linspace method, the stop is inclusive. Okay, so these are like the two most common pattern producing methods in NumPy. One is arrange and one is linspace. Okay. All right. Can everyone create this array now using either of the methods? Please try solving quiz 26. Sri Prakash, that's a really good question. Does it take float by default each time? Answer is no. Look at this. np.arrange 0,5 with step 1. Can you see there is no 1 point? See, there's no 1 point, 2 point, 3 point. The point is not there. So this thing, if you just do type, that will be array obviously. Sorry. If you do the first number, then type, that is int 32. Okay. So no, each time it's not going to be float. It will take the data type which is more suitable basically. And if I'm not wrong, I can get the type from the array. So int 32 is the data type of the data inside this array. Now if I just change this to 0.5 step, then it will be float 64. It is taking the suitable data type for the array that is being created. Okay. Right. So all right, back to quiz. Can everyone try solving this? Use any of the method and produce this array. Please put your answer in the chat. Yeah, this array is going from -7 till 4 and it is going in steps of what? NP arrange -7 4.5. So yeah, Rajat and Ashish both have given me the answer here. So let me try. NP arrange start number is -7, end number exclusive is 4.7. So when you're using arrange, you are excluding 4.5. That is good. So in steps of 0.5, it will exclude 4.5. Therefore, it will stop at 4. Correct. Yeah. So -7, -6.5, -6, da 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 da. It goes till 4. Okay. Great. Can we try quiz number 27 now? Create an array with 20 entries, starting with number -10, ending with number 10. What is the command for that? So these quizzes are here to motivate you to choose between these two methods, which is better for which case. np.linspace -10 10 20. Yep. So I think the inclusive part is hidden in the English here, right? It says starting with the number -10 and ending with the number 10. So if you read this English carefully, what it is saying is include -10 and 10, correct? So that directly tells me use linspace, right? So -10, 10, and of course it will produce 20 numbers. Okay. Quiz number 28. I'll sort of solve this and show you step by step. Okay, you can follow along. Define a function that takes in the first term and the common difference of an arithmetic progression and prints the first 10 terms of the sequence. Do we all remember arithmetic progression from school? Yeah, do we remember? It's that, you know, arithmetic progression, right? It has a number, then you keep adding the same number again and again. That thing is called common difference and this thing is called first term. Okay. So I need to define, create, let's say create AP, right? And I need to return the arithmetic progression. And what it has to take? It has to take in first term, suppose A, and it has to take in common difference B. All right. And it has to print the first n terms of the sequence. So I have to also take the character n. Okay, not character, number. So I need to take in first term common difference, and I need to take in this variable n. Okay, first n terms of this arithmetic progression. Now, which method can I use for this? Right, I would think of using np.arrange. Correct. So suppose I do ap equal to np.arrange and just directly I say adn. What do you think is going to happen? So just go back to arrange. Okay, just go back to arrange. Go to a simple version of arrange. So if what you can see here is it's excluding the last number. Correct, it's excluding the last number. And we know, if you remember arithmetic progression formula, that is a plus what? N minus 1d. Correct. So if I use np.arrange, first it is going to print a. Okay, then it is going to print what? A plus d, then it is going to print a plus 2d, and so on. And it is going to exclude what? That is the question. It is going to exclude, sorry, this should be the other way around. This common difference should come here, and this is where what we should put. Should we put a plus nd? Should we put a plus n minus 1d? Which one we should put here? So notice that this a plus n minus 1d, if you remember, that is the nth term, and I need to produce the first n term, which means what I should put inside here is a plus nd. Okay, because this will be excluded. Here if I put a plus n minus 1d, then the nth term will be excluded, so I cannot put that. Okay, so I'll define this function. Now this is my start number, this is my stop number exclusive, and this is my common difference. So suppose suppose I do something. Suppose this is my arithmetic progression. 3 plus 4 is 7, 7 plus 4 is 11, so on. Right. Suppose this arithmetic progression, and I want to produce the first 10 numbers. Now this function, if I take create AP, the first term is 3, the common difference is 4, and I want 10 numbers. D is not defined. Okay, and times D. So now it's producing 3, 7, 11, 15, 19, whatever. So is it producing 10 numbers? Just check shape. Yes, it is producing 10 numbers. Hope this is clear. Okay. There's a more challenging exercise here for you guys. Okay, it is based on, I think, arrange or linspace. I don't remember, but this is quite interesting. Okay, solve it in your free time later. All right, so now we have seen, linspace and arrange for generating these equally spaced axes, basically. Right. Many times when you're doing coding, you also require some placeholder arrays. You may have done similar things in your own domain before. Placeholder means something to start with, right? Then I can add numbers to it, then I can subtract numbers, whatever, but something to start with. So there is a very, very nice and simple method in NumPy, 2 methods, by the way, which allow you to do this. One is called zeros, one is called ones. Okay, essentially it's just producing any kind of n-dimensional array with zeros. So suppose I say np0 shape equal to 2, 2, it will produce 0, 0, 0, 0 of shape 2 by 2. Suppose I do 2 by 5, it will produce shape 2 by 5, 0, 0, 0, 0, 0, 0. Right. So whatever shape you want to give here, you give 2, 3, 4, you give 3-dimensional. It will produce the same shape with all zeros inside. Okay. So that's the zeros method. And the argument I'm passing is shape. Okay. So you can directly, just pass this value. You don't need to necessarily call the parameter name each time. You can directly pass this value. So for example, np dot zeros, 2, 5. Okay. So this is going like this. One thing to remember again is that this is a tuple. So when you do, so this is where tuple interaction becomes a bit complicated, because np.zeros is also a function. The input to a function is also in the format of a tuple, and the parameter in this case is shape of NumPy array, and we know that shape is also a tuple. So now if you don't correctly specify the shape tuple, then it will try to understand the function tuple. So here if you see these brackets, that is for the tuple of the input parameters of the function. Okay, but I want only one input parameter, and that input parameter itself is a tuple. So that is why I need to use double bracket. Okay, so these two things need to be put inside a tuple. Then it's one parameter, right? This is going to be one parameter which is taken into the parameter shape. Okay, great. So when it's not a tuple, when it's an integer, then it's okay, obviously, right? When it's an integer, it's not a problem, right? And let me also take this opportunity to show you how to write an integer as a tuple, because you can put this integer inside two brackets like this. You can also do comma with space. So typically, if you've seen in Python, one-dimensional tuples are represented as integer comma something, right? So if you do np array, and suppose I just have a one-dimensional array here, okay, 1 2 3, and I do dot shape, you must have seen this many times, right? So this is a tuple with only one dimension, right? This standard convention. So you can even use that convention here if you want, but obviously it's just much easier to just put the integer in there. Okay, what do you think np.once is going to do? It's going to produce ones, that's all, right? So whatever shape you give, it will produce ones. There are other related methods like I and identity. I will leave it for you guys to explore in your free time. Okay, and there's a very simple question here which I think you can do it yourself. Okay, great. Another set of methods which are quite useful is random number generation. Now you must be familiar with the Python, I think rand. Okay, so you can there is a package called random. Okay, this has some random numbers and things like that. What is NumPy going to do? It's going to build on that, and it's going to give a universal set of random numbers. Now I'll not go more into detail into the nature of random numbers right now. Okay, this is something that you will study later when you do probability and all of those things in the program, right? When you do probability related statistics, that time it will become more clear. But let me just show you a few methods. So this is the package within the library. So there is numpy.random. Okay, it's a module within the numpy package which is specifically designed for generation and handling of random numbers. So the way to call it is np.random, and then there are many functions inside like randint and things like that. So what do you think randint is? Randint is nothing but it produces random integers. And the parameters here, if you see, it is low equal to 1, high equal to 5, size equal to 10. What is the meaning of this? Produce 10 random integers for me, okay, between 1 and 5 excluding 5. So as you can see, it has produced 10 random integers for me between 1 and 5 excluding 5. So 1, 2, 3, 4. You just run it again, you will get different. Run it again, you will get different. And these things, again, as I told you, these are used in backend when you do things like sampling, you know, when you go to inferential statistics and things like that, you have to pick random samples from data, right? So all of these methods are inbuilt in some of the methods that you will be using there. But in the backend, it's all NumPy. Okay. So again, if you want, you can also produce negative integers. Here size equal to 1, which means from -10 to 16, produce me a random integer. But notice that the output is array only. So if you want to extract this number, then you have to do bracket 0, right? Get the first number in the array, right? And if you don't do this, you will get the array. Each time you will get array. Okay. So randint produces random integers or arrays of random integers. What does rand do? Now this is a very interesting function. It is producing between 0 and 1. So if you keep running it again and again, you will see that you are getting numbers between 0 and 1, right? And you can specify, and in fact, this thing has the parameters are essentially the sizes of each dimension. In other words, it is the shape. Okay, so here you don't need to put double bracket. Here you can directly put the shape that you want. So 2, 3. So if I do np random ran 2, 3, it gives me 2 cross 3 array with random numbers between 0 and 1. So here there is no necessity to put double bracket. Okay, so here you can see tuple object cannot be interpreted as integer. The reason for this is that the function is designed that way. Okay, so which is why I make it a point that you should all look at the documentation when you get the chance. So if you see here, it says d0, d1, dot, 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 dn. So obviously these are the sizes of the dimensions. So if you remember the image file, that is 25, 32, 3, right? So d0 is 25, d1 is 32, and then d2 will be 3, right? You don't need to put a tuple as the input in this function, which is why it's important. Now, if what was the other function? If you go to ones, here if you say, it says shape is the parameter. Here you have to give the tuple. Okay, so always make sure to check the input parameter, what is expected by the function. So anyway, so you can generate like this, random numbers between 0 and 1. So these are some common random number generators that are used, and of course a lot of the other statistical methods will build on these basic methods. Okay. Some additional statistical methods which are of use in data analysis, which we will see in much more detail when we do pandas. Here I will just give a sneak peek kind of thing, is the max and min, right? So we know what max and min is. Max and min is nothing but maximum and minimum value. So I'm just using, np.rand and np.round to create a random array. Okay, here I've created a 3-dimensional array. Notice I have used np.rand and then np.round, and I put all this together to produce random array. I can, run it again. It will give me slightly different array. And if you don't like these floating point numbers, then just round it to integers. Okay. And if you, do not like the points, the 10 point, 39 point, 57 point, if you don't like that, then just put this array result inside another array command and specify your data type. The type equal to int. This should work. Yeah. So now I have nice integer. Okay. So notice how I'm chaining commands. Okay. This is something that we have to start getting familiar with. Okay. All these bit by commands are very tiny commands, right? It is what's it doing? Rounding, random, collapsing. All of these are very precise pinpoint commands. So when you do a more holistic thing in data analysis, when you do for bigger analysis, you need to learn to chain these commands. Okay. So I've chained all these commands and produced this array here. Shape is 243. Okay. Now what will happen if I do np array.max, right? So this array np array.max. So if I do max, it is essentially giving me the maximum value, that is the maximum integer or maximum number, I should say, not integer, maximum number in the array. So in all of the numbers, 99 is maximum. Minimum is 1. Interesting. So minimum number is 1. Notice that this maximum minimum functions are also axis wide operators. So suppose for the same array, this array, if I do np.array axis equal to 0, what happened here? And we try to interpret this. So what it has done is it has collapsed rows, but it has given me the columns which have the maximum value. In other words, and maybe this is a bit hard to see in 3 dimensions. So maybe we will go for 2 dimensions, right? So suppose I just change it to 2 dimensions. Now I have this 2 cross 3 array, and now the maximum value is 95, minimum value is 8. Okay. Now if I do maximum axis equal to 0, what is it doing? It is giving me 39, 60, 95. So it gave me 3 columns. In other words, it has collapsed the rows. But how did it collapse the rows? It retained the row which contained the maximum value in the whole array. So 95 is the maximum value in the complete array. So it's essentially, it is giving me the row which contained that maximum value. And how am I saying that it has collapsed the rows? Of course it has collapsed the rows. which is why you're getting 3 columns, 39, 60, 95. So what it has done is it has seen this row, it has seen this row, and it has checked these 2 rows and selected that, okay, 95, the maximum value is in this row. So it has collapsed the rows and given me all 3 columns, and out of these all 3 columns you will get the maximum number 95. It gave me the row which has the maximum number. Similarly, for this, if I do axis equal to 1, what will it do? It will give me the column, right, which has the maximum value. So in this case, it is giving me 95, and here I am getting the value 59. So it is giving me 95 and 59. Okay. Now axis equal to 2, obviously this is not going to work, right? So so column wise, if you see here, I have okay, this will obviously not work, but these 2 are working, right? So when axis equal to 0, 39, 25, the maximum number is 39. 60, 59, maximum number is 60. 95 and 8, maximum number is 95. So it has collapsed these columns. And then axis equal to 1, it will check column wise. So it will check for all the columns for row 1, 39, 60, 95. The maximum value is 95 here, and that is what is retained here. And similarly here, 27, 59, 8, what is the maximum value? 59. So that is produced here. Now same thing, if I rerun my code again, suppose I have 81, 85, 11, 39, 79, 82, right? The global maximum is 85, global minimum is 11, so I have 85, I have 11. What will happen if I do axis equal to 0? Again, it will check all the rows and then collapse. So 81 and 39, what is the maximum? 81. 85 and 79, what is the maximum? 85. 11 and 82, what is the maximum? 82. So for axis equal to 0, I will get 81, 85, 82. Okay. And if I do axis equal to 1, I will get in this row, right? It will collapse the columns. So 81, 85, 11, 3 columns. Collapse using which operation? Max. So max of these is 85, and then max of these is 82. Okay, so this kind of analysis is quite important when you're asking similar questions. So previously I used the example of what is that, nationality as the columns, and maybe something like gender in the rows. So now you can ask question of which nationality or which gender is expending the most, or out of these gender which nationality is expending the most, right? That kind of analysis you can do. Now if I change this back to a 3-dimensional, it operates in exactly the same way. The only problem is that it's hard to visualize 3 dimensions, but it will give you the maximum values across each of the axes. So now if you do axis equal to 2, it will give those maximum values. Minimum is very similar. Okay, so let me go back to 2 by 3, right? So now I have these numbers here, right? And of course this is not going to work. I will comment it. Now if I do min ax equal to 0, if you remember, it has to collapse the rows. So minimum 56, 4 and 1, right? 56, 4 and 1. Similarly, it has to now collapse the columns. So 37 and 1. So here you get 37 and 1. All right. This won't work because it's 2D. So I don't know why this is in here. This is not required. Anyway, so this is how maximum and minimum operator also works, and it's also a statistical method, right? We will see this in more meaningful detail when we start with pandas, because NumPy can get a little abstract with all these random numbers, which is why I've just given you some examples here, right? When we do pandas, we will do very in detail analysis of data sets and things like that, using these kind of operations and more. So finally, just some additional methods. I wouldn't say these are too important or extremely important, but again, good to know some basics methods. So we've already seen appending values and things like that, right? We have seen how to append columns to the array. We've seen how to append rows to the array. Those things we have seen. You can also concatenate arrays. So there is a specific method called concatenate. Okay, so suppose I have these 2 arrays, 1, 2, minus 4, 3, 2, minus 5. And this array is also the same. Interesting. Let me change it. Okay. 5, 3, minus 2 7 8 0. Okay. So suppose I have these two arrays. Now notice that this shape, and again, as I said, mentally or through code, always keep the shape in mind. So the shape of these two arrays is 3 by 2 3 by 2, which is obviously visible from here. Okay, 3 rows 2 columns. Now if I use this method called concatenate, what it does is it will essentially just join the array. Okay, so you can put the arrays that you want to concatenate as a tuple. So here if you see this, I have put array 1 and array 2 inside a tuple, and if you want to know more about the parameters, you can just look at the documentation. So here you can see the input arrays are supposed to be put inside a tuple, and the axis, where do you want to add. Okay, so now if I combine these two arrays along axis equal to 0, again, when you're doing sum, mean, product, max, what is happening? You're collapsing the rows. But when you're concatenating, you're doing opposite of collapse. Think of it that way, very simple. So axis equal to 0 for those methods was collapsing the rows. For concatenate, what is happening? It will expand the rows. That's all. So when I do axis equal to 0, I have 3 rows here and I have 3 rows here. Now these 3 rows will join this way, right? It will expand the rows. So 1 2 minus 4 3 2 minus 5 5 3 minus 2 7 8 0. Similarly, if I specify axis equal to 1, what will happen? Instead of collapsing, obviously it will not collapse. Collapse is something which is associated with summation, mean, aggregation type methods. When you're concatenating, it will expand. So these two arrays, now if you do axis equal to 1, it will expand the columns. So you'll get 1 2 5 3, right? 1 2 5 3 minus 4 3 minus 2 7 2 minus 5 8 0. Okay, so if you do that, this is what you get: 1 2 5 3 minus 4 3 minus 2 7 2 minus 5 8 0. And of course, if you want to save it, if you want to save the value, you need to assign to some variable, because these are not in place methods, right? Temporary output only. Okay, and then there's one interesting method I thought I should add. Again, these are slightly obscure methods which you may not use too much, which is why I've just given 1 or 2 examples here. But again, it's good to know that some of these methods exist. The split method essentially splits your array based on an index position. Okay, so here is your input array, and then there's this parameter called indices or sections. Okay, now I've specified as index 1. Okay, this just means that the first row, second row. Okay, I hope that language is clear. When I say indices or a section is 1, that is the second row. So it will split across this row. So now see, you have 1 2 5 3 as a separate array, and then you have this as another array. Okay, so I won't go more into this method or even these concatenate, right? These are, some of these are pretty obvious, so I would request the learners to explore, and some of these are very obscure, which you might explore only in case you have any free time left after doing all your basic fundamentals. Okay, so this split, for example, is quite rarely used. It's mostly not used. So I just put it as just a few additional methods to show you that it's there. Okay, now obviously if you go to the NumPy documentation, you will get all of these methods and many more methods. Okay, but throughout these 2 sessions, what we've done is we've covered all the basics and all the important methods. Specifically coming to the statistical methods, I have not gone too much into detail. I have shown you how it operates: max, min, sum, mean, product, linspace, right? I've showed you how these things operate. We will obviously explore all these statistical methods in a more meaningful setting, right? And it will be explored in greater detail when we do pandas. Right, so finally, just to close off this this whole journey into NumPy. Oh, and by the way, there is a quiz. I will leave this to you guys to do later. It's fine. I think there's a lot of quizzes for you to practice. Let's talk about finally mathematical constants. So as I told you, NumPy is this very universal mathematical package. So obviously it should have the value of the constants, right? So pi I think we all remember pi from school. What is pi? Is it 22 by 7? Yeah, can the audience tell me whether it's 22 by 7, 3.14? Okay. Okay, so we all remember pi. Great. It's an irrational number, so technically speaking it's not equal to 22 by 7. What is 180? Oh, 180 degrees. Correct, Anusha. Pi radians is equal to 180 degrees. Correct. Wonderful. Yeah, so as I told you, I have a maths background, so I got that. Anyway, so yes, NumPy, yes, 3.1415. In fact, guys, pi is irrational. Okay, so any finite decimal representation is wrong. Any ratio representation is wrong. Any finite ratio representation is wrong. There are infinite self-referencing definitions of such numbers that if you are interested, you can go Google it later. But these are irrational numbers. Now, what does NumPy do? It produces or it stores the value of these irrational numbers and mathematical constants up to some accuracy, right? Up to some precision, sorry, not accuracy. So if I just do type np.py, it is float. Okay, so it is storing pi up to, as you can see, many decimals, right? Similarly, e, do we all know the constant e in mathematics? Anyone? Have you heard of Euler constant? It's pronounced Euler, but the spelling is EULER. Okay. Do you remember e power x when you were doing the differentiation, integration, all that kind of stuff? Remember there was this function called e power x, and you differentiate e power x, you still get e power x. Yeah. So that e, that is the base. And if you remember natural logarithms, ln, the base of natural logarithm is e. Right, so that's also very important mathematical constant. So that is also stored in NumPy. So you can directly call the value of e, of pi, and things like that from NumPy. Okay, it's stored internally. And finally, I do want to talk about this thing here, np.nan. So look, null values are treated in very different ways in Python. So for example, np.nan says nan. Nan means not a number, by the way. np.nan gives you the output nan. Nan means not a number. Okay. So suppose I do plus 0. Not a number plus 0 is still not a number. Suppose I do nan plus 2. Not a number plus 2 is still not a number. In other words, whatever you do to nan, it's going to stay nan. Okay. Not a number. So that's also a constant in NumPy, by the way. So I just do type nan, it says float. Right. Type says float. If I do len, float has no len. Okay, obviously not. Float does not have any len. Okay. Suppose I put this inside a list and then say len. Okay, there is one item in the list which is not a number. Okay. So np.nan is a placeholder, right? It's your na value. Okay, na. Similarly, in Python, you also have this thing called none. So if I do type none, there's none type. Okay. And if I put none inside a list, then I try to do len, gives me 1. So there is one object inside here. Okay. And if I do len of none directly, none type does not have any length. Okay. So these are the some placeholders in Python. Why these are important? Well, when you do exploratory data analysis and things like that, when you do data processing and things like that, you will encounter many null values. Okay, it is very common. So when you take multiple sources of data, you put it together, you do some transformation, do some operation, all of that might lead to many null values. In fact, your data source itself might have many missing values. So how do you render missing values when you work in Python? So typically convention is to treat it as not a number or treat it as none. So there are a couple of important conventions which whole world uses. So it's good to know, if you see none somewhere, if you see nan somewhere, you shouldn't get confused, right? So there are some of these placeholders which are used to denote missing values, okay, which is something that you will see in later data processing, data pre-processing. Okay, I'll quickly summarize here, and I've written this down, so let me just read it. What does it say? NumPy is a library that has various subpackages. Yes, I think we can all agree it has various subpackages, random, many things. Like, in fact, if people are interested more in the math, try this subpackage. I think it is called linalg. Let me check. np dot linalg. Yeah. So there is a linalg subpackage which is linear algebra. So for example, if you remember the Euclidean distance formula, and then there is area of triangle. But first you should try without linalg. Okay, please try those homework questions and those math questions based on what you learned. Summation, broadcasting operation, all of that. Okay, try with that. Then if you want, you can explore linalg, which is also a useful sub package or sub module inside NumPy. And obviously that deals with linear algebra. So here you get direct functions for distances, for dot product, all those kinds of things. So yeah, NumPy is a library which has various sub modules and sub packages, all dealing with different fields of mathematics and statistics, right? And fitting all of this in a single session, and I believe now it's 2 sessions. So fitting all of this in 2 sessions or even in a single course is near impossible, and I think that's a fact, right? So what we need to understand is that we have been enabled and empowered to understand this package. We have been introduced to the most important and most popular objects and operations in this package from the point of view of data science, right? So now what you should think is, I understand all this, I practice all this, and once I'm good with all this, I can explore further, and I'll understand what's going on even better, right? It's a very vast package, NumPy. So here what we covered was some important basics, but as I said, you will be using familiar and unfamiliar packages and methods throughout your journey in data science, right? Unfamiliar in the sense, when you do a certain certain technique, maybe later in the program, maybe in some other topic, there may be, okay, we are using NumPy dot something. Okay, so at that point the expectation is that you are comfortable enough with how NumPy operates, and by now I think we all know how NumPy operates, right? If I make a quiz saying what is the most important aspect of NumPy array, all of you will say shape. Correct? So now we have reached that point, right? We are familiar to some good extent with these NumPy objects, so that time it will be easier for you to understand what's going on with the other methods and things like that. As I said, it is important to understand that programming language or tools are learned over multiple iterations. Overnight, I'm not going to become good with NumPy. Okay, over 1 month also, I'm not going to become a master of NumPy. Okay, it's going to take a few months, right? Which is why the program is pretty drawn out, right? So obviously, I can just teach NumPy and say do these things and blah blah blah, and call it a certificate, right? Whatever, right? No. So just to give you some perspective, I have been using NumPy and its equivalent for quite a few years now, right? So initially, my work was in MATLAB, which is different from Python, obviously. So I've been working in MATLAB, then I worked in R, and then I started with Python. Okay, now you guys have the advantage, you're starting with Python. Right? So anyway, it'll take time for mastery. So that's one thing you keep in mind. Right, so we are at this stage, we are familiar with NumPy, we know the basic operations, we will do the quizzes. Okay, we are good with NumPy, right? You keep using it more, you keep understanding what's happening throughout the program. In case you're stuck somewhere, feel free to try out GPT, right? It will give you information, it will give you advice. Just don't expect it to give you arithmetic answers, right? We saw this with an example yesterday. I think there was some addition of what was that, some transpose of array, something. It was not able to understand 1723 1273, right? So don't expect too much arithmetic results and number based results from GPT, but you can expect code, you can expect logic. Logic in the sense it will teach you how a command works, right? You can expect things like that. So GPT, of course, you can use for that. And I would also urge everyone to, if you have some minor doubts and things like that, use the upGrad discussion forum. If you have slightly more complex things, you can put it here in discussion forum. You can also go check Stack Overflow. Maybe somebody already solved the problem, right? So there are multiple resources. How many of you know Stack Overflow? I think that's the name, Stack Overflow, right? So Stack Overflow is an open forum where people post, doubts related to or issues related to coding and things like that. And I have seen that it has some good, answers from the public. So with that, I'm going to stop here. Let me go ahead and publish the poll so that you guys can give me your feedback.